1.1 Scope Section 1 General. This manual, developed by the automatic fire detection and alarm industry of the Signaling, Protection, and Communications section, provides technical information on basic fire alarm systems in common usage. This edition of the manual supersedes all prior versions of training manual on fire alarm systems. 1.2 Referenced Standards. National Electrical Manufacturers Association NEMA 50 Emergency Communications Audio Intelligibility Applications Guide. National Fire Protection Association NFPA 13 and FPA 70 and FPA 72 20071 and FPA 1012006 Standard for the Installation of Sprinkler Systems. National Electrical Code. National Fire Alarm Code. Life Safety Code SB 2010 Page 1 American National Standards Institute, Acoustical Society of America ANSI S3.41 American National Standard Audible Emergency Evacuation Signal Underwriters Laboratories UL 1971 Signaling Devices for the Hearing Impaired. Note 1. Since NFPA standards and codes are periodically revised, the year of the desired edition of the particular standard or code should be used when referencing the NFPA document involved. Two methods are in common use. One is to reference the code by stating NFPA 72-2007. The other is to refer to the 2007 edition of NFPA 72. If a particular question comes up regarding a standard or code, be sure to correctly identify which edition of the code may be at issue. All states or municipalities that have adopted NFPA codes or standards by reference do not always refer to the latest edition available. Each state or municipality may adopt the NFPA codes in whole or in part. The user should check for local amendments to the codes. 1.3 Acknowledge. To confirm that a message or signal has been received, such as by the pressing of a button or the selection of a software command. Active multiplex system. A multiplexing system in which signaling devices such as transponders are employed to transmit status signals of each initiating device or initiating device circuit within a prescribed time interval so that the lack of receipt of such signal may be interpreted as a trouble signal. Addressable device. A fire alarm system component with discrete identification that can have its status individually identified or that is used to individually control other functions. Adverse condition. Any condition occurring in a communications or transmission channel that interferes with the proper transmission or interpretation, or both, of status change or control command signals at the supervising station. Air sampling type detector. A detector that consists of a piping or tubing distribution network from the detector to the area S to be protected. An aspiration fan in the detector housing draws air from the protected. General definitions. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 Page 2 Area back to the detector through air sampling ports, piping, or tubing. At the detector, the air is analyzed for fire products. Alarm. A warning of fire danger. Alarm service. The service required following the receipt of an alarm signal. Alarm signal. A signal indicating an emergency requiring immediate action, such as a signal indicative of fire. Alarm system. A combination of compatible initiating devices, control units, and indicating appliances designed and installed to produce an alarm signal in the event of fire. Alarm verification feature. A feature of automatic fire detection and alarm systems to reduce unwanted alarms wherein smoke detectors report alarm conditions after a minimum period of time, or confirm alarm conditions within a given time period after being reset, in order to be accepted as a valid alarm initiation signal. Alert tone. An attention-getting signal to alert occupants of the pending transmission of a voice message. Analog initiating device. Sensor. An initiating device that transmits a signal indicating varying degrees of condition as contrasted with a conventional initiating device, which can only indicate an on-off condition. Annunciator. A unit containing one or more indicator lamps, alphanumeric displays, or other equivalent means in which each indication provides status information about a circuit, initiating device, condition, or location. Approved. acceptable to the authority having jurisdiction, AHJ. Authority having jurisdiction. The organization, office, or individual responsible for approving equipment, materials, an installation, or a procedure. NFPA 72 contains an annex item commenting on the definition for authority having jurisdiction as follows: A-3.2.2 Authority having jurisdiction, AHJ. The phrase, authority having jurisdiction, is used in NFPA documents in a broad manner, since jurisdictions and approval agencies vary, as do their responsibilities. Where public safety is primary, the authority having jurisdiction may be a federal, state, local, or other regional department or individual such as a fire chief, fire marshal, chief of a fire prevention bureau, labor department, or health department, building official, electrical inspector, or others having statutory authority. For insurance purposes, an insurance inspection department, rating bureau, or other insurance company representative may be the authority having jurisdiction. In many circumstances, the property owner or his or her designated agent assumes the role of the authority having jurisdiction. At government installations, the commanding officer or departmental official may be the authority having jurisdiction. Automatic extinguishing system supervisory device. A device that responds to abnormal conditions that could affect the proper operation of an automatic sprinkler system or other fire extinguishing system or suppression system including, but not limited to, control valves, pressure levels, liquid agent levels and temperatures, pump power and running, engine temperature and overspend, and room temperature. Automatic fire alarm system. A system in which all or some of the initiating device circuits are activated by automatic devices, such as fire detectors. Audible signal. An audible signal is the sound made by one or more audible notification appliances such as bells, horns, or speakers in response to the operation of an initiating device. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 3 Automatic fire detector, a device designed to detect the presence of a fire signature and to initiate a signal. For the purpose of this code, automatic fire detectors are classified as follows. Combination detector, a device that either responds to more than one of the fire phenomena or employs more than one operating principle to sense one of these phenomena. Typical examples are a combination of a heat detector with a smoke detector or a combination rate of rise and fixed temperature heat detector. This device has listings for each sensing method employed. Electrical conductivity heat detector, a line type or spot type sensing element in which resistance varies as a function of temperature. Fire gas detector, a device that detects gases produced by a fire. Fixed temperature detector, a device that responds when its operating element becomes heated to a predetermined level. Flame detector, a radiant energy sensing fire detector that detects the radiant energy emitted by a flame. Heat detector, a fire detector that senses heat produced by burning substances. Heat is the energy produced by combustion that causes substances to rise in temperature. Line type detector, a device in which detection is continuous along a path. Typical examples are rate of rise pneumatic tubing detectors, projected beam smoke detectors, and heat-sensitive cable. Multi-criteria detector, a device that contains multiple sensors that separately respond to physical stimulus such as heat, smoke, or fire gases, or employs more than one sensor to sense the same stimulus. This sensor is capable of generating only one alarm signal from the sensors employed in the design, either independently or in combination. The sensor output signal is mathematically evaluated to determine when an alarm signal is warranted. The evaluation can be performed either at the detector or at the control unit. This detector has a single listing that establishes the primary function of the detector. Multi-sensor detector, a device that contains multiple sensors that separately respond to physical stimulus such as heat, smoke, or fire gases, or employs more than one sensor to sense the same stimulus. A device capable of generating multiple alarm signals from any one of the sensors employed in the design, independently or in combination. The sensor output signals are mathematically evaluated to determine when an alarm signal is warranted. The evaluation can be performed either at the detector or at the control unit. This device has listings for each sensing method employed. Other fire detectors. Devices that detect a phenomenon other than heat, smoke, flame, or gases produced by a fire. Pneumatic rate of rise tubing heat detector, a line-type detector composed of small diameter tubing, usually copper, that is installed on the ceiling or high on the walls throughout the protected area. The tubing is terminated in a detector unit containing diaphragms and associated contacts set to actuate at a predetermined pressure. The system is sealed except for calibrated vents that compensate for normal changes in temperature. Projected beam type detector, a type of photoelectric light obscuration smoke detector wherein the beam spans the protected area. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB2-2010 page 4 Radiant Energy Sensing Fire Detector, a device that detects radiant energy, such as ultraviolet, visible, or infrared that is emitted as a product of combustion reaction and obeys the laws of optics. Rate Compensation Detector, a device that responds when the temperature of the air surrounding the device reaches a predetermined level, regardless of the rate of temperature rise. Rate of Rise Detector, a device that responds when the temperature rises at a rate exceeding a predetermined value. Smoke Detector, a device that detects visible or invisible particles of combustion. Spark Ember Detector, a radiant energy sensing fire detector that is designed to detect sparks or embers, or both. These devices are normally intended to operate in dark environments and in the infrared part of the spectrum. Spot Type Detector, a device in which the detecting element is concentrated at a particular location. Typical examples are smoke detectors, bimetallic detectors, fusible alloy. Automatic Fire Extinguishing or Suppression System Operation Detector, a device that automatically detects the operation of a fire extinguishing or suppression system by means appropriate to the system employed. Auxiliary Box, a fire alarm box that can be operated from one or more remote actuating devices. Auxiliary Fire Alarm System, a system connected to a municipal fire alarm system for transmitting a fire alarm to the Public Fire Service Communication Center. Fire alarms from an auxiliary fire alarm system are received at the Public Fire Service Communication Center on the same equipment and by the same methods as alarms transmitted manually from municipal fire alarm boxes located on streets. Local Energy Type, an auxiliary system that employs a locally completed arrangement of parts, initiating devices, relays, power supply, and associated components to automatically trip a municipal transmitter or master box over electrical circuits that are electrically isolated from the municipal system circuits. Parallel Telephone Type, an auxiliary system connected by a municipally controlled individual circuit to the protected property to interconnect the initiating devices at the protected premises and the municipal fire alarm switchboard. Shunt Auxiliary Type, an auxiliary system electrically connected to an integral part of the municipal alarm system extending the municipal circuit into the protected premises to interconnect the initiating devices, which, when operated, open the municipal circuit shunted around the trip coil of the municipal transmitter or master box, which is thereupon energized to start transmission without any assistance whatsoever from a local source of power. Average Ambient Sound Level, the root mean square, a weighted sound pressure level measured over a period of time that any person is present, or a 24-hour period, whichever time period is the lesser. Bell, a single-stroke or vibrating type audible notification appliance that has a bell tone. Bidirectional, two-way communication, communication between fire alarm system elements in which both elements participate in carrying out a task instruction. Box, fire alarm, a manually operated device used to initiate an alarm signal. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 5A. Non-coded. A manually operated device which, when operated, closes or opens one or more sets of contacts and generally locks the contacts in the operated position until the box is reset. B. Coded. A manually operated device in which the act of pulling a lever causes the transmission of not less than 3 rounds of coded alarm signals. Similar to the non-coded type, except that instead of a manually operated switch, a mechanism to rotate a code wheel is utilized. Rotation of the code wheel, in turn, causes an electrical circuit to be alternately opened and closed, or closed and opened, thus transmitting a coded alarm signal that identifies the location of the box. The code wheel is cut for the individual code to be transmitted by the device and can operate by clockwork or an electric motor. Clockwork transmitters can be pre-wound or can be wound by the pulling of the alarm lever. Usually the box is designed to repeat its code 4 times and automatically come to rest. Pre-wound transmitters must sound a trouble signal when they require rewinding. Solid-state, electronic coding devices are also used in conjunction with the fire alarm control unit to produce coded sounding of the system's audible notification appliances. Break glass fire alarm box. A fire alarm box in which it is necessary to break a special element in order to operate the box. Carrier. High-frequency electromagnetic energy that can be modulated by voice or signaling impulses. Carrier system. A means of conveying a number of channels over a single path by modulating each channel on a different carrier frequency and demodulating at the receiving point to restore the signals to their original form. Ceiling. The upper surface of a space, regardless of height. Areas with a suspended ceiling have 2 ceilings, one visible from the floor and one above the suspended ceiling. Ceiling height. The height from the continuous floor of a room to the continuous ceiling of a room or space. Ceiling surfaces. Ceiling surfaces referred to in conjunction with the locations of initiating devices are defined as follows. Beam construction. Ceilings that have solid structural or solid non-structural members projecting down from the ceiling surface more than 100 mm, 4 inches, and spaced more than 0.9 meters, 3 feet, center to center. Girder. A support for beams or joists that runs at right angles to the beams or joists. If the top of the girder is within 100 mm, 4 inches of the ceiling, the girder is a factor in determining the number of detectors and is to be considered a beam. If the top of the girder is more than 100 mm, 4 inches from the ceiling, the girder is not a factor in detector location. Central Processing Unit (CPU). An arrangement of circuitry using computer circuit techniques usually consisting of memory elements, signal processing circuitry, and a means to input and output data at very high speed. Central Station. A supervising station that is listed for Central Station service. Central Station Fire Alarm System. A system or group of systems in which the operations of circuits and devices are transmitted automatically to, recorded in, maintained by, and supervised from a listed central station having competent and experienced servers and operators who, upon receipt of a signal, take such action as required by code. Such service is to be controlled and operated by a person, firm, or corporation whose business is the furnishing, maintaining, or monitoring of supervised fire alarm systems. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 6 Central Station Service. The use of a system or a group of systems in which the operations of circuits and devices at a protected property are signaled to, recorded in, and supervised from a listed central station that has competent and experienced operators who, upon receipt of a signal, take such action as required by a code. Related activities at the protected property, such as equipment installation, inspection, testing, maintenance, and runner service are the responsibility of the central station or a listed fire alarm service local company. Central station service is controlled and operated by a person, firm, or corporation whose business is the furnishing of such contracted services or whose properties are the protected premises. Chime. A single-stroke or vibrating-type audible notification appliance that has a xylophone-type striking bar and/or tone. Circuit interface. A circuit component that interfaces initiating devices or control circuits, or both, notification appliances or circuits, or both, system control outputs, and other signaling line circuits to a signaling line circuit. Class A circuit. Class A refers to an arrangement of monitored initiating device, signaling line, or notification appliance circuits that prevents a single open or ground on the installation wiring of these circuits from causing loss of the system's intended function. Class B circuit. Class B refers to an arrangement of monitored initiating device, signaling line, or notification appliance circuits that would permit a single open or ground on the installation wiring of these circuits to cause loss of all or some of the system's intended function. Closed proprietary protocol. A protocol that is exclusive to a specific set of hardware and/or software that is often considered non-standard and is provided for commercial gains, improved features and functionality, or both. Coded. An audible or visible signal that conveys several discrete bits or units of information. Notification signal examples are numbered strokes of an impact-type appliance and numbered flashes of a visible appliance. Combination fire alarm and guard door box. A manually operated box for separately transmitting a fire alarm signal and a distinctive guard patrol or supervisory signal. Combination system. A fire alarm system whose components might be used, in whole or in part, in common with a non-fire signaling system, such as a paging system, a security system, a building automation system, or a process monitoring system. Communication channel. A pathway, circuit or other means allowing fire alarm communications to flow between fire alarm system elements. Communications protocol. A defined software instruction set that allows hardware and software to carry out tasks or instructions. Compatibility listed. A specific listing process that applies only to two-wire devices, such as smoke detectors, in which the smoke detector is listed to operate with specific control equipment. Certification. A systematic program that uses randomly selected follow-up inspections of the certificated systems installed under the program that allows the listing organization to verify that a fire alarm system complies with all the requirements of a code. A system installed under such a program is identified by the issuance of a certificate and is designated as a certificated system. Certification of personnel. A formal program of related instruction and testing as provided by a recognized organization or the authority having jurisdiction. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 7 Compatible equipment. Equipment that interfaces mechanically or electrically together as manufactured without field modification. Contiguous property. A single owner or single user protected premise on a continuous plot of ground, including any buildings thereon, that is not separated by a public thoroughfare, transportation right-of-way, property owned or used by others, or body of water not under the same ownership. Control unit. A system component that monitors inputs and controls outputs from various types of circuits connected to it. Daycare home. A building or portion of a building in which more than 3 but not more than 12 clients receive care, maintenance, and supervision by other than their relative S or legal guardians S for less than 24 hours per day. Detector. A device suitable for connection to a circuit that has a sensor that responds to a physical stimulus such as heat or smoke. Digital Alarm Communicator Receiver, DACR, a system component that accepts and displays signals from digital alarm communicator transmitters, DACTs, sent over the public switch telephone network. Digital Alarm Communicator System, DACS, a system in which signals are transmitted from a digital alarm communicator transmitter, DACT, located at the protected premises through the switch telephone network to a digital alarm communicator receiver, DACR. Digital Alarm Communicator Transmitter, DACT, a system component at the protected premises to which initiating devices or groups of devices are connected. The DACT seizes the connected telephone line, dials a pre-selected number to connect to a DACR, and transmits signals indicating a status change of the initiating device. Digital Alarm Radio Receiver, DAR, a system component composed of two subcomponents, one that receives and decodes radio signals, the other that enunciates the decoded data. These two subcomponents can be co-resident at the central station or separated by means of a data transmission channel. Digital Alarm Radio System, DARS, a system in which signals are transmitted from a digital alarm radio transmitter, DART, located at a protected premises to a radio channel to a digital alarm radio receiver, DAR. Digital Alarm Radio Transmitter, DART, a system component that is connected to or is an integral part of a digital alarm communicator transmitter, DACT, that is used to provide an alternate radio transmission channel. Display, the visual representation of output data, other than printed copy. Dual control, the use of two primary trunk facilities over separate routes or different methods to control one communications channel. Effective mask threshold, the minimum sound level at which the tone signal is audible in ambient noise. Emergency voice alarm communications, dedicated manual or automatic equipment for originating and distributing voice instructions, as well as alert and evacuation signals pertaining to a fire emergency, to the occupants of a building. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 8 Evacuation, the withdrawal of occupants from a building. Note: evacuation does not include relocation of occupants within a building. Evacuation signal, distinctive signal intended to be recognized by the occupants as requiring evacuation of the building. False alarm, a warning of fire danger when no danger is present. Fire alarm box, a manually operated device used to initiate an alarm signal. See box, fire alarm for added detail. Auxiliary box, a fire alarm box that can only be operated from one or more remote initiating devices or an auxiliary fire alarm system used to send an alarm to the public fire service communications center. Combination fire alarm and guard tour box, a manually operated box for separately transmitting a fire alarm signal and a distinctive guard patrol tour supervisory signal. Manual fire alarm box, a manually operated device used to initiate an alarm signal. Master box, a publicly accessible fire alarm box that can also be operated by one or more remote initiating devices or an auxiliary fire alarm system used to send an alarm to the public fire service communications center. Publicly accessible fire alarm box, an enclosure, accessible to the public, containing a manually operated transmitter used to send an alarm to the public fire service communications center. Fire Alarm Control Unit, FACU, formerly Fire Alarm Control Panel, a component of the fire alarm system, provided with primary and secondary power sources, that receives signals from initiating devices or other fire alarm control units, and processes these signals to determine part or all of the required fire alarm system output function. Dedicated Function Fire Alarm Control Unit, a protected premises fire alarm control unit that is intended to provide operation of a specifically identified fire safety function, such as sprinkler alarm and supervisory control unit or an elevator recall control and supervisory control unit. Master Fire Alarm Control Unit, a fire alarm control unit that serves the protected premises or portion of the protected premises as a local fire alarm control unit and accepts inputs from other fire alarm control units. Protected premises local control unit, a fire alarm control unit that serves the protected premises or a portion of the protected premises. Releasing Service Fire Alarm Control Unit, a protected premises fire alarm control unit specifically listed for releasing service. Fire alarm signal, a signal initiated by a fire alarm initiating device such as a manual fire alarm box, automatic fire detector, water flow switch, or other device whose activation is indicative of the presence of a fire or fire signature. Fire alarm system. A system or portion of a combination system that consists of components and circuits arranged to monitor and enunciate the status of fire alarm or supervisory signal initiating devices and to initiate the appropriate response to those signals. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 9 Fire alarm. Evacuation signal tone generator. A device that produces a fire alarm. Evacuation tone upon command. Fire command center. The principal attended or unattended location where the status of the detection, alarm communications, and control systems is displayed and from which the system S can be manually controlled. Fire safety function control device. The fire alarm system component that directly interfaces with the control system that controls the fire safety function. Fire safety functions. Building and fire control functions that are intended to increase the level of life safety for occupants or to control the spread of harmful effects of fire. Fire warden. A building staff member or a tenant trained to perform assigned duties in the event of a fire emergency. Fixed temperature detector. A device that responds when its operating element becomes heated to a predetermined level. Gateway. A device that is used in the transmission of serial data, digital or analog, from the fire alarm control unit to other building system control units, equipment, or networks and/or from other building system control units to the fire alarm control unit. Guard signal. A supervisory signal monitoring the performance of guard patrols. Guard tour reporting station. A device that is manually or automatically initiated to indicate the route being followed and the timing of a guard tour. Initiating device. A system component that originates transmission of a change of state condition, such as a smoke detector, manual fire alarm box, or supervisory switch. Initiating device circuit. A circuit to which automatic or manual initiating devices are connected where the signal received does not identify the individual device operated. Ionization smoke detection. See smoke detection. Labeled. Equipment or materials to which has been attached a label, symbol, or other identifying mark of an organization acceptable to the authority having jurisdiction that conducts product evaluation and maintains periodic inspection of production of labeled equipment or materials, and by whose labeling the manufacturer indicates compliance with appropriate standards or performance in a specified manner. Note: UL classified label means that the product was tested to specific conditions on products shown in the classified label file card. Leg facility. The portion of a communications channel that connects not more than one protected premises to a primary or secondary trunk facility. The leg facility includes the portion of the signal transmission circuit from its point of connection with a trunk facility to the point where it is terminated within the protected premises at one or more transponders. Line fault isolators. A device designed to disconnect itself along with its associated wiring whenever a short circuit occurs on its supporting circuit. Depending on the wiring scheme employed, a greater level of system operability can be maintained using line fault isolators should a short circuit condition develop. Line type detector. A device in which detection is continuous along a path. Typical examples are rate of rise pneumatic tubing detectors, projected beam smoke detectors, and heat-sensitive cable. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 10 listed equipment, materials, or services included in a list published by an organization acceptable to the authority having jurisdiction that conducts evaluations of products or services, and that maintains periodic inspection of production of listed equipment or materials or periodic evaluation of services, and whose listing states either that the equipment, material, or service meets identified standards or has been tested and found suitable for a specified purpose. NFPA 72 contains an annex item commenting on the definition as follows: A.3.2.5 listed The means for identifying listed equipment may vary for each organization concerned with product evaluation, some of which do not recognize equipment as listed unless it is also labeled. The authority having jurisdiction should utilize the system employed by the listing organization to identify a listed product. Loss of power. The reduction of available voltage at the load below the point at which equipment cannot function as designed. Low power radio transmitter. Any device that communicates with associated control receiving equipment by low power radio signals. Maintenance. 1. Repair service, including periodic inspections and tests, required to keep the fire alarm system and its component parts in an operative condition at all times, together with replacement of the system or its components when they become undependable or inoperable for any reason. 2. Work, including, but not limited to, repair, replacement, and service, performed to ensure that equipment operates properly. Manual fire alarm box. A manually operated device used to initiate an alarm signal. Mass notification system. A system used to provide information and instructions to people in a building, area, site, or other space. Master box. A municipal fire alarm box that can also be operated by remote means. Master control unit panel. A control unit that serves the protected premises or portion of the protected multiplex. Communication of two or more fire alarm signals conditions over a common single communications channel. Multiplexing. A signaling method characterized by simultaneous or sequential transmission, or both, and reception of multiple signals on a signaling line circuit, a transmission channel, or communications channel, including means for positively identifying each signal. Municipal fire alarm box, street box, an enclosure containing a manually operated transmitter used to send an alarm to the public fire service communications center. Municipal fire alarm system, a system of alarm initiating devices, receiving equipment, and connecting circuits, other than a public telephone network used to transmit alarms from street locations to the public fire service communications center. Network. A system of interconnected fire alarm components and/or associated circuits. Loading capacity. The maximum number of discrete elements of fire alarm systems permitted to be used in a particular configuration. Premises as a local control unit and accepts inputs from other fire alarm control units. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 11 Network node. A critical element of an fire alarm network where communications lines, channels, pathways interface. Non-coded. An audible or visible signal conveying one discrete bit of information. Non-contiguous property. An owner or user protected premises where two or more protected premises, controlled by the same owner or user, are separated by a public thoroughfare, body of water, transportation right-of-way, or property owned or used by others. Audible notification appliance. A notification appliance that alerts by the sense of hearing. Olfactory notification appliance. A notification appliance that alerts by the sense of smell. Tactile notification appliance. A notification appliance that alerts by the sense of touch or vibration. Textual audible notification appliance. A notification appliance that conveys a stream of audible information. An example of a textual audible appliance is a speaker that reproduces a voice message. Textual visible notification appliance. A notification appliance that conveys a stream of visible information, alphanumeric or pictorial message. Textual visible notification appliances provide temporary text, permanent text, or symbols. Textual visible notification appliances include, but are not limited to, annunciators, monitors, cathode ray tubes, CRTs, displays, printers. Visible notification appliance. A notification appliance that alerts by the sense of sight. Notification appliance circuit. A circuit or path directly connected to a notification appliance. Notification zone. An area covered by notification appliances that are activated simultaneously. Open non-proprietary protocol. a protocol that is widely known, understood, and/or otherwise implemented that is most often considered a standard and is usually provided for non-commercial gains. Plant one or more buildings under the same ownership or control on a single property. Positive alarm sequence, an automatic sequence that results in an alarm signal, even when manually delayed for investigation, unless the system is reset. Power supply, a source of electrical operating power, including the circuits and terminations connecting it to the dependent system components. Non-restorable initiating device, a device whose sensing element is destroyed or becomes non-resettable in the process of its operation. Notification appliance, a fire alarm system component such as a bell, horn, speaker, light, or text display that provides audible, tactile, or visible outputs, or any combination thereof. Nuisance alarm, any alarm caused by mechanical failure, malfunction, improper installation, or lack of proper maintenance, or any alarm activated by a cause that cannot be determined. Pathways, any conductor, optic fiber, radio carrier, or other means for transmitting fire alarm system information between two or more locations. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 12 Proprietary Supervising Station Fire Alarm System, and installation of fire alarm systems that serve contiguous and non-contiguous properties under one ownership from a proprietary supervising station located at the protected property, at which trained, competent personnel are in constant attendance. This includes the proprietary supervising station, power supplies, signal initiating devices, initiating device circuits, signal notification appliances, equipment for the automatic, permanent visual recording of signals, and equipment for initiating the operation of emergency building control services. Protected premises, the physical location protected by a fire alarm system. Protected premises, local fire alarm system, a protected premises system that sounds an alarm at the protected premises as the result of the manual operation of a fire alarm box or the operation of protection equipment or systems, such as water flowing in a sprinkler system, the discharge of carbon dioxide, the detection of smoke, or the detection of heat. Definition adopted by NFPA for NFPA 72-2002 in lieu of references to local systems. Radio Alarm Repeater Station Receiver, RARSR, a system component that receives radio signals and resides at a repeater station that is located at a remote receiving location. Radio Alarm Supervising Station Receiver, RASSR, a system component that receives data and enunciates that data at the supervising station. Radio Alarm System, RAS, a system in which signals are transmitted from a radio alarm transmitter, RAT, located at a protected premises through a radio channel to two or more radio alarm repeater station receivers, RARSR, and are enunciated by a radio alarm supervising station receiver, RASSR, located at the supervising station. Radio alarm transmitter, RAT, a system component at the protected premises to which initiating devices or groups of devices are connected that transmit signals indicating a status change of the initiating devices. Radio channel, a band of frequencies of a width sufficient to permit its use for radio communications. CNFPA 72-2002, 3.3.30, channel. Note: the width of the channel depends on the type of transmissions and the tolerance for the frequency of emission. Channels normally are allocated for radio transmission in a specified type for service by a specified transmitter. Record drawings, as built, that document the location of all devices, appliances, wiring sequences, wiring methods, and connections of the components of the fire alarm system as installed. Record of completion, a document that acknowledges the features of installation, operation, performance, service, and equipment with representation by the property owner, system installer, system supplier, service organization, and the authority having jurisdiction. Relocation, the movement of occupants from a fire zone to a safe area within the same building. Remote Supervising Station Fire Alarm System, a system installed in accordance with a code to transmit alarm, supervisory, and trouble signals from one or more protected premises to a remote location at which appropriate action is taken. Reset, a control function that attempts to return a system or device to its normal, non-alarm state. Proprietary Supervising Station, a location to which alarm or supervisory signaling devices on proprietary fire alarm systems are connected and where personnel are in attendance at all times to supervise operation and investigate signals. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 13 Secondary trunk facility, that part of a transmission channel connecting two or more, but fewer than all, leg facilities to a primary trunk facility. Shall indicates a mandatory requirement. Should indicates a recommendation or that which is advised but not required. Signaling line circuit interface, a system component that connects a signaling line circuit to any combination of initiating devices, initiating device circuits, notification appliances, notification appliance circuits, system control outputs, and other signaling line circuits. Site-specific software, software specific to the operation and configuration of a particular system. Typically, it defines the type and quantity of hardware modules, customized labels, and specific operating features of a system. Smoke detection, detecting smoke using one or more of the following methods, including but not limited to: cloud chamber smoke detection, the principle of using an air sample drawn from the protected area into a high humidity chamber combined with a lowering of chamber pressure to create an environment in which the resultant moisture in the air condenses on any smoke particles present, forming a cloud. The cloud density is measured by a photoelectric principle. The density signal is processed and used to convey an alarm condition when it meets preset criteria. Ionization smoke detection, the principle of using a small amount of radioactive material to ionize the air between two differentially charged electrodes to sense the presence of smoke particles. Smoke particles entering the ionization volume decrease the conductance of the air by reducing ion mobility. The reduced conductance signal is processed and used to convey an alarm condition when it meets preset criteria. NFPA 72 contains an annex item commenting on the definition for ionization smoke detection as follows: A.3.3.181.2 Ionization smoke detection. Ionization smoke detection is more responsive to invisible particles, smaller than 1 micron in size, produced by most flaming fires. It is somewhat less responsive to the larger particles typical of most smoldering fires. Smoke detectors utilizing the ionization principle are usually of the spot type. Photoelectric light obscuration smoke detection, the principle of using the light source and a photosensitive sensor onto which the principal portion of the source emissions is focused. When smoke particles enter the light path, some of the light is scattered and some is absorbed, thereby reducing the light reaching the receiving sensor. The light reduction signal is processed and used to convey an alarm condition when it meets preset criteria. Photoelectric light scattering smoke detection, the principle of using the light source and a photosensitive sensor arranged so that the rays from the light source do not normally fall onto the photosensitive sensor. When smoke particles enter the light path, some of the light is scattered by reflection and refraction onto the sensor. The light signal is processed and used to convey an alarm condition when it meets preset criteria. Signal, a status indication communicated by electrical or other means. Signaling line circuit, a circuit or path between any combination of circuit interfaces, control units, or transmitters over which multiple system input signals or output signals, or both, are carried. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 14 Video Image Flame Detection, VIFD, the principle of using automatic analysis of real-time video images to detect the presence of flame. Video Image Smoke Detection, VISD, the principle of using automatic analysis of real-time video images to detect the presence of smoke. Spacing, a horizontally measured dimension relating to the allowable coverage of fire detectors. Spot Type Detector, a device whose detecting element is concentrated at a particular location. Typical examples are bimetallic detectors, fusible alloy detectors, certain pneumatic rate of rise detectors, certain smoke detectors, and thermoelectric detectors. Standard audible emergency evacuation signal, a distinctive 3-pulse temporal pattern emergency evacuation signal required by NFPA 72 for all new systems installed after July 1, 1996. For a detailed description of this signal, see ANSI S3.41. Subsidiary station. A subsidiary station is a normally unattended location that is remote from the supervising station and is linked by a communications channel S to the supervising station. Interconnection of signals on one or more transmission channels from protected premises with a communications channel S to the supervising station is performed at this location. Supervising station, a facility that receives signals and at which personnel are in attendance at all times to respond to these signals. Supervisory signal, a signal indicating the need of action in connection with the supervision of guards tours, the fire suppression systems or equipment, or the maintenance features of related systems. Supervisory signal initiating device. An initiating device such as a valve supervisory switch, water level indicator, or low air pressure switch on a dry pipe sprinkler system whose change of state signals an off normal condition and its restoration to normal of a fire protection or life safety system, or a need for action in connection with guards tours, fire suppression systems or equipment, or maintenance features of related systems. Supplementary. As used in a code, supplementary refers to equipment or operations not required by a code and designated as such by the authority having jurisdiction. Temporal signal, a distinctive signal intended to be recognized by its pattern of 4 rounds of 3 in a timed sequence of events. A timed sequence of events in the 3-pulse pattern. Trouble signal, a signal initiated by the fire alarm system or device indicative of a fault in a monitored circuit or component. Two-way fire department communication system, an electrically monitored telephone system providing private voice communications capability between the command center or central control unit and designated remote locations. Phones or phone jacks can be installed at the remote locations. Unidirectional, one-way communication. Communication from a fire alarm system element in which one element provides the task instruction and other element S participate in carrying out a task instruction. Visible signal. A visible signal is the response to the operation of an initiating device by one or more direct or indirect visible notification appliances. For a direct visible signal, the sole means of notification is by direct viewing of the light source. For an indirect visible signal, the sole means of notification is by reflected light within the room. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 15 Voice intelligibility, audible voice information that is distinguishable and understandable. CNEMA SB50 Emergency Communications Audio Intelligibility Applications Guide. Water flow switch. An assembly approved for the service and so constructed and installed that any flow of water from a sprinkler system equal to or greater than that from a single automatic sprinkler head will result in activation of this switch and subsequently indicate an alarm condition. Wireless control unit. A component that transmits, receives, and processes wireless signals. Wireless initiating device. Any initiating device that communicates with an associated control receiving equipment using a wireless transmission path. Wireless protection system. A system or a part of a system that can transmit and receive signals without the aid of wire. It may consist of a wireless control unit, wireless initiating devices, notification appliances, wireless repeater, etc. Wireless repeater, a component used to relay signals between wireless receivers or wireless control units, or both. Zone, A defined area within the protected premises. A zone can define an area from which a signal can be received, an area to which a signal can be sent, or an area in which a form of control can be executed. Evacuation signaling zone. A discrete area of a building, bounded by smoke or fire barriers, to which occupants are intended to relocate or evacuate. Notification zone. An area covered by notification appliances that are activated simultaneously. Two point one General Section 2 Basic Fire Alarm Systems. Most fire alarm systems consist of the following basic parts: A. Control unit. B. Initiating device circuits and/or signaling line circuits. C. Notification appliance circuits. D. Power supply. E. Building fire safety control circuits. Optional. The applications of fire alarm systems can be broken down into four broad categories. A. Household fire alarm systems. B. Protected premises, local fire alarm systems. C. Supervising station fire alarm systems. 1. Central station fire alarm systems. 2. Remote supervising station fire alarm systems. 3. Proprietary supervising station fire alarm systems. D. Public fire reporting systems. 1. Auxiliary fire alarm systems, local energy type. 2. Auxiliary fire alarm systems, SHUN type. Each of these categories is defined in Section 1 of this manual. Starting with the 1993 edition of NFPA 72, the classification of local fire alarm systems was changed to protected premises fire alarm systems. The definition for protected premises systems makes it evident that the system's application has not changed from what it was when it was called a local system and is confined to the premises being protected. In NFPA 72's 2007 edition, the requirements for protected premises local fire alarm systems are in Chapter 6. Chapter 5 applies to initiating devices, and Chapter 7 to notification appliances connected to the protected premises fire alarm system. In addition to protected premises fire alarm system requirements, Chapter 8 also includes the requirements for the installation of that portion of the supervising stations covered in NFPA 72 Chapter 8 located on the protected premises. Though NFPA specified the installation requirements for the four categories of systems, the requirements of the authorities having jurisdiction must also be met. In addition, care should be taken to install equipment in accordance with manufacturer's instructions. 2.2 Control Unit. The control unit is the brain of the system. It distributes power to the system and electrically supervises its circuits. The control unit contains the logic circuits to receive signals from alarm-causing devices and transmit them to alarm notification appliances, building fire safety controls, and supplementary equipment. Depending on system design, the fire alarm signaling function may provide for one or more of the following: A. Notifying all building occupants simultaneously. B. Notifying occupants in certain portions of the building who are in immediate danger. C. Notifying key building personnel. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. D. E. 2.3 Notifying the fire department activating building fire safety control and supplementary functions during fire emergencies. Notification methods when non-coded, master-coded, and march time-coded systems are used. The standard audible emergency evacuation, temporal code 3, is also used. Coded, selective coded, and zone-coded systems, if also required to notify occupants of the need to vacate the premises, should have their coded location signals followed by the standard audible emergency evacuation signals. Note: the following descriptions describe the traditional audible signals that were sounded by systems before NFPA 72 required the standard audible emergency evacuation signal be used whenever the intent of the audible alarm signal was to notify the occupants of the building of the need to evacuate, leave the building. 2.3.1 Non-coded system. A non-coded system is one in which a fire alarm signal is continuously transmitted. The fire alarm notification appliances may be manually or automatically restored to normal, silenced. Note: restoring the system to normal, following a fire alarm, may involve the resetting of detection devices and the control unit, and is implied in all of the following descriptions. 2.3.2 Zone Non-coded System Example Control Unit SB2 to 2010 page 17. A zone non-coded system provides for the continuous transmission of the fire alarm signal as in a non-coded system, but also incorporates an annunciator or display to indicate the exact area, or zone, of the building from which the alarm originated. Before continuing with the description of a variety of coded system types, it should be recognized that coded systems use a coding device, which may be electromechanical or electronic in nature, to produce a predetermined, patterned, and distinctive fire alarm signal. The coding mechanism may be integral to the control unit, or it may be employed in a coded manual fire alarm box, or it may be used in a coded transmitter device to which are connected non-coded manual and automatic fire detection devices. 2.3.3 Coded System. A coded system is one in which not less than 3 rounds of coded fire alarm signals are transmitted, after which the fire alarm system may be manually or automatically restored to normal. Also see Selective Coded System. 2.3.4 Master Coded System. A master coded system is one in which the coding mechanism provides for the transmission of the same common coded fire alarm signal in response to the initiation of an alarm from any location in the building. Common code, e.g., 44, should be selected to produce a distinctive pulsing of the system's alarm notification appliances so that building occupants know unmistakably that a fire condition exists. 2.3.5 March Time Coded System. A march time coded system is actually a non-coded system that operates much like the master coded system, except that the coding mechanism is arranged to produce a fire alarm signal at a march time rate of approximately 120 pulses per minute. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 18. 2.3.6 Selective Coded System. A selective coded system is one in which a number of code transmitters or remotely mounted devices, or both, are used. The coding mechanism for each coded unit is systematically selected and organized to produce its own distinctive coded alarm signal identifying its location, floor or zone in the system. In this way, the sounding of a fire alarm signal notifies the building occupants of an alarm of fire and, at the same time, tells key building personnel, such as an in-house fire brigade, of the location from which the alarm was initiated. Normally, 4 rounds of the selective code are sounded. 2.3.7 Temporal Code 3 Pattern. The use of the distinctive 3-pulse temporal pattern fire alarm evacuation signal, required by NFPA 72, became effective July 1, 1996, for new systems installed after that date. According to ANSI S3.41, a temporal pattern is 1. An on-phase lasting 0.5 seconds, plus/minus sign 10%. 2. An off-phase lasting 0.5 seconds, plus/minus sign 10%, for 3 successive on periods. 3. An off-phase lasting 1.5 seconds, plus/minus sign 10%. The signal should be repeated for a period that is appropriate for the purposes of evacuation of the building, but for not less than 180 seconds. A single stroke bell or chime sounded at on intervals lasting 1 second, plus/minus sign 10%, with a 2-second plus-minus sign. 10% off interval after each third on stroke is permitted. The minimum repetition time is permitted to be manually interrupted. 2.3.8 Zone-coded system. A zone-coded system also alerts both the building occupants and key building personnel, while the audible alarms in a zone-coded system function identically to those in a selective coded system. Zone-coded systems generally are less specific about the origin of the signal. As its name implies, the signal denotes only the general area or zone from which one or more different detection devices may have initiated the alarm. 2.4 Voice Fire Alarm System. A voice fire alarm signaling system is a system that includes emergency voice alarm communication service where the notification appliances are loudspeakers and can use any recorded sound and/or live or recorded voice to direct building occupants to either evacuate the building or move to a place of safety, or provide other information about the emergency. Since the loudspeakers may reproduce any programmed sound, a basic system can emulate any of the systems described in 2.3 in addition to having the live or recorded voice capability. See 2.12.5 for additional information on emergency voice alarm communication systems. 2.5 Control Unit Operation. A fire alarm control unit may be a simple, single-zone unit providing for one alarm initiating circuit and one alarm notification circuit. However, most control units are modular in construction and are designed to accommodate multiple zones of detection and alarm notification, as well as the selection of other modular components to perform any of the system functions listed in 2.1. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 19 Example control units. Fire alarm systems must perform in an emergency. For this reason, the control unit constantly monitors, supervises the integrity of the primary, main power supply, the secondary, standby power supply, and the installation wires and the connections of the alarm initiating devices and alarm notification appliances to the initiating and notification circuits. The control unit will sound a trouble signal to alert operating personnel when a fault condition exists on any of the monitored circuits that prevents normal circuit operation. The trouble signal normally will sound to indicate any of the following types of faults: A. Loss of primary, main power. B. Loss of secondary, standby power. C. 6.3.1. Monitoring of the secondary, standby power supply was first required in the 1993 edition of NFPA 72. Note: NFPA 72 contains important exceptions to the requirement for a secondary power supply where the building is served by, and the fire alarm system is connected to, an emergency power system meeting the requirements of Articles 700, 701, or 702 of NFPA 70, National Electrical Code. C. An open and a monitored wire. D. A ground on a monitored wire or power supply output. E. Loss of an audio amplifier, microphone, tone generator, or preamplifier. F. A short across an alarm notification appliance circuit, NACG. Loss of connection between any installation wire and any alarm initiating device wire or terminal necessary to sense an alarm. H. Loss of connection between any installation wire and any alarm notification appliance wire or terminal necessary to indicate the alarm signal. Any one of the foregoing faults could interfere with the proper transmission or receipt of an automatic or manual alarm signal. The trouble signal is produced by an audible appliance, with a distinctive sound pattern. A visible indication, light LED, may also be provided. Depending upon control unit design, a trouble signal silencing switch may be provided. If the trouble can be silenced in this manner, a trouble light must be provided that is to remain lighted until the cause of the trouble is corrected. The audible trouble signal will sound if the switch is in the silence position and no trouble exists. In addition to the foregoing trouble indications, the control unit may contain additional trouble lamps that pinpoint the particular circuits or zones that are in trouble. Trouble conditions also may be recorded on a system printer, if used. It should be noted here that the requirement for a fire alarm system to monitor, supervise the integrity of its interconnecting wiring and connections is the major difference between the installation of a fire alarm system and the installation of the more general wiring in a building. Most problems encountered during the startup of copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 20. A fire alarm system are traced to errors made in the installation, wiring or connections, or both. It is, therefore, extremely important to follow the manufacturer's published instructions when installing a fire alarm system. Caution should be used in interpretation of the term supplementary. By definition, such circuits are not a required part of the fire alarm systems and must be so specifically declared by the authority having jurisdiction for the project involved. More detailed information on circuits and functions that must be monitored can be found in the National Electrical Code, NFPA 70 Article 760, and NFPA 72 for the type of system being installed. The control unit is usually installed in a listed surface or flush wall-mounted cabinet, a floor-mounted cabinet, or a desk-type console, depending upon the size of the system and the manufacturer. Normally, a lock is provided for security of the controls. 2.6 Performance of circuits. Though Class A and Class B classifications are most commonly used, they are only defined by their performance under single open or ground fault conditions. Short-circuit faults are not recognized by the control unit as faults, except for notification apply on circuits. Though short-circuit faults occur less frequently than opens or grounds, their effect can be more catastrophic. A short circuit on an initiating device circuit most often results in a nuisance alarm, which can have serious consequences when certain types of occupancies are unnecessarily evacuated. Of even greater consequences are short-circuit faults on signaling line and notification apply on circuits, which could in certain instances cause the loss of the entire system. For this reason, NFPA 72 classifies these circuits both as Class A or B as well as by styles, which also take short-circuit faults into consideration. NFPA 72 divides initiating device circuits into styles A through E, signaling line circuits into styles 0.5 through 7 and notification apply on circuits into styles W through Z. These two methods of classification are not incompatible and either can be used independently or combined to specify the desired performance of a circuit. Where the requirements of Class A and Class B circuits are adequate to cover the desired performance, they can be used alone to specify the desired performance. Where it is desired to require more stringent circuit performance characteristics, the two classification methods can be combined to specify the required performance, e.g., by specifying Class A, Style 7, or simply a Style 7 where it is required that a system continue to be capable of reporting an alarm condition even with a short on a signaling line circuit. NFPA 72 also requires that all styles of Class A circuits using physical conductors, metallic or optical fiber, be installed such that the outgoing and return conductors exiting from and returning to the control unit, respectively, are routed separately. The outgoing and return conductors are not permitted to be run in the same cable assembly, multi-conductor cable, enclosure, or raceway. There are at least 3 exceptions to this requirement in NFPA 72, so the appropriate exception should be referenced for the exact requirements. 2.7 Initiating device circuits, IDCS. Initiating device circuits are those to which automatic or manual initiating devices are connected. The commonly used types of circuits are 2.7.1 Two-wire using normally open contact initiating devices and an end-of-line device. This is termed a Class B circuit. See Figure 2.1. Monitoring of this circuit is accomplished by passing a low current through the installation wires and end-of-line device. Any interruption of this current will cause the trouble signal to operate. Copyright 2010 by the National Electrical Manufacturers Association. The initiating devices are connected across 2 of the wires. After the last device, these 2 wires are brought back directly to the control unit. If the wires terminate within the control unit with only an end-of-line device, the circuit is termed Class B. Additional circuitry may be provided which allows Class A operation of the circuit despite the occurrence of a single open or ground in that circuit. With this additional circuitry, the circuit is termed a Class A circuit. See Figure 2.3. It may be necessary to refer to the manufacturer's operating manual or drawings to determine whether a circuit is a Class A wired, Class B, or a true Class A circuit. Figure 2.3 Class A initiating device circuit using normally open contacts 2.8 signaling line circuits. Signaling line circuit is defined in Section 1. The most common usage of a signaling line circuit is an addressable or analog addressable circuit or communications line between panels. In referring to the definition, one should also read the definitions for positive non-interfering and successive (PNIS) system and shunt non-interfering (SNI) coded system. All of the definitions have the common intent to describe signaling from a multiple number of individually identifiable initiating devices or circuits over a common circuit or path, compared with the definition of an initiating device circuit, which deals with a single identifiable circuit of initiating devices. This is an important concept in fire alarm signaling. In zone systems, where initiating devices are connected to a system via initiating device circuits, loss of an initiating device circuit would prevent signals from being received from only one group of initiating devices. Where individual initiating devices or initiating device circuits are connected to a system via a signaling line circuit, loss of the signaling line circuit would prevent signals from being received from many, if not all, the initiating devices. For this reason, system designers may specify a different style or level of installation reliability between the two different types of circuits, such as styles 4, 6, or 7. A system arranged as described in the first paragraph of 2.8 can be simply implemented on a loop consisting of a single wire pair. Code wheels with a specific code for each device would revolve and interrupt the wire SB2 to 2010 page 21 Figure 2.1 Class B initiating device circuit using normally open initiating contacts. 2.7.2 Class A wired circuit using normally open contact initiating devices. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 22 Path of the signaling line circuit by opening the line or by shunting its end-of-line device in accordance with its code. 2.9 Notification appliance circuits. Notification appliance circuits are circuits that can operate a variety of appliances such as bells, horns, chimes, buzzers, or speakers to signal an alarm condition. Visible appliances such as strobe or other lamp types also may be used on these circuits. Appliances used in fire alarm systems should be listed for such use. Common notification circuit types can be as follows. 2.9.1 Parallel circuits. These circuits normally have polarized alarm notification appliances wired in parallel and equipped with diodes in series with each coil and an end-of-line device. Monitoring current is allowed to flow in one direction through the end-of-line device to monitor the circuit wires. Upon reversal of the current flow, the notification appliances are allowed to sound or flash. NFPA 72 requires that line shorts also be monitored. Upon interruption of the monitoring current, or wire-to-wire short, an audible trouble signal is sounded. See Figure 2.5. Figure 2.5 Parallel notification appliance circuit using polarized notification appliances. Parallel circuits are also used for speaker circuits when the fire alarm control unit is designed to sound electronic tones or to play recorded or live voice messages. The most common method of monitoring used in this application is to have a capacitor in series with each speaker transformer coil so as to block any DC voltage used for monitoring. The audible signal, being AC, will pass through the capacitor and energize the speaker coil. See Figure 2.6. Figure 2.6 Parallel notification appliance circuit using capacitor-coupled speakers. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. 2.10 Power supplies. Fire alarm systems are required to have at least two independent and reliable sources of electrical power. a primary main power supply to operate the system, and a secondary standby power supply to operate the system in the event of failure of the primary main power supply. The secondary power supply must be able to sound trouble signals in the event of loss of the primary main power. NFPA 72 does not permit a primary battery, dry cells to be used for this purpose. Power supplies are more fully described in NFPA 72 4.4.1 2002 edition. 2.11 Supplementary circuits and devices. Supplementary circuits and devices may consist of the following: A. Annunciators. B. Notification appliances not required by an FPA 72C. Printers. D. Certain power-down functions. These circuits may be unmonitored, provided the equipment to which they are connected is not required by an FPA 72. They are designated as supplementary by the authority having jurisdiction, and a short circuit, an open, or a ground fault in the circuit does not prevent the required operation of the fire alarm system. 2.12 Types of control systems. 2.12.1 Protected premises. Local fire alarm system, Chapter 6, and FPA 72. A protected premises fire alarm system provides alarm signal indications at the protected premises and, in addition, it provides for one or more of the following: A. Manual fire alarm service. B. Automatic fire alarm service. C. Automatic detection of water flow or abnormal conditions in sprinkler systems or other fire suppression systems. D. Automatic discharge or abnormal condition reporting of other fire suppression systems such as CO2, halon, or alternate gaseous or dry chemical suppressants. C. Activation of alarm notification appliances. F. Guard tour supervisory service. G. Industrial process monitoring. H. Activation of fire safety functions. I. Activation of off-premises signals. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 23. SB 2/2010 page 24. Example Control Unit 2.12.2 Auxiliary Fire Alarm System, Chapter 9, and FPA 72. There are two types of auxiliary systems in common use. One is a local energy auxiliary alarm system that uses power from the protected premises system to automatically trip a transmitter or master box connected to the municipal public fire service communication system. See Figure 2.7. Figure 2.7 Local energy type auxiliary alarm system. The other is a shunt auxiliary alarm system with isolated closed contacts controlled by the protected premises fire alarm system or alarm initiating devices connected directly to a municipal transmitter or master box. Power from the municipal system loop is used to trip the transmitter. See Figure 2.8. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. The remote supervising station system provides an alternative method of connecting a fire alarm system directly to the municipal communications center over lines other than the municipal fire alarm circuits. Usually this means a separate pair of telephone wires, leased from the telephone company, between each property and the municipal communications center. Permission must be obtained from the authority having jurisdiction. Generally, these are non-coded systems, which use individual pilot lights, LEDs, to identify the property from where the alarm originated. See Figures 2.9a and 2.9b. Figure 2.9a Remote Supervising Station Fire Alarm System Schematic Diagram. Figure 2.9b Remote Supervising Station Fire Alarm System Riser Diagram. There are two types of non-coded remote supervising station systems. The first is the reverse polarity type, in which power for the leased circuit originates at the fire alarm control unit on the protected premises. In the SB 2/2010 page 25 Figure 2.8 Shunt type auxiliary alarm system 2.12.3 Remote supervising station fire alarm system, Chapter 8, and FPA 72. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 26 Event of an alarm, the polarity of the leased line is reversed. energizing the polarized relay in the receiving equipment at the Municipal Communications Center, thereby lighting a light identifying the location from which the alarm originated and actuating an alarm-sounding appliance. The leased lines between the system at the protected premises and the Municipal Communications Center are electrically monitored for integrity. The second type utilizes differential current relays or equivalent circuits. A small monitoring current flows through the leased wire in an end-of-line resistor at the protected premises. When an alarm is actuated, a relay contact shorts out the end-of-line resistor, causing the current to increase sufficiently to pick up or energize an alarm relay at the Municipal Communications Center. This, in turn, lights a pilot light and sounds the alarm appliance. The system can be powered from either end of the line. For either system, the receiving unit at the Municipal Communications Center can be a single station or a multiple station receiver with separate alarm indicators and individual pairs of wires for each protected property. Because of the small gauge of the leased circuit wire, loop resistance is an important factor and must be determined prior to specifying the equipment. Long lines having up to 4,000 ohms loop resistance, for example, may require different equipment or power supplies, or both, than for a circuit of only 500 ohms loop resistance. 2.12.4 Proprietary Supervising Station Fire Alarm System, Chapter 8, and FPA 72. A proprietary supervising station fire alarm system serves either single or multiple contiguous or non-contiguous properties under one ownership. Trained operators are required to be in constant attendance on this type of system. The operator may alert an in-house fire brigade or the municipal fire department or both, as required by the authority having jurisdiction. All signals received by the central supervising station that show a change of status must be automatically and permanently recorded, including time and date of occurrence. 2.12.5 Emergency Voice Alarm Communications, Chapter 6, and FPA 72. Fire alarm systems with emergency voice alarm communications service are used to permit pre-recorded or live voice communications during fire and other emergencies. A one-way system permits emergency personnel to give voice instructions on either a selected or on an all-call basis via microphone and a system of loudspeakers. Its use came about with the advent of high-rise buildings and other structures where immediate evacuation of the entire building might be impractical, and the fire plan called for selected partial evacuation and/or the relocation of the building occupants from the fire-affected zones. A two-way system, using telephone or intercom techniques, permits communications between fire service personnel while investigating or fighting a fire in the building. Most two-way systems use telephones located in fire stairwells so that the fire service personnel can talk from any floor to the fire command station. These telephones are also permitted to be used by other building occupants and are frequently installed on all floors for use in emergency circumstances. A notification signal, distinctive from any other alarm or trouble signal, is required at the fire command station to indicate an off-hook, call-in condition of any telephone on the system. Emergency voice alarm communications take three basic forms. Example: Emergency Voice Communication System A system that stands alone and is manually controlled. Voice or tone signals can be selected and distributed by operator choice. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 27b. A system that is integrated into a full fire alarm system. Voice or tone signals can be selected and distributed manually or automatically. C. A system used for mass notification, which based upon the emergency response plan, can take occupant notification precedence over the fire alarm system. 2.12.6 Central Station Fire Alarm System providing central station service, Chapter 8, and FPA 72. A central station fire alarm system receives signals from alarm and supervisory signaling devices at a protected premise. Central station service is contracted by the owner or manager of the protected premise. The response to the signals is determined by the type of service provided. A central station fire alarm system provides the following service elements: A. Water flow alarm. Dispatch fire department upon the activation of a sprinkler system. B. Sprinkler supervisory. Notify building maintenance personnel when a fire sprinkler system has been disabled by actions such as closing of valve. C. Guards tour supervisory. Notify building personnel when the guards tour is not completed on time. D. Manual fire alarm. Dispatch the fire department when the manual fire alarm box has been activated. E. Automatic fire alarm detection. Dispatch the fire department when an automatic fire detector goes into alarm. F. Retransmission of alarms to the fire department. G. Associated record keeping and reporting. H. Runner service. Each service element of central station service must be provided under a contract with a listed central station or a listed fire alarm service local company that subcontracts the monitoring, retransmission, and associated record keeping to a listed central station. The central station shall indicate that all the requirements of the fire alarm code are met by either certification or placarding through a third-party verification service. 2.12.7 Fire Safety Control Functions. NFPA 72 contains many requirements that apply to safety control equipment within the protected premises that do not detect fires or notify people but do make the premises safer for the occupants from the fire's effects. In most cases, these control functions are required by local codes and ordinances and, therefore, must have their installation wires monitored for integrity, with very few exceptions, and meet the requirements found in Chapter 6 of NFPA 72. The exceptions are limited to those devices that operate in a fail-safe manner during a circuit fault to release the control device, e.g., door release. Elevator recall service is functionally described in detail in NFPA 72, Chapter 6, not only for monitoring for integrity but also for sequence of operation. In general, because of the many methods used by various manufacturers of the control devices, no specific wiring is detailed in this manual except where the wiring makes the function required clearer. Generally, the interface is a normally open or normally closed auxiliary relay contact on one of the fire alarm system components. However, NFPA 72 also permits data transfer to control devices or systems through listed data ports. NFPA 72 also requires that the control device be listed as being compatible with the control unit so as to not interfere with the control unit's operation. It is extremely important that the installer follow the manufacturer's published installation instructions. 2.12.8 Combination Systems. NFPA 72 permits combination systems where the fire alarm system shares components, equipment, and circuitry with non-fire alarm systems. The non-fire alarm equipment does not have to be listed for fire alarm use where it does not perform a required fire alarm system function. Where common wiring is used between, copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 28. The fire alarm and non-fire alarm systems, short circuits, open circuits, or grounds on the shared wiring or within the non-fire alarm equipment must not prevent normal operation of the fire alarm system. Some fire alarm systems are monitored by computers that may not be a part of the fire alarm system itself. In such cases, the removal, replacement, failure, or maintenance procedure of any hardware, software, or circuit not required to perform the fire alarm system functions should not cause loss of any of the fire alarm functions. These requirements do not apply where the computer equipment, software, and circuitry are all listed for the purpose. 2.12.9 Interconnected fire alarm control units. Many fire alarm installations are provided as extensions to existing systems requiring the installer to interconnect control unit wiring of two or more fire alarm systems built by the same or different manufacturers. For many years, there have been questions about the propriety of such installations since the NFPA 72 standards basically describes single systems. NFPA 72 now specifically permits such installations but, by detailing the requirements that must be met when two or more control units are interconnected, requires the interconnected control units to function as a single system. 3.1 General Section 3 Fire Alarm System Concept Section 2 dealt with basic fire alarm systems. This included the function of the control unit, the designations of different types of systems, and details of various approaches to wiring initiating device and notification appliance circuits. All of the systems described in their installation techniques could be supported by control units using simple relay circuitry. Small systems may still be best implemented that way. New technology has given manufacturers the opportunity to apply computer-controlled devices that can work much faster and perform more work to make people in a building safer from the danger of fire. While most intelligent or smart detectors or sensors are defined in Section 1, Section 3 introduces these subjects so that those responsible for the physical installation of fire alarm systems that use these advanced technologies will have a working understanding of the concepts involved. 3.2 Multiplexing or networking. In addition to reading the definition for multiplexing in Section 1, the reader should also review the information in 2.8. It can be seen that essentially, the term multiplexing is a term used to describe the operation of a signaling line circuit and usually identifies the systems that use computer techniques for data handling and communications between components on the installation wiring circuits. Understanding the basic principles of a multiplex system in terms of old technology can help in the understanding of today's new technology multiplex systems. It bridges the gap between fire alarm system concepts with which one may be familiar and the hardware used in implementing multiplex systems. The specifier and installer should be familiar with the concepts of the signaling methodology and not necessarily the complex details of the new types of circuits involved. Similarly, the installer should understand that where this manual makes reference to installation wiring in various types of physical wire circuits, such circuits may actually be considered to be signaling pathways that could be either radio or optical fiber pathways. With the new technologies, no physical pathway needs to exist for initiating and signaling line circuits, and reference to the physical wire pathways is purely to facilitate the understanding of the signaling techniques involved. Most systems now being installed still use physical wire paths. The new technology systems, for the most part, use the basic capabilities of computers and borrow heavily from telephone signaling methods. An important function that multiplex systems have added to fire alarm signaling systems is the capability to construct systems that use a common signaling line circuit to gather information from many types of input devices, such as manual fire alarm boxes, fire detection devices, and supervisory devices, and distribute appropriate control action commands to output devices, such as relays and alarm notification appliances, at very high speed. Signaling technology makes use of radio signaling paths practical because it makes it possible to monitor signaling pathways with a high degree of reliability without using wires. In addition, the cost and size of components have shrunk so that it is possible to construct devices that incorporate several functions, giving rise to the proliferation of addressable and analog devices as described in subsequent paragraphs. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 29. SB2 to 2010 page 38. Basic multiplex system block diagram is shown in figure 3.1. The signaling line circuit can use any number of wires or other types of circuit paths. 2 to 4 wires are most common. In addition, power supply wiring may be required for the input initiating devices and output notification or control relay appliances. Figure 3.1 Basic multiplex system block diagram showing initiating device circuits connected to circuit interfaces and to a signaling line circuit. 3.3 Circuit interfaces, transponders, data gathering panels. The assembly that connects each of the initiating, notification and control circuits to the signaling line circuit is known as a circuit interface. The term transponder is also used to describe this unit. A circuit interface may have one or more initiating devices, notification appliances, or control circuits connected to it. In figure 3.1, circuit interfaces are shown connecting initiating device circuits to a signaling line circuit. As required by the definition in Section 1, Each circuit interface must have the capability of separately indicating the status of each connected initiating device circuit. All connected notification appliance circuits and control output circuits can be individually actuated and monitored by the control unit. Normally, the circuit interface is an assembly of solid-state components capable of working at high speed. The high speed permits the system to report individual alarms and other conditions in a short time, thereby making it possible for a large number of initiating devices, notification appliances and control circuits to be connected to a signaling line circuit. For proprietary supervising station systems, the maximum elapsed time from sensing a fire alarm at an initiating device until it is recorded or displayed at the proprietary supervising station may not exceed 10 seconds. Subsequent fire alarm signals must be recorded or displayed at intervals not exceeding 10 seconds even when signals other than fire alarms are being originated simultaneously. Timing is important because fire alarm standards permit monitoring of other functions within the building that may not be related to fire alarm signaling. It would not be wise to have a fire reporting system that had many non-fire alarm inputs delay the timely receipt and display of fire alarm signals. With today's components and computer techniques, the copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 31 slowest part of any system is usually a printer, if used, and the reaction time of any attendant receiving the signals. 3.4 multiplexed or networked outputs. Up to this point, we have described a multiplex or networked system that has multiple initiating circuits inputting signals from multiple locations onto the signaling line circuit and transmitting them to a control unit. Now consider that the signaling line circuit is merely a communications path. In some manner, the circuit interfaces have placed signals on the signaling line circuit to be interpreted at the control unit. Consider a computer network, where any computer can communicate with any other computer, as well as the server, and the server can communicate with any other computer on the network. At each location, there is capability for input as well as output. Similarly, circuit interfaces on a signaling line circuit can be operated in networked mode. Addressing information can be sent from a control unit on the signaling line that causes individual circuit interfaces on the same line to respond with the status of its connected initiating device circuits. Or, a circuit interface may originate the address, type of device, and status data that may be read by the control unit. The control unit may also send address and commands to notification appliance and control circuits connected to a circuit interface. On some more complex systems, data from one circuit interface may be read by all circuit interfaces and cause selective action at one or more of the circuit interfaces. Figure 3.2 shows a block diagram where both an initiating device and a notification appliance circuit are connected to the analog addressable signaling line circuit through the same circuit interface. A circuit interface can connect initiating device, alarm notification appliance, and control circuits or combinations of the three to a signaling line circuit. One major advantage of the technology is the reduction of wire installation costs. Essentially, Figure 3.2 is the same as Figure 3.1 except that some circuit interfaces are shown with output capability to actuate notification appliances or to actuate relays to perform control functions such as fan startup or shutdown, door release, etc. Figure 3.2 basic multiplex system showing notification appliance circuits also connected to circuit interfaces. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 32. Figure 3.3 is similar to Figure 3.2 with the addition of T-tap connections on the signaling line circuit that restricts its use to Class B applications. Figure 3.3 active multiplex system using T-tap connections. In most fire alarm systems, the input, initiating device circuit transmits data from initiating devices that is received by the control unit that interprets it and sends out data to specific circuit interfaces to actuate the outputs. However, on more complex systems, Using today's communications techniques, it is possible for data at any point on the signaling line circuit to be interpreted and acted upon at any circuit interface location to create a programmed output. 3.5 Addressability. If the signaling line circuit is constructed as a network, how will the data messages be routed to the proper location? This brings up the subject of addressability. Let's go back to the simple selective coded system described in 2.8. Each code wheel sends a series of pulses to the control unit so the control unit can determine which code wheel has been actuated. For example, a code wheel may send 2 pulses, pause, 1 pulse, pause, then 3 pulses. The control unit sees this as location 213. It is very much like a house number on a street so that the post office can properly deliver the mail, hence the term address. The address of the initiating device circuit sending the signal is 213. Circuitry within the control unit would have been arranged to know exactly what receipt of the coded signal 213 means. In a simple system, the digital information received could be interpreted by the control unit both for location and status. In more complex systems, there might be more digits transmitted, with some identifying the circuit reporting address and others to indicate status such as alarm, trouble, or normal, and some identifying the type of reporting device. Now let's go back to Figure 3.2 where two-way signaling is used. Each circuit interface and the control unit must be coordinated and work together so that a signal originating from any actuated initiating device can be copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 33 identified by the control unit as having originated from a device connected to that circuit interface. In a similar manner, any signals sent from the control unit must be deciphered by the proper circuit interface in a manner that permits the circuit interface to actuate the proper outputs. In some systems, it is possible for a signal transmitted by one circuit interface to be read and acted upon by some other circuit interface. The addressing techniques and system design used by the manufacturer make this possible. Another necessary signal component becomes evident when discussing addressable systems. The signals sent and received must contain more information than just an address. There must be a component in the signal transmitted by the circuit interface that not only identifies the location or address of the device, but in addition, the status condition being sensed by the reporting device. The additional signal component is also necessary when a control unit sends a signal to a circuit interface and the interface needs to take action. The circuit interface must not only be told which output to effect by its address but also what the action is to be. 3.6 Intelligent, smart circuit interfaces. If a circuit interface could be programmed to take certain actions based upon the identity, address, and status of an input signal that originates at some other circuit interface, it could then be said to be an intelligent circuit interface, and the action to be taken need not be a component of the signal sent from the originating circuit interface. Most new control units have this intelligent capability, but with the technology available today, even input and output devices can be so constructed. 3.7 Programming. Programming is a procedure that assigns meaning to the codes that instruct a system to perform certain functions. Sometime, someplace, a person sat down and programmed the equipment to take certain action upon receipt of specific signals. For example, in a simple relay circuit with 3 relays labeled A, B, and C, an electrician could wire them in such a manner that relay C would be energized only when relays A and B were both energized. In computer logic jargon, the circuit could be described as being programmed. Today, circuits are wired by commands entered into a computer from a keyboard by a programmer. They can be readily changed by the same method. The term software is applied to the finished program for a system. The basic system programming is often done by the manufacturer, but today, most systems require some programming to be done by a factory-trained technician to accommodate actual installation requirements or changes. Software is usually easier to change than physically wired hardware. a term used to describe the physical parts of a system that can be seen and felt. Often, the control unit software package is described by two related terms: system software and configuration software. System software controls the operation of the control unit and all of its subsystems, is the same for all control units regardless of the particular installation, and may not be changed by the installer. Configuration software is used by the installer to wire the system components together as described above. Together, system software and configuration software make up the complete functionality of the control unit. 3.8 Addressable devices. Suppose a manufacturer, taking advantage of the small solid-state components available to him, was to build a smoke detector and, in the same device, includes a circuit that performed the circuit interface function. He would have an initiating device that would be capable of being installed directly on signaling line circuits, since each initiating device could be individually identified at the control unit. Such a device is known in the industry as an addressable device. It must be compatible with the other system devices and the control unit so that the whole system can function as required. The addressable devices do not have to be limited to smoke detectors. They may be other initiating devices such as heat detectors, sprinkler water flow alarm switches, manual fire alarm boxes, etc. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 34. The manufacturer may also incorporate an output device, such as a relay, into a single assembly with an initiating device. He could arrange the electronics such that the relay is actuated only when its associated initiating device is in the alarm state. Or, the relay could be controlled by data put on the signaling line circuit from some other system component on the signaling line circuit. The combined functional device would still be referred to as an addressable device. 3.9 Multiplexing technology. Remember, functionally, the signals passed back and forth in a multiplex fire alarm system permit the system to identify the type of device reporting, its address, which is usually mapped to its physical location in the building, and status. But, in the case of outputs, the signals must direct action commands to specific locations. There are several different methods, protocols used by manufacturers to place their multiplex signals on a signaling line circuit. Probably no two manufacturers use the same protocol. It is beyond the scope of this manual to go into any of these in detail. To understand the concept of a basic multiplex system, one could examine the operation of the simple touch-tone, push-button telephone used in the United States. The user of a telephone pushes the keypad buttons in a sequence identifying the number being called. Using time division multiplexing, this identifies to the system the first, second, third, fourth, and so on, digits of the address he is dialing. Not only must the sequence of the digits be known, but also their value, which is signaled to the system by the tones sent on the line when the buttons are pushed. This is called frequency division multiplexing. So the telephone uses both time division and frequency division multiplexing. Many multiplex systems place a tone on the signaling line and then shift the tone in accordance with some particular code. Here again, digital or alpha characters can be sequentially represented and decoded by various pieces of equipment along the signaling line circuit as required to perform the system functions. Other systems may use the length of a particular tone as having some significance, such as a quantitative value. It can be seen that the signals on these multiplex signaling line circuits cannot be received and interpreted without special compatible equipment designed for that purpose on the particular system involved. 3.10 Active multiplex. Today's multiplex systems use what the industry refers to as active multiplex. Each reporting point in the system is required to send its status signal at periodic intervals. The lack of receipt of at least an OK or normal signal from a reporting point is interpreted by the control unit as an abnormal condition for the reporting point. This contrasts greatly from the old mechanical systems where a spring-wound transmitter could be bound up and unable to send an alarm signal and not cause this to be indicated by a trouble signal. It is this feature of the active multiplex systems that in some instances permits signaling line circuits to be T-tapped. Referring to Figure 3.3, it can be seen that if each reporting point is required to send an OK signal to the control unit, all the signal paths are monitored for integrity even though T-taps are used in the interconnecting signaling paths. However, the installer of a system must not assume all multiplex signaling line circuits may be T-tapped. It depends on the type of system being installed and the part of NFPA 72 that states the requirements. Two systems using equipment that looks physically identical may use different signaling techniques, protocols, and require different wiring methods. No assumptions should be made by the installer. Always follow the manufacturer's published installation instructions. While it is relatively easy to depict fire alarm system installation wiring, or even imagine that the signaling paths could be optical fiber cables or radio waves, it is not easy to visualize the actual signal itself in today's new technology systems. Specialized test equipment can be used for this purpose. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. 3.11 Digital signaling. Older systems using mechanical code wheels interrupting or connecting wire paths could have their signal made visible with a simple lamp connection, or audible with bells or horns. These older coding systems use digital information such as in the code 213 in the earlier example. Today's systems also use digital information to indicate a particular reporting device's address, location, type, status, or other data. However, they do so at high speed and normally cannot be interpreted by human observers without specialized equipment to capture the data and put it into humanly interpretable form. The digital data can be imposed on a hardwired signaling path by varying the amplitude of current flow, by imposing audible or inaudible frequencies, by varying the length of pulses, by imposing multiple tones with a separate tone for each digit 09, by shifting frequency of a tone, or other techniques or combinations of the above. Any of the methods used for encoding a signal onto a hardwire signaling path can generally also be used in one form or another on optical fiber cable and radio signaling paths. 3.12 Analog sensors. Now that the subject of digital signaling has been introduced, a whole new concept in automatic fire detection can more easily be understood. Heretofore, fire detection has been primarily an on-off type of function. Normally a contact or its equivalent closed and initiated a signal indicative of a fire condition. This could be a manual fire alarm box, smoke or heat detector, sprinkler water flow switch, or any other device capable of detecting a fire condition. Now, with the advent of economical components and the power of digital signaling unleashed, it is possible for fire-detecting sensors to signal how much heat, temperature, or how much smoke, % obscuration, is being sensed by a detection device. Such devices are known as analog sensors because they measure and transmit how much of the physical phenomenon caused by the fire is present even though the transmission of the signal is digital. In the industry, the terms intelligent or smart devices are frequently heard when describing these sensors. There are two types of intelligent sensors. A. Sensors that only send quantitative data back to a central or sub-control unit where the alarm level decision is made. In this case, the sensing device is relatively dumb when compared to conventional smoke detectors that can both sense smoke and decide that an alarm level has been reached. B. Sensors that employ a microprocessor (CPU) that analyzes the signal for alarm and pre-alarm levels and makes decisions on when or what sort of information should be sent to the central or sub-control unit. In this type of intelligent system, both the sensor and control unit contain CPU decision makers. The benefits of this concept are that the communications on the signaling line circuit is greatly simplified and alarm reporting is still possible even if the control unit CPU fails. The use of analog sensors permits using a sophisticated signal analyzer at only one location, the control unit CPU, allowing its cost to be spread over many analog devices. Using this method, the control unit designer may be able to design faster detection into the system while at the same time greatly reducing false alarms. For example, the control unit CPU may use signals from several sensors, typically sensors that are physically adjacent or in the same enclosed protected space, in concert to determine with greater certainty that there is indeed a fire threat, and not a false alarm. A disadvantage of this method is that the control unit CPU must receive and process signals from all sensors, and therefore requires greater computing capability to complete the calculations within the time required for early warning. 3.13 Intelligent systems. Assuming computer-type circuitry is used in a control unit, the control unit designer can design an algorithm using rate of rise, sensor signal level, time delays, multiple sensor logic, or a combination of some or all these techniques. With a sophisticated control unit, a designer can provide the ability to manually or automatically, copyright sign copyright 2010 by the National Electrical Manufacturers Association, SB 2/2010 page 35. SB 2/2010 page 36. Shift the sensitivity of detectors at selected locations, depending on the time of day, day of the week, or change in occupancy. For example, sensors in a banquet room may be shifted slightly less sensitive during periods of expected heavy smoking by the occupants. Such systems are frequently referred to as intelligent systems. Intelligent systems can also monitor the buildup of contaminants in a sensor and indicate the need for maintenance, cleaning, or replacement before a sensor indicates an unwanted alarm. The algorithm used may also improve the system's ability to give warning of an incipient alarm condition at a threshold below the alarm level. While used principally for heat and smoke detection, any value that can be sensed and encoded into the signal can be sent to the control unit or any other location on a signaling line circuit where equipment capable of interpreting the signal may be located. With the proper sensing devices, this could include such things as the level of water in a tank, the temperature at or outside loading docks or in warehouses, or the actual percent closure of a sprinkler shutoff valve. Figure 3.4 shows a circuit where one of the circuit interface devices is a sensor in its own right and also monitors and reports the status of a connected subordinate initiating device circuit. It is possible that the signal transmitted by such a device can have one address for both its own sensor and the connected initiating device circuit, or it could have separate addresses for each. It depends on the product offered by the manufacturer. A single analog sensor that included monitoring capability of a separate subordinate initiating device circuit with the same address might be used in the same room with more conventional detectors without sophisticated communications capabilities. In such an application, the size of the room may not require more detailed location information than a single address. Putting all of the above together, a system designer, using computer techniques, high-speed signaling line circuits, binary, on-off, as well as analog sensing devices, and information display systems, such as color video or LCD, liquid crystal display screens and printers, can put together a very sophisticated new technology system. Figure 3.4 multiplex system where non-addressable initiating devices are connected to an addressable initiating device that includes circuit interface. Not all such systems are implemented with large-scale computers or even the well-known personal computer. The small size and extraordinary power of the microprocessor and its support chips make possible economical systems in very small packages. If the information to the operator can be displayed on an copyright sign copyright 2010 by the National Electrical Manufacturers Association, SB 2/2010 page 37. Alphanumeric indicators such as used on a hand calculator, and a large number of audible or visible alarm signaling circuits are not required. A control unit connected to thousands of sensors could be constructed in very small space. 3.14 displays. Most existing systems have used individual lamp or LED type indicators. Many new systems are also using the same technique. However, Displays are available that give manufacturers the capability to display more information in an alphanumeric format. Primarily, these displays have taken three basic forms: flat-screen displays made with light-emitting diodes (LED), liquid crystal display (LCD), and cathode ray tubes (CRT). LCD units are most familiar because of their use on the faces of digital watches. For fire alarm use, they are available in a variety of numbers of characters and character sizes. Using displays, the designer can present alphanumeric data describing a reporting device and graphic data such as floor plans and building height profiles in any color the designer chooses to best communicate with the operator. 3.15 Digital Alarm Communicator Systems, DACS. The signaling technique used for remote supervising station fire alarm systems requires telephone lines between the protected premises and the remote receiving point. These physical wires are becoming less and less available. The telephone service companies have steadily been converting to optical fiber cable and radio communication links that cannot be used to carry the DC current required by the method described in 2.18.3. A new fire alarm system component called a digital alarm communicator has been employed to overcome the application problem of the disappearing physical copper paths. A digital alarm communicator system consists of one or more digital alarm communicator transmitters, DACT, and at least one digital alarm communicator receiver, DACR, all of which are defined in Section 1. The DACTs are designed to connect to the standard public switch telephone networks. The DACT units send appropriate coded signals to a remote receiving location and are designed to automatically dial up the particular receiving station to which they are to report. Since they are designed to use the public switch telephone network, the signals will go through whatever type of signaling path the telephone company puts in place for its normal voice communication services. A DACT protecting a particular area can send an alarm signal to any location that can be reached by a voice telephone circuit. A simple DACS could consist of a single DACT connected to a switch network telephone line reporting to a DACR anywhere in the world. The single DACT could be monitoring fire detection devices directly or be connected to a fire alarm system. Section 4 Initiating Devices 4.1 Manual and Automatic Alarm Initiating Devices. Initiating devices for fire alarm systems are either manual fire alarm boxes or automatic detectors and are used to initiate an alarm on a fire alarm system. 4.2 Manual fire alarm boxes. Manual fire alarm boxes may be of the following types: 1. Non-coded or coded, 2. Pre-signal or general alarm, 3. Break glass or non-break glass, and 4. Single action or double action. Mounting according to NFPA 101, 2006 9.6.2.6 Surface Semi, Flush Flush 4.2.1 Non-coded fire alarm boxes. A non-coded manual fire alarm box contains a normally open or closed switch that is housed within a distinctive enclosure. The device may be surface, semi-flush, or flush-mounted. Once actuated, the fire alarm box contacts transfer and are maintained until some specific resetting of the fire alarm box restores the unit to normal. Contact and circuit arrangements may vary to provide a number of functions simultaneously. 4.2.2 Coded fire alarm boxes. Coded fire alarm boxes contain a mechanically or electrically driven motor that, when activated, turns a code wheel, causing contacts to momentarily open or close to reproduce the code of the fire alarm box. The fire alarm box is required to repeat its code a minimum of 3 times. Contact and circuit arrangements may vary to provide a number of functions simultaneously. Electronic devices may be used to produce the same effect. 4.2.3 Pre-signal fire alarm boxes. Pre-signal fire alarm boxes initially cause alarm signals to sound only in specific areas. Actuation of a key switch on the fire alarm box or the control unit will cause an evacuation signal to sound. 4.2.4 General Alarm Fire Alarm Boxes. A general alarm fire alarm box, the most common, when actuated, causes evacuation signals to sound immediately. 4.2.5 Break glass fire alarm boxes. The term break glass is applied to both non-coded and coded fire alarm boxes where the actuation of the device to cause an alarm requires the initial action of breaking a glass or other breakable element. Fire alarm boxes without this feature are classified as non-break glass. See Figure 4.1. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. Figure 4.1 Break glass fire alarm box. 4.2.6 Single action fire alarm box is a fire alarm box that initiates an alarm as the result of a single action by the user. The required action usually is breaking a glass element only or actuating a lever or other movable part of the station. See Figure 4.2. Figure 4.2 Single Action Fire Alarm Box SB2 to 2010 page 39. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 40. 4.2.7 Double Action Fire Alarm Box is a fire alarm box that initiates an alarm as a result of two actions taken by the user. The operation of such a station nominally requires the user to break a glass, push a lever, open a door, or lift a cover in order to gain access to a switch or lever that must then be operated in order to initiate an alarm. See Figure 4.3. The required double action tends to discourage accidental or deliberately malicious nuisance alarms. Figure 4.3 Double Action Fire Alarm Box. 4.3 Automatic Alarm Initiating Devices. Automatic alarm initiating devices may be actuated by various physical phenomena that may be present as the result of a fire. These factors may be direct effects such as heat, smoke, flame radiation, or combinations of these effects. Devices sensing these direct effects of fire are generally referred to as automatic fire detectors. Automatic initiation may also be accomplished as the result of detecting flow of water in a sprinkler pipe, either by a vane deflected by the water or a pressure-operated switch mounted on a sprinkler system dry pipe valve. In addition, pressure switches may be mounted on fixed fire suppression systems that suppress fires by releasing agents such as clean agent, halon substitutes, carbon dioxide, dry chemicals, or foam. These devices are generally referred to by their direct function, i.e., flow switch, pressure switch, and so forth. 4.3.1 Classification of automatic fire detectors. 4.3.1.1 By combustion product detected. A. Heat detector. A device that detects abnormally high temperature or rate of temperature rise. B. Smoke detector. A device that detects airborne particles of combustion. The past and the future. C. Flame detector. A device that detects the infrared, ultraviolet, or visible radiation produced by a fire. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. 4.3.1.2 By physical arrangement of detector. A. Line type detector. A device in which detection is continuous along its length. Typical examples are rate of rise pneumatic tubing detectors, projected beam smoke detectors, video smoke detection, and heat-sensitive cable. Example detector. B. Spot type detector. A device whose detecting element is concentrated at a particular location. Typical examples are bimetallic heat detectors, fusible alloy heat detectors, certain pneumatic rate of rise heat detectors, certain smoke detectors, flame detectors, and thermoelectric heat detectors. C. Duct smoke detector. A duct smoke detector uses the velocity pressure drop across sampling tubes located in an airstream to move air through a smoke detector. A spot type detector with a velocity shield, if required, is also available for direct insertion into a duct. D. Air sampling. Aspirating type detector. A sampling type detector consists of a distribution of piping or tubing from the detector unit to the areas or zones to be protected. An air pump draws air from the protected area back to the detector through the air sampling ports in the piping or tubing. At the detector, the air is analyzed for combustion products. Air sampling detectors can be arranged to sequentially sample and analyze air from multiple zones. 4.3.1.3 by operating modes. A non-restorable detector, a device whose sensing element is designed to be destroyed or becomes non-resettable by the process of detecting a fire. B restorable detector, a device whose sensing element is not ordinarily destroyed by the process of detecting heat. Restoration may be manual or automatic if the sensing element is not damaged by exposure to fire. C. Latching detector, a device that when it detects the presence of fire smoke electrically locks itself in the alarm condition. Typically only the removal of power will restore the detector to normal, assuming the source that caused the alarm has been eliminated. SB 2/2010 page 41, copyright sign, copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 42D. Non-latching detector, a device that when it detects the presence of fire smoke remains in the alarm condition until the alarm condition is no longer sensed, at which point the detector will automatically restore. 4.3.2 Heat sensing fire detectors. 4.3.2.1 Operating principles. 4.3.2.2 Fixed temperature detector. A fixed temperature detector is a device that will respond when its operating element becomes heated to a predetermined temperature level. See Figure 4.4. A bimetallic, snap-action disc, fixed temperature detector. Snap-action disc is in the raised center portion of the device. Figure 4.4 Fixed temperature detector. 4.3.2.2.1 Thermal lag. When a fixed temperature device operates, the temperature of the surrounding air will always be higher than the operating temperature of the device itself. This difference between the operating temperature of the device and the actual air temperature is commonly referred to as thermal lag, and is a function of the rate at which the temperature is increasing in the detector versus the air temperature. 4.3.2.2.2 Typical examples of fixed temperature sensing elements. A bimetallic, a sensing element composed of two metals having different coefficients of thermal expansion arranged so that the element will be deflected in one direction when heated and in the opposite direction when cooled. B. Electrical conductivity, a sensing element composed of an electrical resistor, thermistor, whose resistance varies as a function of temperature. See Figure 4.5. Copyright sign, copyright 2010 by the National Electrical Manufacturers Association. C. Fusible alloy, a sensing element of a special composition, eutectic metal that melts rapidly at the rated temperature. It is employed to restrain operation of an electrical contact until the point of fusion is reached. Once activated, the detector will indicate by dropping the disc from the bottom of the detector, or leaving a hole in the detector where the special composition eutectic metal was. D. Heat-sensitive cable, a line-type device whose sensing element comprises, in one type, two current-carrying wires separated by a heat-sensitive insulation that softens at the rated temperature, thus allowing the wires to make electrical contact. In another type, a single wire is centered in a metallic tube and the intervening space is filled with a substance that, at a critical temperature, becomes conductive, thus establishing electrical contact between the tube and the wire. See Figure 4.6. E. Electronic fixed temperature sensor, a spot-type heat detector that uses the electronics in the head to monitor a thermocouple. The thermocouple will transmit to the electronics the air temperature near the sensor. Once the thermocouple reaches the maximum temperature rating of the detector, The detector electronics generates an alarm and illuminates its internal LED to indicate the detector in alarm. Figure 4.6 Heat-sensitive cable 4.3.2.3 Rate compensation detector. This is a device that will respond when the temperature of the air surrounding the device reaches a predetermined level regardless of the rate of temperature rise. See Figure 4.7. SB2 to 2010 page 43 Figure 4.5 Electrical conductivity sensing element, copyright sign copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 44 Figure 4.7 Schematic of rate compensation detector. A typical example is a spot-type detector with a tubular casing of a metal that tends to expand lengthwise as it is heated, and an associated contact mechanism that will close at a certain point in the elongation process. A second metallic element inside the tube exerts an opposing force on the contacts, tending to hold them open. The forces are balanced in such a way that on a slow rate of temperature rise, there is more time for heat to penetrate to the inner element, which therefore inhibits contact closure until the total device has been heated to its rated temperature level. However, on a fast rate of temperature rise, there is not as much time for heat to penetrate to the inner element, which, therefore, exerts less of an inhibiting effect, so that contact closure is obtained when the total device has been heated to a lower level. This, in effect, compensates for thermal lag. 4.3.2.4 Rate of rise detector. A rate of rise detector is a device that will respond when the temperature rises at a rate exceeding a predetermined amount, usually 15 degrees Fahrenheit per minute. Typical examples of rate of rise detectors are a spot-type rate of rise detector, a device consisting of an air chamber, diaphragm, contacts, and compensating vent in a single enclosure. The principle of operation is the same as that described under B below. Some spot-type rate of rise detectors also incorporate an element using eutectic solder that is arranged to melt at a fixed temperature and cause contacts to close. These detectors are referred to as fixed temperature and rate of rise detectors and combine the two principles of operation in a single unit. See Figure 4.9. B. Electronic fixed rate of rise temperature sensor, a spot-type heat detector that uses the electronics in the head to monitor a temperature-sensitive sensor, usually a thermocouple or negative temperature coefficient resistor, NTC. The sensor will transmit to the electronics the air temperature surrounding it. Once the sensor reaches the maximum temperature rating of the detector or the electronics has determined that the sensor has its temperature rise greater than 15 degrees in 1 minute, it goes into alarm and illuminates its internal LED to indicate the detector in alarm. C. Pneumatic rate of rise tubing, a line-type detector comprising small diameter tubing, usually copper, which is installed on the ceiling or high on the walls throughout the protected area. The tubing is terminated in a detector unit, containing diaphragms and associated contacts set to actuate at a predetermined pressure. The system is sealed except for calibrated vents that compensate for normal changes in ambient temperature. See Figure 4.8. Copyright sign copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 45 Figure 4.8 Pneumatic rate of rise tubing Figure 4.9 Combination spot type rate of rise and fixed temperature detector 4.3.3 Smoke sensing fire detectors. For additional information on the proper use of smoke sensing fire detectors, see the following two publications available from the National Electrical Manufacturers Association. Guide for proper use of system smoke detectors. Guide for proper use of smoke detectors in duct applications 4.3.3.1 Classification of detectors by operating principles 4.3.3.1.1 Ionization smoke detectors. Smoke detectors utilizing the ionization principle are usually of the spot type. An ionization smoke detector has a small amount of radioactive material that ionizes the air in the sensing chamber, thus rendering it conductive and permitting a current flow through the air between two charged electrodes. This gives the sensing chamber an effective electrical conductance. When smoke particles enter the ionization area, they decrease the conductance of the air by attaching themselves to the ions, causing a reduction in mobility. When the conductance is less than a predetermined level, the detector responds. See Figure 410. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 46 Figure 410 Current flow through ionization detector sensing chamber 4.3.3.1.2 Photoelectric light obscuration smoke detectors utilizing the photoelectric light obscuration principle consist of a light source that is projected onto a photosensitive device. Smoke particles between the light source and the photosensitive device reduce the light reaching the device, causing the detector to respond. A projected beam smoke detector is a line-type light obscuration smoke detector where the light beam is projected across the area to be protected. See Figure 411. Figure 411 Projected beam smoke detector 4.3.3.1.3 Photoelectric light scattering smoke detectors utilizing the photoelectric light scattering principle are usually of the spot type. They contain a light source and a photosensitive device so arranged that light rays do not normally fall onto the photosensitive device. When smoke particles enter the light path, light strikes the particles and is scattered onto the photosensitive device, causing the detector to respond. See Figure 412. Figure 412 Photoelectric light scattering detector, copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. 4.3.3.1.4 Combination smoke detectors can use multi-criteria or multi-sensors to determine alarm threshold. With the photoelectric light scattering smoke sensor, you can add heat detection, ion smoke detection, and/or CO detection. The heat addition confirms the fire by sensing the amount of heat with the smoke. The ion sensor confirms another technology of smoke detection with the photoelectric light scattering detection. The CO addition ensures a fire is present by sensing the particles of CO that are generated by the fire, as CO is not generated without a source of combustion. The following are the definitions of both concepts. 4.4.4.1 Multi-criteria detector, a device that contains multiple sensors that separately respond to physical stimulus such as heat, smoke, or fire gases, or employs more than one sensor to sense the same stimulus. This sensor is capable of generating only one alarm signal from the sensors employed in the design, either independently or in combination. The sensor output signal is mathematically evaluated to determine when an alarm signal is warranted. The evaluation can be performed either at the detector or at the control unit. This detector has a single listing that establishes the primary function of the detector. Multi-sensor detector, a device that contains multiple sensors that separately respond to physical stimulus such as heat, smoke, or fire gases, or employs more than one sensor to sense the same stimulus. A device capable of generating multiple alarm signals from any one of the sensors employed in the design, independently or in combination. The sensor output signals are mathematically evaluated to determine when an alarm signal is warranted. The evaluation can be performed either at the detector or at the control unit. This device has listings for each sensing method employed. Switches on automatic fire suppression systems. Water flow switch on sprinkler systems. Another type of alarm initiating device that may be used is a sprinkler water flow switch of either the pressure or vane type. The water flow switches illustrated in Figure 413 are of the vane type and are generally used in wet pipe sprinkler systems. Operation of a sprinkler head causes water to flow in the system, moving the vane. After an adjustable retard period to compensate for water surges, the switch or transmitter connected to the fire alarm system will operate. Vane-type switches should be installed in the size and type of pipe for which they are listed. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 47. SB2 to 2010 page 48 figure 413 water flow switch on sprinkler system vane type. Water flow switches should not be used in dry pipe systems, deluge systems, or pre-action systems because the vane mechanism could be damaged by the sudden rush of water when the control valve opens. A pressure-actuated water flow switch is used on these systems. 4.4.2 Alarm switches on fire suppression systems. Fixed fire suppression systems of the FM200, halon, carbon dioxide, dry chemical, or foam type have pressure or flow switches that actuate upon operation of the suppression system. 4.4.3 Supervisory monitoring for sprinkler systems. A device arranged to supervise the operative condition of automatic sprinkler systems. 4.4.3.1 Valve supervision indicates sprinkler system water supply valve S is closed. 4.4.3.2 Pressure supervision indicates low water pressure in sprinkler system. 4.4.3.3 Fire pump supervision. Power including phase reversal, pump running, pump not in auto, pump fault, pump low fuel. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. 4.4.4 Engine-driven generator supervision. Engine or control panel trouble. Generator running, selector switch not in auto, low fuel. 4.5 Installation wiring. The primary rule of installation wiring is, follow the manufacturer's published instructions. This rule cannot be overemphasized. As noted in Section 2, the requirement for electrical monitoring of the installation wires and their connections to initiating devices makes fire alarm system wiring very different from general wiring. A manufacturer's installation instruction covers wiring and connections. The wiring is run a specific way because of the monitoring requirements. Any variance from the manufacturer's drawings might cause a portion of a circuit to be unmonitored and, if an open or short occurred, prevent the circuit from performing its intended function, and possibly lead to loss of life, without prior warning. There are enough exceptions to the rules that an installer should not presume one particular system must be wired in the same manner as a similar system worked on previously. It is possible that hardware that appears to be identical in two different buildings can be wired different. This may be because one building may have used a device that was required by an authority having jurisdiction and the other building used a similar appearing device that was considered supplementary to a required fire alarm system. In fire alarm signaling systems, installation wiring for supplementary equipment is not required to be monitored. However, a set of rules requires that an open, short, or ground on such supplementary equipment wiring should not affect any function of the required system. Since there are at least a dozen accepted variations to wire installation monitoring, and not all may apply to every job, how is the installer to interpret the requirements? He uses the primary rule of installation wiring: follow the manufacturer's published instructions. Fire alarm system installation drawings take two forms. One form is where the manufacturer of the control unit or a qualified installer creates an installation wiring diagram for a particular building. The other form is where a manufacturer of the control unit or other components in the system furnishes typical installation drawings. An installer who uses the typical drawings has responsibility for applying the typical drawings in accordance with local code requirements. The manufacturer's drawings will show how the unit is to be connected into a system. However, how to interconnect devices on the same floor but served by a different riser may not always be shown. Nor may subtle differences about supplementary equipment installation wiring be shown. Generally, installers using typical drawings should be well qualified in fire alarm system installation requirements or be under the direct supervision of someone who is well qualified, such as certified to NICET Level 2 or Level 3. For initiating devices, figures 415 and 416 show incorrectly connected devices. Figures 414 and 417 show them correctly connected. In both cases, they will operate correctly for alarm purposes. However, note that in figures 415 and 416, the device could become disconnected from the monitored installation wires without disturbing the monitored circuit. In figures 414 and in 417, None of the connections can be broken without breaking the monitored circuit. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 49. SB 2/2010 page 50. Normally open contact initiating device. Figure 414 initiating devices. Correctly wired normally open contact initiating device. Figure 415 initiating devices. Incorrectly wired. Figure 416 pigtail connections. Incorrect wiring method. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. The installer should note that in Figure 417, the manufacturer's pigtail wires on either circuit side of the device are very likely Y connected within the device and would seem to be a contradiction to the requirements. However, this is not true because the monitoring requirements apply to the connections made at time of installation. The manufacturing connections are made under controlled conditions with skilled technicians, usually soldered, and inspected. In addition, approved devices are subject to quality control procedures acceptable to the testing authority. Another approach for showing the difference between incorrect and correct wiring methods is shown in figures 418 and 419. These are shown to illustrate the effect the correct wiring method can have on the number of wires in the riser. This also illustrates the expense that could be incurred to correct a faulty installation. Figure 418 incorrect wiring method for multi-riser initiating device. Circuit SB 2/2010 page 51. Figure 417 pigtail connections. Correct wiring method. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 52. The figures used show simple initiating devices. A minimum of 4 connections should be made to each device. Some initiating devices, such as smoke detectors, may also require a power connection that also requires 4 additional connections. Some smoke detectors have relays built in for additional functions. Depending on the application, another 4 connections may be required for the relay contacts. To show all the variations of connections to smoke detectors is beyond the scope of this manual. The installer need not be fully knowledgeable of all the ramifications of wiring requirements because of monitoring, but should be aware of them as they relate to why manufacturers or other system suppliers show their wiring the way they do. As this section began, we restate the primary rule of installation wiring. Follow the manufacturer's published instructions. Figure 419 correct wiring method for multi-riser initiating device. Circuit 4.6 circuit styles. Circuit classes. For conventional IDC, initiating device circuit, typical initiation circuits are wired in either Class B, Style B or Class A. Style D. Today's way of indicating the type of circuit is to speak in terms of circuit style. The older panels and technicians speak of class of circuit. Class B. Style B is a circuit that includes one initiation device or more wired series parallel with an end-of-line device, typically a resistor. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 53. Should an open occur between the fire alarm control unit and the end-of-line device, everything past the open toward the end-of-line resistor will not generate an alarm. Everything before the open will operate. During this open condition without any alarms, the panel shall indicate trouble condition. Should a single ground fault occur on this circuit or any other circuit, all devices must operate during an alarm condition. The panel should indicate a ground fault trouble indication. Figure 420 correct wiring method for Class A circuit. Class A. Style D is a circuit that includes one initiation device or more wired series parallel with the end of the wiring returning to the control unit or module. Should an open occur between the FACU and the return wires, everything past the open toward the FACU will generate an alarm. Everything before the open will also operate. During this open condition without any alarms, the panel shall indicate trouble condition. Should a single ground fault occur on this circuit or any other circuit, all devices must operate during an alarm condition. The panel should indicate a ground fault trouble indication. 5.1 General Section 5 Notification Appliances. Notification appliances provide audible and/or visible notification of an alarm condition to building occupants. There are several types of alarm notification appliances. A. Audible alarm notification appliances. B. Visible alarm notification appliances. C. Visible alarm notification annunciators. D. Audible visible combination alarm notification appliances. Alarm notification appliances should be installed in the protected premises in accordance with local codes, architect's plans, requirements of authorities having jurisdiction, the manufacturer's published instructions, and the basic requirements of the NFPA standards as they apply to the installation. 5.2 Alarm notification appliances. All audible and visible alarm notification appliances are required by an FPA 72 to be installed on monitored circuits. In addition to the general description of monitoring for integrity requirements discussed in Section 2, a wire-to-wire short on an alarm notification appliance installation wiring circuit must sound a trouble signal. There are some exceptions. One is a circuit to an alarm notification appliance installed in the same room as the control unit where the wires are installed in conduit or are equivalently protected against mechanical damage. Another is where the appliance is installed for a supplementary purpose. An example might be when an audible and/or visible appliance is mounted adjacent to a manual station to deter false alarms rather than to indicate a need for evacuation. 5.3 Audible alarm notification appliances. 5.3.1 Bells. Bells may be used for fire alarm signals where their sound is distinctive and will not be confused with similar audible signals used for other purposes. Bells may be of the single-stroke or vibrating type. Single-stroke bells are used to provide audible coded signals. Vibrating types are used primarily for non-coded, continuous, or temporal sounding applications, but they also may be used to provide coded audible signals. Bells may be provided with 4-inch through 12-inch gongs in 2-inch increments. The 6 and 10-inch sizes are the most commonly used. Bells with 4-inch gongs are usually reserved for use as trouble signals. Generally, the larger the diameter of the gongs, the lower the frequency and the louder the audible signal, expressed in terms of decibels, dBA. Bells are usually of the underdome type and can be mounted on standard conduit boxes. Wind bells must be concealed, recessed, and/or mounted flush with the wall. Special boxes and grills are necessary. 5.3.2 Horns. Horns are provided for applications that require louder or more distinctive signals, or both. Care should be exercised to see that circuits are electrically compatible when powering both types of notification appliances. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 55. Horns are usually of the continuous vibrating type and may be used to provide either coded, non-coded, or temporal audible alarm signals. They may be of the surface, grill, flush, semi-flush, single projector, double projector, or trumpet type. In very noisy areas, resonating, air-powered, or motor-driven horns are sometimes used because of their inherently high decibel output. Resonating horns can be operated on alternating or direct current, produce a loud piercing tone, and coded, non-coded, or temporal operation can be provided. Air-powered horns which use valves that are controlled by electrical solenoids powered by alternating or direct current may be utilized. Either coded or non-coded operation can be provided. Motor-driven horns are not practical for providing coded output signals and are more widely used for continuous signals. They are particularly effective under rolling conditions where power is periodically applied and removed to vary the motor speed and the sound pitch. 5.3.3 Chimes. Chimes are soft-toned appliances. They are normally used in applications where panic or other undesirable actions might result from the use of loud audible alarm signals. Their use is especially adaptable to such areas as nurses' stations and hospitals to alert only authorized personnel. 5.3.4 Buzzers. Buzzers are generally used for trouble signals, rather than alarm signals. They are primarily intended to provide a continuous sound and are seldom used for coded signals. 5.3.5 Sirens are usually limited to outdoor applications but are sometimes used in extremely noisy indoor areas. Sirens are motor-driven or electronic appliances and may be either alternating or direct current operated. They are not very practical for use as coded audible signals. 5.3.6 Speakers are frequently used as alarm notification appliances. Since they reproduce electronic signals, they can be made to sound like any mechanical signaling appliance and have the capability of reproducing unique sounds that are not practical on mechanical appliances. In addition, they may be used to give live or recorded voice instructions. Speakers are either direct radiating cone or of the compression driver and horn type. Speakers are generally operated from audio amplifiers delivering standard output line levels of 70.7 or 25 volt RMS. The speakers are driven by an electronic tone generator, microphone, tape player, or voice synthesizer and an electronic audio amplifier. Two types of audio amplifier are in wide use: A. Integral, that type in which the tone generator, amplifier, and speaker are enclosed in a common housing. B. Remote, that type in which the speaker is energized from a remotely located tone generator, microphone, tape player, and/or voice synthesizer and amplifier. 5.3.7 Electronic alarms. Many audible alarm notification appliances now use electronic circuitry to drive compact piezo-ceramic transducers or speakers to produce the sounds of conventional horns, bells, chimes, buzzers, or sirens. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 56. These electronic alarms are usually more compact and more efficient than conventional electromechanical designs and may include the ability to change the sound selection or sound level to better fit the application. 5.4 Visible alarm notification appliances. Visible alarm notification appliances may be used alone or in conjunction with audible alarm notification appliances. Visible alarm notification appliances can be effective in high-noise areas, where the hearing impaired are to be alerted, or where attention to the light unit can provide additional information. In most applications, visible alarm notification appliances are most effective when used in a flashing mode. For this reason, NFPA 72 requires the flashing. The flashing cannot exceed 2 flashes per second nor be slower than 1 flash every second. Synchronized flashing is important to persons with photosensitive epilepsy. Flashing strobes out of sync in a visual line of sight could cause a reaction in this section of society. Early systems used incandescent lamp flashing. The effect was accomplished by periodically interrupting current to the appliance, using the strobe technique, or any combination of these methods. However, the maximum pulse duration shall not exceed 0.2 seconds with a maximum duty cycle of 40%. One method of determining compliance with current NFPA 72 requirements for any visible alarm notification appliance is that the product be listed by Underwriters Laboratories in accordance with UL 1971 signaling devices for the hearing impaired. Visible alarm notification appliances must be clear or nominally white and shall not exceed 1000 candela in effective intensity. 5.5 Combination audible visible notification appliances. The audible and visible functions can be combined in one unit to produce both sound and light from a single appliance. For example, the sounder can be a horn, bell, or speaker. The light portion is generally a xenon strobe, meeting the requirements of UL 1971. Advantages of the combined signals are: A. The visible signal identifies the particular audible alarm appliance that is operating. B. The visible signal produces a recognizable alarm when the audible signal may be obscured by an ambient noise level. C. Persons having impaired hearing can see the visible portion of the alarm signals. The combined signals are available in several voltages up to line voltage. 24-volt DC units are the most prevalent. Polarized versions facilitate circuit integrity monitoring. 2 or 4 wire connected types permit application of either a common or separate power supply, or where it is desired to have the visible signals continue to operate after the audible signal is silenced. 5.5.1 Visible annunciators. Annunciators can be used with either coded or zone non-coded systems to provide indication of the initiating device or zone from which the alarm originated. 5.5.2 Lamp annunciators and lamp annunciators. The devices, zones, or areas from which alarms originate are indicated by the lighting of lamps or light-emitting diodes, LEDs. A. Lamp annunciators may be provided with different colored lenses, usually red for alarm, amber for trouble, and green or white for power-on indications. B. Backlighted annunciators are used to light up information on a window or to provide illumination for a graphic annunciator. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 57C. Graphic annunciators have lamps located in a map or floor plan to provide an easier means of identifying the particular device, area, or zone affected. The area from which the alarm has been initiated can be indicated by a bullseye-type lamp located within the area or by backlighting the entire affected area or zone. 5.5.3 Drop-type annunciators. Drop-type annunciators use a target that drops in front of a window when the target coil is energized, or energized for supervisory annunciation. The target remains down until the annunciator is reset manually, thus providing a simple means of lock-in annunciation. An advantage of this type of annunciator is its low power consumption requirements. Except for the monitored application, it uses power only momentarily when operated. Drop-type annunciators are no longer in common use on new installations. 5.5.4 Incandescent lamp. Incandescent lamp alarm annunciators are single or dual lamp. 5.5.5 Solid-state lamp. Solid-state luminous appliances have become the most prevalent because of high reliability, relatively low current rating, and availability in various colors. A light-emitting diode (LED) lamp is an example. These are inherently low-current appliances adaptable to solid-state energizing circuits. Annunciator panel and indicating lamps that formerly used incandescent lamps have been replaced by solid-state lamps. 5.5.6 Fluorescent lamp. Fluorescent lamps are used primarily as sources of distributed or diffused backlighting and continuous warning signals that, when activated, convey a printed warning or direction message. Because of complex starting circuits and relatively low brilliance, fluorescent signal appliances are not used in coded or flashing warning applications. Items of this type are typically exit signs, which are flashed to indicate evacuation. 5.6 Permanent recorders. Permanent recorders are used on fire alarm systems as a means to indicate the type and location of an alarm as well as to provide a permanent record of the time and date an alarm occurred. As an indicator of the location of an alarm, a recorder that creates a hard copy record performs the same function as a lamp annunciator. In many systems, the recorder may be used to record a trouble condition and other events that are related to the fire alarm system. Typically, these might indicate the activation of alarm notification appliances, fan shutdown, door closings, or other building fire safety functions that may have taken place either automatically or because of operator actions. 5.6.1 Punch registers. Punch registers follow coded current pulses to either imprint or punch the code on a paper tape. During the receipt of the signal, the time and date is printed automatically on the tape by the timestamp. The paper tape is on a reel. Usually, the used portion of the tape is stored on a motor-driven take-up reel. 5.6.2 Print recorders. Print recorders have replaced punch recorders almost entirely in today's fire alarm systems. Upgrades and extension or retrofit of older systems are likely to replace the mechanical punch recorder with an electronically operated printer. New systems, using microprocessor or mini-computer technology, or both, will have a wide variety of electronic printers. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 58. Print recorders range from small hand-size units similar to those found on small printing calculators up to large, sophisticated, high-speed printers found on major computing systems. Where no other visual means of indicating an alarm is provided, proprietary fire alarm systems require two printers, one of which is reserved for fire alarm signals. 5.6.3 Timestamps. Timestamps can be used with punch registers and print recorders. They provide an accurate record of the time and date of receipt of a signal. They are usually automatically operated when an alarm signal is received. Most new installations using print recorders generate the time and date electronically and do not use separate timestamps. 5.7 Installation wiring. Section 6 of this manual stated the primary rule of installation wiring as, follow the manufacturer's published instructions. It is repeated here again because this rule cannot be overemphasized. The monitoring requirements that affect wire counts and types of connections on notification appliance circuits are identical to those for initiating device circuits. All that was said in Section 6 on installation wiring applies and is not repeated here. The reader, therefore, is referred to 6.4. The only difference would be in the internal construction of the connected components. Initiating devices are essentially normally open contact switches or their electronic equivalent. Notification appliances are power-using devices. The wire counts and method of connections are identical to the diagrams in Section 2 of this manual. Figures 5.1, 5.2, and 5.3 illustrate this equivalency and no further discussion on these points is required. Figure 5.1 Incorrect installation wiring method for a notification appliance circuit. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 59. Figure 5.2 Correct installation wiring method for a notification appliance circuit. Figure 5.3 Correct installation wiring method for a single notification appliance circuit with two risers. The form of alarm notification appliances has been changing over the years. Instead of traditional bells or horns, electricians are finding themselves installing electronic alarms or loudspeakers. Only listed speakers bearing labels from nationally recognized testing laboratories, indicating that the appliance is intended for fire alarm system use, should be installed on a fire alarm system. Such labeling is normally required by the authority having jurisdiction and indicates that the appliance has been tested to the temperature, humidity, and life cycle requirements considered necessary for use in life safety systems. Sometimes, speaker systems are used in what are termed combination systems, where the speakers are also used for paging. Where this is the case, the non-fire use should not interfere with the fire alarm use. In addition, a fault in the non-fire alarm system components should not cause the required fire alarm speakers to be inoperative. The audio system should be fully operational whenever it may be needed for a fire alarm emergency. When combination systems are used, it is still necessary to comply with all requirements for fire alarm installation wiring and monitoring. If an unmonitored audio system is being used to transmit a supplementary evacuation signal, it is required by NFPA 72 that the fire alarm system provide sufficient monitored alarm notification appliance circuit capability to perform all required alarm notification even if the supplementary audio system is disabled. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 60. Alarm notification circuits today are becoming quite complex. This is particularly true in high-rise buildings where each floor is usually a separate circuit. As in all fire alarm system installation wiring, the installer should follow the primary rule of installation wiring, follow the manufacturer's published instructions. Section 6 Installation Instructions for Fire Alarm Systems. 6.1 General National and Local Codes, Architect's Plans, or the authority having jurisdiction may specify what type of equipment may be used, where the fire alarm system components should be located, and how the circuits should be arranged. In addition, the information supplied by the manufacturer and the applicable requirements of the NFPA standards codes listed in the front of this publication should be followed. 6.2 Location of system components. 6.2.1 General Most fire alarm systems are installed to meet requirements of applicable laws. The authorities enforcing these laws should be consulted for specific approval of installation methods and component locations. This manual may not be in total agreement with their requirements because the manual reflects NFPA standards codes and trends in the industry in effect at the time of publication. Care must be taken to acknowledge local or state revisions to any particular code or standard. 6.2.2 Fire Alarm Control Units. The mount and location of the fire alarm system control unit and associated peripheral equipment should be carefully chosen with consideration given to system operating requirements. Preferably, the central equipment should be located in an area of low fire risk. For the safety of the operator, who may be required to remain at this post after the general evacuation of the occupants, the fire alarm control unit should be located on the ground floor within easy reach of a fire exit. The fire alarm control unit cabinet can be floor-mounted or installed on a vertical wall in a clean, dry, unobstructed location. The center of the cabinet should be at a convenient height from the finished floor for ease of operator usage. Consideration also should be given to the fact that some fire alarm control units exhibit a slight hum that is inherent in some power supplies and certain alternating current components. These types of fire alarm control units should be located where this hum will not be objectionable to others in the area. A smoke detector shall be located above the main panel, remote control panels, external remote station transmitter panels, and remote notification appliance circuit power supplies in all unoccupied areas. The detector is there to give an early warning should the panel be threatened by smoke or fire. The panel should be able to transmit the alarm before being disabled by fire. 6.2.3 Alarm Initiating Devices. Manual fire alarm boxes should be distributed throughout the protected area so that they are unobstructed, readily accessible, and located in the normal path of exit from the area. Where a fire alarm system is required, manual fire alarm boxes should be located as directed and approved by the local authority having jurisdiction. Since 1979, NFPA standards codes have required that an adequate number of fire alarm boxes be provided on each floor. Also, additional fire alarm boxes should be provided so that the travel distance to the nearest station will not be in excess of 200 feet. Each station should be securely mounted and at a height compliant with NFPA 72 and Americans with Disabilities Act (ADA) requirements. The rule of thumb is to install the manual fire alarm box so the top is at 48 inches above the finished floor, AFF. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2-2010 page 61. SB2-2010 page 62. Automatic fire detectors should be installed in all areas where required by the building code and the appropriate NFPA standard code or as required by the authority having jurisdiction. Where total coverage is required, this should include all rooms, halls, storage areas, basements, attics, lofts, spaces above suspended ceilings, and other subdivisions and accessible spaces, and inside all equipment closets, closed stairways, dumbwaiter shafts, and chutes. Inaccessible areas that contain combustible material should be made accessible and protected by detector S. Detectors should also be installed underneath open loading docks or platforms and their covers, and for accessible underfloor spaces of buildings without basements. Exceptions to the last two paragraphs and other detailed information on automatic fire detectors are found in Chapter 5, Initiating Devices, NFPA 72. Determining the exact location for automatic fire detectors is one of the most critical decisions to be made when installing any fire alarm system. Whenever possible, the type of detector to be used and the location of each detector should be determined by a qualified fire protection engineer who has made a complete survey of the premises to be protected. When this is not feasible, the recommendations of the equipment manufacturer should be followed. NFPA 72 gives complete information on the minimum performance, location, mounting, testing, and maintenance requirements of automatic fire detectors used for the protection of occupants, building, space, structure, area, or object to be protected in accordance with the stated purpose. Rate-compensated and fixed-temperature detectors having the proper set points for an area are rarely subjected to false operations. To avoid nuisance alarms, rate-of-rise detectors should not be located where sudden temperature changes normally occur, such as near loading platforms, furnace doors, or school doorways. Smoke detectors should not be located in areas where high levels of detector contamination normally are likely to occur, such as near air duct, airport hangars, garages, and furnace areas. Water flow switches should be mounted on sprinkler risers in order to sense the flow of water in a sprinkler system. The installation of water flow switches should be in accordance with NFPA 13, standard for the installation of sprinkler systems. 6.2.4 Audible Alarm Notification Appliances. Audible alarm notification appliances should be installed so as to be protected against the effects of temperature, vermin, corrosion, humidity, and physical damage. Appliances intended for use in special environments, such as outdoors or in hazardous locations or where subject to tampering, must be listed for the intended application. Where guards or covers are employed for protection, they must be listed for use with the appliance, and their effect on the appliance's field performance must be taken into account. Audible alarm notification appliances intended for operation in the public mode must be installed so that their sound level is at least 15 dBA above the average ambient sound level, or 5 dBA above a maximum ambient sound level lasting for 60 seconds or longer, whichever is greater, as measured 1.5 meters, 5 feet above the floor in the area required to be served by the system using the A-weighted scale, dBA. They can be installed on walls or ceilings in accordance with NFPA 72, Chapter 7 and the manufacturer's published instructions. 6.2.5 Visible Alarm Notification Appliances. Visible alarm notification appliances are available separately or in combination with audible alarm notification appliances. Their primary purpose is to provide hearing-impaired occupants of a building with notification of a fire emergency. Visible alarm notification appliances must be located so that the operating effect of the appliance can be seen by the intended viewers. The appliances must be of a type, size, intensity, and number so that the viewer can tell when they have been illuminated, regardless of the viewer's orientation. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 63 Chapter 7 of NFPA 72 contains detailed requirements for the installation of visible alarm appliances, including their location, spacing, and intensity in rooms, corridors, and sleeping areas, on walls, and on ceilings. The user of this manual should refer to the NFPA document and to the manufacturer's published instructions for complete installation information. 6.2.6 Visible alarm signal annunciators. Annunciators should be mounted where they are readily accessible to responsible operating personnel. The use of an annunciator at the main entrance to a building is recommended to permit responding fire service personnel to locate the fire quickly. NFPA 72 requires that fire alarm systems serving 2 or more zones indicate the zone of origin of the alarm initiation by annunciation or coded alarm signal. 6.2.7 Permanent recorders. Punch registers and printers are normally located adjacent to the fire alarm control unit where they can be readily accessed by responsible operating personnel. 6.2.8 Trouble signal appliances. Trouble signal appliances should be located where they can be readily heard by responsible personnel and, unless otherwise specified, should be mounted on or near the fire alarm control unit. At least one trouble signal appliance must be audible and may be supplemented with a visible indicator. Typically, in today's systems, the audible and visual LED trouble signal is located within the main fire alarm control unit. It may also be found in remote panels. 6.3 Power supplies. 6.3.1 Number of sources required. All fire alarm systems installed in accordance with NFPA 72 require 2 power supplies: a primary, main power supply used to operate the system, and a secondary, standby power supply used to operate the fire alarm system in the event of a failure of the primary, main power supply. 6.3.2 Primary, main power supplies. The most widely used source for the primary, main power supply is one phase of the commercial 240-120 volt AC electric light and power service available in most buildings. If necessary, a properly installed engine-driven generator or equivalent may be used instead. As an example, per NFPA 72, it would be usable where no commercial power was available, like a seasonal camp in the middle of the woods. Connections to the power service should be on a dedicated branch circuit. The circuit and connections should be mechanically protected. The circuit disconnecting means should be accessible only to authorized personnel and should be clearly marked "Fire Alarm Circuit Control." NFPA 72 requires that the location of the circuit disconnecting means be permanently identified at the fire alarm control unit. 6.3.3 Secondary, standby power supplies. Secondary, standby power supplies should be capable of operating the connected fire alarm system in the event of failure of the primary, main power supply for specified periods of time under maximum normal load and alarm load conditions. The specified periods of time vary depending upon the type of system and, in the case of proprietary systems, how the system is used. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 64 Table 6.1 shows specified periods of time under maximum normal load and alarm load conditions required by NFPA standards. NFPA 72. Note that previous editions of NFPA 72 called for 60 hours of maximum normal load for both auxiliary systems and remote supervising station systems. Table 6.1 Operating periods required by NFPA standards: maximum normal load protected premises, local systems, auxiliary systems, remote supervising station systems, central station and proprietary supervisory station systems, emergency voice alarm communications ***** for test purposes. NFPA equates 15 minutes of voice communications at full alarm load to 2 hours of voice communications at normal alarm load. The maximum normal load for fire alarm systems generally includes only monitoring current. NFPA 72 requires that the secondary, standby power supply be capable of operating the system continuously for the period of either 5 minutes or 2 hours under alarm load at the end of the 24-hour maximum normal load period, depending on the type of system. Maximum normal load for central station and proprietary supervising station fire alarm systems depends on how the system is applied. In regular fire alarm service, most systems are normally dormant. Only monitoring current, including the two-way transmissions on multiplex systems and other continuously energized circuits, need to be considered in calculating maximum normal loads. When, however, alarms or supervisory signals are received, lamps and peripheral equipment are frequently turned on. Printers that might get a real fire signal once a month can get hundreds of signals an hour if guard patrols report to the system or other supervisory services are being monitored. Since the function of emergency voice alarm communication systems is to provide communications to people in buildings that are deemed to be impractical to totally evacuate, it is necessary to require that these systems remain functional beyond the usual 5 minutes of alarm. NFPA 72 requires this period to be 2 hours. However, the nature of the use of a voice system during an emergency condition is sporadic and the number of speaker circuits selected varies. Therefore, NFPA 72 permits 15 minutes of operation at maximum connected load to be considered the equivalent of 2 hours of normal use. Secondary, standby power supplies are used in two basic forms. In one form, The secondary power supply is not directly connected to the system but is switched in when primary operating power fails. The switching can take place either in a building system switchover point or at the fire alarm system control unit. In the other form, the primary, main source of power is of an uninterruptible nature, such as might be supplied from an uninterruptible power source (UPS) or a float-charged battery, where the battery is floated across the primary, main power supply to the fire alarm system control unit. In either case, the trouble signal is required to indicate loss of the primary, main power supply. The only exception permitted by the NFPA standards to sounding the trouble signal upon loss of primary, main power is when the fire alarm systems get their primary, main power by connection to a building power supply that is backed up by one of the emergency or standby systems described in 6.3.1. In this case, the loss of power is usually evident and the fire alarm system cannot monitor the loss of building power without further connections to the building system. A secondary source for protected premises and supervising station systems can also be from an automatically started emergency generator. The system would only be required to have 4 hours of battery standby in accordance with NFPA 72. Alarm load 5 minutes 5 minutes 5 minutes 5 minutes 2 hours asterisk 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 24 hours 24 hours 24 hours 24 hours 24 hours. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. 6.3.4 Trouble signal power supply in older systems without battery standby. The trouble signal power supply is rarely a true independent source of power except on systems that do not use a secondary, standby power supply. In such systems, the phase of the building power used for the trouble signal power supply should be different from the phase used for the primary, main power supply for the fire alarm system. Where a secondary, standby power supply is used, it should be used as the source of power for the trouble signals. 6.3.5 Batteries 6.3.5.1 Storage batteries should be located or enclosed such that the equipment of the fire alarm system, including overcurrent protective devices, should not be adversely affected by battery gases. The cells should be suitably insulated against grounds and shorts and should be mounted in such a manner as not to be subject to mechanical damage. Racks and frames should be suitably protected against deterioration. Storage batteries should be trickle charged or float charged from a reliable power source to keep them fully charged under normal operation. They should be protected from damage caused by an excessive rate of charge or from the reversal or interruption of the supply current. Provisions should be made to prevent spraying of the battery electrolyte while it is being charged at the maximum rate. In newer systems, the battery charger and battery are monitored for faults. When lead-acid batteries are used, transparent battery cases will facilitate inspection for excessive sedimentation. Storage batteries are typically protected by overcurrent devices having a rating of not less than 150% and not more than 250% of the maximum operating load applied to the battery. 6.3.5.2 Primary, dry cell batteries. Primary, dry cell batteries should not be used except as the sole source of power for a low-power radio wireless initiating device where use requirements in accordance with NFPA 72 are met. 6.4 Requirements for installation of wiring and equipment. Refer to Article 760 of NFPA 70 for requirements for installation of fire alarm wiring and equipment. 6.5 Manufacturers' published instructions. Installation wiring also should be in accordance with the procedures and recommendations of the fire alarm system manufacturer. Typically, the manufacturer's published instructions may recommend the use of straight lay, twisted wire, coaxial cable, microphone cable, shielded cable, special fire retardant cable, or low smoke producing multi-conductor cable. 6.6 Local codes. All fire alarm systems should be installed in accordance with protected premises fire alarm and electrical codes. Most local authorities have adopted the National Electrical Code, NFPA 70, as their local electrical code. Some localities have added requirements to the National Electrical Code, or have completely written their own code. In any event, it is very important to check with the local electrical and/or fire inspector to determine what the code requirements are for installing fire alarm systems. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 65. SB 2/2010 page 66. 6.7 Types of circuits. The majority of fire alarm systems are powered by 120 V, 60 Hz. This voltage is transformed down to 12 or 24 volts DC, typically 24 volts. In terms of the power and the type of wire that may be used, fire alarm circuits are broken into two types: non-power limited and power limited. These circuits are also defined in detail in the National Electrical Code, Article 760. Caution: low-voltage systems, as mentioned above, are generally derived through the transformation of 120-volt sources. This higher voltage is present in most control units. In addition, fan control circuits and circuits to control other equipment may be present in the control unit. These circuits are frequently 120 volts or more, depending upon the application. 6.8 Intermixing of circuits. Non-power limited fire alarm circuits may be run in the same enclosure, cable, or raceway with Class I circuits, defined in Article 725 of the National Electrical Code, provided all conductors are insulated for the maximum voltage of any conductor in the enclosure or raceway, and installed per manufacturer's published instructions. Care may be required to keep separation between power and non-power limited wiring. Power supply and fire alarm circuit conductors are permitted in the same enclosure, cable, or raceway only where connected to the same equipment. See Article 760 of the National Electrical Code for the full requirements for the selection and installation of conductors in non-power limited fire alarm circuits. Power limited fire alarm circuit conductors should be separated by at least 0.250 inches, 6 mm, a partition, barrier, or other acceptable equivalent means, from an electric light, power, Class 1, or non-power limited fire alarm circuit conductors in the same enclosure, raceway, cable, compartment, outlet box, or shaft. Merely insulating all conductors for the maximum voltage of any conductor in the enclosure, raceway, and so forth is not an acceptable equivalent means. An exception exists for conductors in compartments, enclosures, outlet boxes, or similar fittings where electric light, power, Class 1 circuit, or non-power limited conductors are introduced solely to connect to equipment connected to the power limited fire alarm system or to other circuits controlled by the fire alarm system to which the other conductors in the enclosure are connected. In this case, only a 0.25-inch separation is required. Power limited fire alarm circuits may be run in the same enclosure, cable, or raceway with Class 3 circuits, and with Class 2 circuits provided that the insulation of the Class 2 circuit conductors is at least equal to what is required for the Class 3 power limited circuit conductors. Class 2 and Class 3 circuits are defined in Article 725 of the National Electrical Code. A circuit that could be installed as a power limited circuit may be run with non-power limited and Class 1 circuits under the following conditions. First, the circuit must be reclassified as a non-power limited circuit, and second, the terminals to which the circuit is connected must no longer be identified as a power limited circuit. The circuit conductors must be insulated for the highest voltage requirements throughout. This means that if a power limited circuit has been changed, for wiring purposes, to a non-power limited circuit, it should be installed as a non-power limited circuit from end to end. See Article 760 of the National Electrical Code for the requirements for the selection and installation of conductors in power-limited fire alarm circuits. 6.9 Enclosed versus exposed wiring. Power and non-power limited fire alarm installation wiring may be installed in enclosed raceways or cable trays. However, The National Electrical Code and many local codes permit both non-power limited and power limited wiring, where meeting the requirements of sections 760-52 and 760-26 respectively of the National Copyright Sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 67 Electrical Code, to be either run in raceways or run exposed on the surface of ceiling and sidewalls or fished in concealed spaces where applicable cables, listed for the purpose, are used. Where wires are permitted to be run exposed, they should be adequately supported and protected from mechanical damage. Where mounted within 7 feet of the floor, exposed cable must be securely fastened in an approved manner at intervals of not less than 18 inches in the National Electrical Code. Some exceptions are taken to this requirement. For non-power limited circuits, the National Electrical Code permits the use of specific types of non-power limited cables operating at 150 volts or less. A separate power limited series of cable is recognized for power limited circuit wiring, with the use restrictions and markings, as required by the National Electrical Code. These cables may be run exposed, not in a raceway. Both types of circuits require the use of cables listed as being resistant to the spread of fire and smoke and suitable for the purpose, power classification of circuit, and whether used for plenum, riser, or general purpose applications. It should be noted that the National Electrical Code defines the space over a hung ceiling used for environmental air handling purposes as other space used for environmental air, and not as a plenum. A plenum is described in the National Electrical Code as being a ductway specifically manufactured to transport environmental air. Listed non-power limited plenum cable may be used without a raceway in other space used for environmental air, but it may not be used without a raceway in the space meeting the code's definition of a plenum, even though it may be known as plenum cable. Listed power limited plenum cable may be used without a raceway in spaces used for both environmental air and space meeting the National Electrical Code definition of a plenum and environmental air handling space. This is an important difference because some NFPA standards define plenum differently and the National Electrical Code's other space used for environmental air is almost universally referred to as a plenum. 6.10 Selecting conductors in cables. The National Electrical Code Article 760 spells out in detail all the requirements for wire, cable, and their markings, and installation methods. All of this detail is not repeated here. Therefore, the user of this manual should also refer to the NEC Article 760 that governs all electrical fire alarm signaling system installations. The 3 specific types are classified for use based on their properties in the presence of fire. The 3 classifications are for use in plenums, risers, and general wiring applications. To be listed, all these types must exhibit resistance to spread of fire. In addition, plenum-rated cables must have low smoke-producing characteristics so that products of combustion are not created within an air handling system, and riser-rated cables must have low flame spread characteristics so that they do not vertically propagate flame from floor to floor. 6.11 Cable markings. All cable listed for fire alarm use must be distinctly marked to identify its permitted application. The markings must include the following type designations: application non-power limited for plenum, use NPLF PFPLP for riser, use NPLFR FPLR for general wiring, NPLF FPL, copyright sign copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 68. Note that the marking table is for cables that are listed for fire alarm use. Any solid, stranded, or bunched-in copper cables meeting the requirements of Chapter 3 of the National Electrical Code and or permitted as substitutes for power-limited cable may be used for fire alarm installations without being listed for fire alarm use. Also, note that the wire classifications of general, riser, and plenum are for wire installed exposed, outside of conduit or other raceway. Use of these classifications is not required, but is permitted, for cables installed in conduit or other raceways. In addition, with some limitations, The National Electrical Code permits substitution for power-limited fire alarm cable using power-limited cable from Articles 725 and 800. The permitted substitutions are shown in a chart in the NEC. The same chart shows a cable substitution hierarchy for fire alarm, communications, and remote control and other signaling applications. 6.12 Identification of circuits where fire alarm circuits are intermixed with other circuits and terminal boxes. The fire alarm circuits should be identified. Attach a tag marked fire alarm circuit to the fire alarm circuit wires. This may help prevent any inadvertent tampering with the circuits, and also provide identification of the circuits for maintenance and testing. Some jurisdictions may require all conduit and boxes to be red in color. 6.13 Monitoring for integrity. Most fire alarm circuits, including radio pathways, are monitored for integrity, the exception being circuits accepted as supplementary by the authority having jurisdiction. Manufacturers' published instructions should be followed when installing to ensure proper monitoring operation. Monitoring means that a fault in the installation wiring will result in a trouble signal at the fire alarm control unit. A fault condition may be either a single break opening in the wiring, or a ground fault independent of whether or not it prevents normal operation of the system. In addition, a short between the two wires of an alarm notification appliance circuit must be monitored so that the energized state of the circuit is not the first indication of a trouble condition. On an analog addressable communication circuit wired style 7, short isolation, a single short shall not affect the operation of any device. Monitoring is accomplished usually by passing a small amount of current through the system's interconnecting wiring. The interconnecting wiring is generally a pair of wires from the fire alarm control unit to the detection devices and notification appliances. To ensure that monitoring is maintained to all devices, T-tapping off these circuits is not permitted. Certain multiplex systems or analog addressable circuits, however, do allow T-taps. Manufacturers' recommendations will provide adequate instructions in this regard. 6.14 Lightning surge protection, circuit protection. Lightning surge protection, when required, should be installed where the outside wiring enters the building. A ground wire should be installed per the NEC and/or manufacturer's published instructions. Lightning surge protection is especially important for circuits that go outside and enter another building, either aerially or underground. Circuits that are exposed to the elements on the roofs of buildings should be considered for lightning protection, with lightning protectors being mounted on or near the floor that is being protected. Under no circumstances should separate lightning surge protection be mounted inside a control unit. Transients should be bypassed to ground at the farthest possible distance from the control unit, and before the lightning-susceptible wires intermix with other circuits. This circuit protection is in addition to that which is required to be built in to the controls. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. 6.15 Outside wiring. Fire alarm wiring that runs outside of a building is typically run overhead on poles or buried. Wires run overhead should use a messenger, or support, and be constructed to withstand the strain of wind, ice, and its own weight. They should be suitable for exposure to sunlight, UV, to avoid premature failure. Wires that are buried should have a weatherproof casing such as polyethylene and also have a rodent barrier. See Article 800 of the National Electrical Code. Outside wiring does not have to be listed for fire alarm use. The NEC dictates how far length the outdoor cable is allowed to travel inside the building before transitioning to indoor wiring. General Section 7 System Startup Procedure. After the installation of the fire alarm system has been completed, the system should be verified to ensure that it is operating properly. It is customary for manufacturers to include their recommended test and maintenance instructions for the system with the control unit. Where these instructions are provided, The system should be tested in accordance with the provided information. Where such instructions are not supplied, the following procedures will serve as a guide. Because of the variations in system design among manufacturers and the large number of operations that are offered, it will be necessary to select the tests that apply to the system being checked out. The following tests are based on the assumption that the fire alarm equipment is required to be installed in accordance with NFPA 70, National Electrical Code, and designed to meet NFPA 72, National Fire Alarm Code, and is listed and/or approved. 7.2 Check of installation wiring. 7.2.1 Preliminary. Prior to connecting the installation wiring to the installation wiring terminals provided on the control unit, the wiring should be checked for extraneous voltages in shorts, opens, and grounds as detailed in the sections below. All faults should be located and eliminated before the installation wires are connected to the control unit. The other end of these wires should be connected to the remote equipment, initiating devices, notification appliances, annunciators, and so forth in the normal manner. An insulation tester should not be used to check for grounds because the predominant use of solid-state components in today's fire alarm systems may require disconnecting a large proportion of system equipment. Consider using an analog voltometer as a primary circuit tester. Digital voltometers typically do not provide sufficient power on resistance to detect grounds. Also, the indicating needle on an analog voltometer, VOM, provides faster visual response than a digital VOM, which can save considerable time. Where a smoke detector is the plug-in type, the installation wiring is terminated at the detector base, but the detector itself is not plugged in until after the installation wiring tests have been completed. Since the circuits between the base terminals are usually completed within the detector, it is necessary to short certain terminals with jumpers to perform the installation wiring tests. These jumpers are usually installed on the base by the manufacturer or are described in the published installation instructions. The jumpers should be removed after the installation wiring tests have been completed and prior to plugging in the detectors. Where the smoke detector is not of the plug-in type, the detector wires should be connected to the circuit for the test. 7.2.2 Test for extraneous voltages. Each installation wire should be tested at the control unit for extraneous stray voltages using the voltmeter. Check each installation wire for stray voltage to ground and to associated wires. Some noise may be measured during this test because of the antenna effect of unloaded wires. This type of voltage will typically not affect circuit operation and will disappear when the installation wires are connected to the control unit. This test should be conducted with the required end-of-line device installed. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. 7.2.3 Test for shorts and opens. Each installation wire should be tested at the control unit and for open circuits and short circuits to all other installation wires, using an ohm meter. The normal expected resistance between each pair of wires can usually be determined from the installation wiring diagram in Table 7.1. 7.2.3.1 Initiating device circuits. For Class B initiating device circuits, the normal resistance between wires depends on the location of the end-of-line device. Where the end-of-line device is located outside the control unit, as shown in Figure 7.1, the resistance measured between wires 1 and 2 at the control unit should be equal in value to the end-of-line device. Where the end-of-line device is located on the control unit, as shown in Figure 7.2, the ohm meter should measure infinite resistance between wires 1 and 2, since wires 3 and 4 are not connected to the end-of-line device during this test. The resistance between wires 1 and 4, and 2 and 3, should also be infinite. The resistance between 1 and 3 and between wires 2 and 4 should be close to 0. The actual reading should be equal to the ohmic resistance of the copper in the wire run. To make sure that wires 1 and 3 and wires 2 and 4 are not connected in more than one place, it is recommended practice to temporarily open the circuit at the last initiating device in each circuit. While the circuits are open, the ohm meter should read infinity between wires 1 and 3 and wires 2 and 4. The final test should be to short 3 and 4, and measure the total ohms between 1 and 2. Ensure that the ohmic resistance between 1 and 2 is less than the maximum allowed by the manufacturer's published instructions. Figure 7.1 End-of-line device on 2-wire Class B initiating device circuit. Figure 7.2 End-of-line device and control unit on 4-wire Class B initiating device circuit. For Class A initiating device circuits, the normal resistance between wires will depend on the circuitry used to provide the Class A operation. 7.2.3.2 Notification appliance circuits. Polarized notification appliances are connected in parallel as shown in Figure 7.3. However, these circuits are terminated by an end-of-line device to permit supervision of the installation wires. The resistance between wires 1 and 2 should be measured with the positive terminal of the ohm meter connected to wire 1 so that SB2 to 2010 page 71, copyright sign copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 72 meter current will flow only through the end-of-line device and not through any of the appliances. The meter reading should be equal to the resistance of the end-of-line device. Sometimes the last appliance in the circuit is installed so as to serve as the end-of-line device. In this case, the ohm meter should read the resistance of the appliance. Note: if the resistance between 1 and 2 is less than the end-of-line device, one or more of the appliances may be installed incorrectly. Figure 7.3 Polarized diode-type notification appliances connected in parallel. Speaker-type notification appliances are also connected in parallel, as shown in Figure 7.4, and terminated by an end-of-line device to permit supervision of the installation wires. Figure 7.4 Speaker-type notification appliances connected in parallel. The meter reading between wires 1 and 2 should be equal in value to the end-of-line device. The capacitor blocks direct current flow through the speaker coil. Table 7.1 Resistance of conductors size AWG 18, 16, 14, 12 DC resistance per 1000 feet ohms 6.54.12.61.6 Copyright sign copyright 2010 by the National Electrical Manufacturers Association. 7.2.4 Test for grounds. All installation wires should be checked for grounds with an ohm meter. All installation wires should test free of grounds, except for the grounded leg of the main power supply, unless otherwise indicated in the manufacturer's published instructions. 7.2.5 Visual inspection. Prior to turning on the power, the system should be inspected to ensure that it complies with all of the published installation instructions. All installation wires should be properly terminated and dressed in a workmanlike manner. Spare, unused circuits should be terminated in accordance with the manufacturer's published instructions. All plug-in components should be fully seated. All switches should be in their normal position. All connections should be tight. The control unit should be clean so that particles of dust or dirt cannot interfere with proper operation. 7.2.6 Check of power sources. The system primary, secondary, and treble power supply terminals, if provided, should be connected to their sources of power as shown in the system wiring diagram. 7.2.6.1 Alternating current systems. For alternating current systems, the primary power supply will usually be a 3-wire 240-120 volt AC supply having a continuous, unfused, grounded neutral conductor, with one phase or side of the circuit used for the primary system operating power supply and the other for the trouble signal power supply. 7.2.6.2 Older, low-voltage direct current systems. Low-voltage, direct current systems usually operate on 24 volts direct current obtained by rectification of transformer reduced 120 volts AC power. For these systems, the transformer may be mounted within the cabinet as an integral part of the control unit, or externally. Low-voltage, direct current systems are required to operate in a normal manner during periods of failure of the primary system power supply. Where rechargeable batteries are used to supply secondary or trouble signal power, the system should include a battery charger that automatically maintains the battery fully charged under all conditions of normal operation. If the battery charger is also used to power the system, it should have sufficient capacity to power the system and charge the battery under maximum load conditions. The installation wiring between all direct current power supplies and the control unit should be checked for correct polarity. The battery charger should be adjusted for proper charging current in accordance with the manufacturer's published instructions. The battery should be tested and brought up to full charge prior to turning the system over to the owner of the building. 7.3 Normal operation. Normal monitoring condition. After the visual inspection has been completed and any faults corrected, the control unit can be energized to obtain the normal monitoring condition. In this condition, all monitoring circuits should be energized. Appliances and all lamps should be in their normal condition. In older systems, whenever a system is in its normal monitoring condition, a trouble signal should sound if its trouble signal silencing switch is in the silence position. Whenever a trouble signal has been silenced, a visible indication of the silence condition is required by NFPA 72. The use of a common trouble in trouble, copyright sign, copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 73. SB 2/2010 page 74 Silenced indication is permitted. Trouble signal silencing switches may be either of the toggle type or momentary contact type, depending on the manufacturer. A toggle switch requires manual restoration to normal since the trouble signal must resound when all trouble conditions have cleared and the switch is in the silenced position. When the silencing switch is returned to its normal position, the audible trouble signal should be silent and the trouble lamp off. Where a momentary contact silencing switch is used, the trouble signal silenced indication is automatically reset to off when all troubles have been cleared. An important exception to this operation is the requirement by NFPA 72 that restoration to normal of any affected initiating circuit on a proprietary supervising station system must be acknowledged by the operator. Restoration of the trouble indications to normal are delayed until after this acknowledgement by the operator. A system left in trouble and silenced should resound within 24 hours. 7.4 Monitoring of circuits for integrity, electrical supervision. 7.4.1 General. With the power turned on and the system operating in the normal monitoring condition, all of the monitored circuits extending from the control unit should be tested separately for proper operation by using the manufacturer's published instructions. Fault conditions should be introduced in a manner such that no more than a single fault exists at any one time. After each test of a monitored circuit, the system should be restored to normal before proceeding to the next test. 7.4.2 Power supply circuits interrupting the primary or secondary power conductors should result in a trouble signal. Restoring the primary or secondary power should automatically return the system to normal operation. 7.4.3 Initiating device and notification apply on circuits and open in any initiating device circuit, or either an open or short on any notification apply on circuit, should result in a trouble signal. Restoring the circuit to normal should silence the trouble signal automatically if a trouble signal latch-in is not provided. Most Class A style DZ circuits latch-in when an open trouble occurs, and will require a reset to clear after the break is repaired. A single ground fault on any initiating device circuit or on any notification apply on circuit should also result in a trouble signal. Removal of the ground fault should restore the system to the normal monitoring condition. On ungrounded systems with a ground detection circuit, a ground on any monitored circuit should sound a trouble signal. 7.4.4 Overcurrent protection devices verify that fuses match the mark ratings on equipment or manufacturer's published instructions. 7.4.5 Municipal circuit systems connected to a municipal communications center or directly to fire headquarters should not be tested without first informing the local fire authorities that the system is being tested. Opening the circuit to a shunt-type municipal fire alarm box will cause an alarm on the municipal fire alarm system. The wires to a shunt-type box should never be grounded since this would cause a ground fault on the municipal system. Copyright sign, copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 75 opening the circuit to a local energy type municipal fire alarm box should sound a trouble signal on the local system and have no effect on the municipal system. Grounding the circuit should produce the same result except that no trouble signal will sound for ungrounded systems without ground detection. Opening the circuit to the Municipal Communications Center or the fire headquarters in a remote supervising station system should sound a trouble signal at the designated location S. A single ground on the circuit will sound a trouble signal only if the system includes a ground detection circuit. 7.4.6 Supplementary circuits need not be monitored for integrity. Unmonitored supplementary circuits should be designed so that a fault on these circuits will not interfere with the operation of the balance of the system. Great care should be exercised in determining which circuits are to be considered supplementary. Where supplementary circuits are provided, they should also be checked for proper operation. See 2.11 for more details. 7.4.7 Annunciator circuits. Annunciators not monitored for integrity meeting the requirements for supplementary circuits are permitted only where they are located on the control unit, are not the primary annunciator, or have been classified as supplementary by the authority having jurisdiction. Monitored annunciators should be tested in the same manner as monitored initiation appliance circuits. 7.5 Alarm operation. All manual alarm initiating devices should be operated individually to test for proper operation of the system during the alarm condition. All automatic alarm initiating devices, including heat, smoke, and water flow devices, should be tested in accordance with the manufacturer's published instructions. The operation of any fire alarm initiating device should result in a fire alarm signal. On non-coded systems, the alarm notification appliances should sound in temporal pattern, or in accordance with local codes or regulations until the circuit is restored manually or the time limit cut out, if provided, operates. On coded systems, the code after each initiation should sound for a minimum of 3 rounds, typically 4. On pre-signal systems, the pre-signal alarm should only sound on pre-signal alarm notification appliances. The general alarm of a pre-signal system should sound on all the alarm notification appliances. This should be verified by listening to each appliance during any one of the alarm initiating device tests. For both coded and zone-coded systems, a test should be made to ensure that each initiating device transmits its correct code. The connection to auxiliary and remote supervising station fire alarm systems should be tested at least once with the approval of the appropriate fire authorities. On enunciated systems, the annunciator should be checked as each initiating device is tested to make sure that the proper point is enunciated. 7.6 Authority having jurisdiction. Throughout this training manual, the phrase, authority having jurisdiction, has been used. Also known as the AHJ, this is the person or organization responsible for the final acceptance of the installed system. On any one installation, the AHJ may consist of a governmental authority, such as a fire marshal, an owner, and copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 76 Owner's designated representative, an insurance authority, a hired inspection company, or any combination of the above. To complicate matters, there is a hierarchical relationship among AHJs. For example, an owner AHJ would not be expected to be able to overrule a government AHJ exercising his legal authority and requiring compliance with any local, state, or federal codes. 7.7 NFPA tables for test methods and visual inspection and test frequencies. NFPA 72 test methods and the maximum time permitted between visual inspection and testing periods are shown in tables 7.2, 7.3, and 7.4. Copyright notice: the following 4 NFPA tables are reprinted here from NFPA 72, National Fire Alarm Code, copyright 2007. With the permission of the National Fire Protection Association, Quincy, Massachusetts 02269. This reprinted material is not the complete and official position of the National Fire Protection Association on the reference subject that is represented only by NFPA 72 in its entirety. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. Device 1. Control equipment A. Functions B. Fuses C. Interface equipment D. Lamps and LEDs E. Primary, main power supply. 2. Engine-driven generator. 3. Secondary, standby power supply. 4. Uninterrupted power supply UPS. 5. Batteries. General tests A. Visual Inspection Table 7 to NFPA 72, Table 10.4.2.2 Test Methods Method SB2 to 2010 page 77 At a minimum, control equipment shall be tested to verify correct receipt of alarm, supervisory, and trouble signals, inputs, operation of evacuation signals and auxiliary functions, outputs, circuit supervision including detection of open circuits and ground faults, and power supply supervision for detection of loss of AC power and disconnection of secondary batteries. The rating and supervision shall be verified. Integrity of single or multiple circuits providing interface between two or more control units shall be verified. Interfaced equipment connections shall be tested by operating or simulating operation of the equipment being supervised. Signals required to be transmitted shall be verified at the control unit. Lamps and LEDs shall be illuminated. All secondary, standby power shall be disconnected and tested under maximum load, including all alarm appliances requiring simultaneous operation. All secondary, standby power shall be reconnected at end of test. For redundant power supplies, each shall be tested separately. If an engine-driven generator dedicated to the fire alarm system is used as a required power source, operation of the generator shall be verified in accordance with NFPA 110, Standard for Emergency and Standby Power Systems, by the building owner. All primary, main power supplies shall be disconnected and the occurrence of required trouble indication for loss of primary power shall be verified. The system's standby and alarm current demand shall be measured or verified and, using manufacturer's data, the ability of batteries to meet standby and alarm requirements shall be verified. General alarm systems shall be operated for a minimum of 5 minutes and emergency voice communications systems for a minimum of 15 minutes. Primary, main power supply shall be reconnected at end of test. If a UPS system dedicated to the fire alarm system is used as a required power source, operation of the UPS system shall be verified by the building owner in accordance with NFPA 111, Standard on Stored Electrical Energy Emergency and Standby Power Systems. Prior to conducting any battery testing, the person conducting the test shall ensure that all system software stored in volatile memory is protected from loss. Batteries shall be inspected for corrosion or leakage. Tightness of connections shall be checked and ensured. If necessary, battery terminals or connections shall be cleaned and coated. Electrolyte level and lead-acid batteries shall be visually inspected. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 78B. Battery replacement C. Charger test D. Discharge test E. Load voltage test. 6. Battery tests, specific types A. Primary battery load voltage test B. Lead-acid type 1. Charger test. 2. Load voltage test 3. Specific gravity device method. Batteries shall be replaced in accordance with the recommendations of the alarm equipment manufacturer, or when the recharge battery voltage or current falls below the manufacturer's recommendations. Sealed gel-type batteries should be replaced 5 years from the date of manufacture. This is a new requirement that NFPA 72 instituted in the 2002 edition. Operation of battery charger shall be checked in accordance with charger test for the specific type of battery. With the battery charger disconnected, The batteries shall be load tested following the manufacturer's recommendations. The voltage level shall not fall below the levels specified. Exception: an artificial load equal to the full fire alarm load connected to the battery shall be permitted to be used in conducting this test. With the battery charger disconnected, the terminal voltage shall be measured while supplying the maximum load required by its application. The voltage level shall not fall below the levels specified for the specific type of battery. If the voltage falls below the level specified, corrective action shall be taken and the batteries shall be retested. Exception: an artificial load equal to the full fire alarm load connected to the battery shall be permitted to be used in conducting this test. The maximum load for a number 6 primary battery shall not be more than 2 amperes per cell. An individual 1.5-volt cell shall be replaced when a load of 1 ohm reduces the voltage below 1 volt. A 6-volt assembly shall be replaced when a test load of 4 ohms reduces the voltage below 4 volts. With the batteries fully charged and connected to the charger, the voltage across the batteries shall be measured with a voltmeter. The voltage shall be 2.30 volts per cell, plus minus sign 0.02 volt at 25 degrees Celsius, 77 degrees Fahrenheit, or as specified by the equipment manufacturer. Under load, the battery shall not fall below 2.05 volts per cell. The specific gravity of the liquid in the pilot cell or all of the cells shall be measured as required. The specific gravity shall be within the range specified by the manufacturer. Although the specified specific gravity can vary from manufacturer to manufacturer, a range of 1.205–1.220 is typical for regular lead-acid batteries, while 1.240–1.260 is typical for high-performance batteries. A hydrometer that shows only a pass or fail condition of the battery and does not indicate the specific gravity shall not be used, because such a reading does not give a true indication of the battery condition. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 79 Device C. Nickel cadmium type 1. Charger test. 2. Load voltage test D. Sealed lead acid type 1. Charger test. 2. Load voltage test. 7. Public fire alarm reporting system power supply A. Lead acid type B. Nickel cadmium type C. Sealed lead acid type D. Wired system method with the batteries fully charged and connected to the charger. An ampere meter shall be placed in series with the battery under charge. The charging current shall be in accordance with the manufacturer's recommendations for the type of battery used. In the absence of specific information, 130 to 125 of the battery rating shall be used. Under load, the float voltage for the entire battery shall be 1.42 volts per cell, nominal. If possible, cells shall be measured individually. With the batteries fully charged and connected to the charger, the voltage across the batteries shall be measured with a voltmeter. The voltage shall be 2.30 volts per cell, plus minus sign 0.02 volt at 25 degrees Celsius, 77 degrees Fahrenheit, or as specified by the equipment manufacturer. Under load, the battery shall perform in accordance with the battery manufacturer's specifications. In addition to the tests and inspection required above, the following requirements shall apply. Perform battery tests in accordance with Item 6B. Perform battery tests in accordance with Item 6C. Perform battery tests in accordance with Item 6D. Manual tests of the power supply for public reporting circuits shall be made and recorded at least once during each 24-hour period. Such tests shall include the following: 1. Current strength of each circuit. Changes in current of any circuit exceeding 10% shall be investigated immediately. 2. Voltage across terminals of each circuit, inside of terminals of protective devices. Changes in voltage of any circuit exceeding 10% shall be investigated immediately. 3. B voltage between ground and circuits. If this test shows a reading in excess of 50% of that shown in the test specified in 2, the trouble shall be immediately located and cleared. Readings in excess of 25% shall be given early attention. These readings shall be taken with a calibrated voltmeter of not more than 100 ohms resistance per volt. Systems in which each circuit is supplied by an independent current source, Forms 3 and 4, require tests between ground and each side of each circuit. Common current source systems, Form 2, require voltage tests between ground and each terminal of each battery and other current source. 4. Ground current reading shall be permitted in lieu of 3. If this method of testing is used, all grounds showing a current reading in excess of 5% of the supplied line current shall be given immediate attention. 5. Voltage across terminals of common battery, on switchboard side of fuses. 6. Voltage between common battery terminals and ground. Abnormal. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010, page 80. 8. Public fire alarm reporting system transmission equipment. A. Publicly accessible fire alarm box. B. Auxiliary box. C. Master box. 1. Manual operation. 2. Auxiliary operation. 9. Transient suppressors. 10. Fire alarm control unit trouble signals. A. Audible and visual. B. Disconnect switches. C. Ground fault monitoring circuit. D. Transmission of signals to off-premises location device method. Ground readings shall be investigated immediately. Tests specified in 5 and 6 shall apply only to those systems using a common battery. If more than one common battery is used, each common battery shall be tested. Publicly accessible initiation device S shall be actuated. Receipt of not less than 3 complete rounds of signal impulses shall be verified. This test shall be performed under normal circuit conditions. If the device is equipped for open circuit operation, ground return, it shall be tested in this condition as one of the semi-annual tests. Each initiating circuit of the auxiliary box shall be tested by actuation of a protected premises initiating device connected to that circuit. Receipt of not less than 3 complete rounds of signal impulses shall be verified. Perform the test described in 8A. Perform the test described in 8B. Lightning protection equipment shall be inspected and maintained per the manufacturer's published instructions. Additional inspections shall be required after any lightning strikes. Equipment located in moderate to severe areas outlined in NFPA 780, Standard for the Installation of Lightning Protection Systems, NXL, shall be inspected semi-annually and after any lightning strikes. Operation of control unit trouble signals shall be verified as well as ringback feature for systems using a trouble silencing switch that requires resetting. If control unit has disconnect or isolating switches, performance of intended function of each switch shall be verified and receipt of trouble signal when a supervised function is disconnected shall also be verified. If the system has a ground detection feature, the occurrence of a ground fault indication shall be verified whenever any installation conductor is grounded. An initiating device shall be actuated and receipt of alarm signal at the off-premises location shall be verified. A trouble condition shall be created and receipt of a trouble signal at the off-premises location shall be verified. A supervisory device shall be actuated and receipt of a supervisory signal at the off-premises location shall be verified. If a transmission carrier is capable of operation under a single or multiple fault condition, an initiating device shall be activated during such fault condition and receipt of a trouble signal at the off-premises location shall be verified. In copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010, page 81. Device 11. Remote annunciators. 12. Conductors metallic. A. Stray voltage. B. Ground fault. C. Short circuit faults. D. Loop resistance. E. Supervision. 13. Conductors non-metallic. A. Circuit integrity. B. Fiber optics method addition to the alarm signal. The correct operation and identification of annunciators shall be verified. If provided, the correct operation of annunciator under fault condition shall be verified. All installation conductors shall be tested with a volt-ohm-meter to verify that there are no stray, unwanted voltages between installation conductors or between installation conductors and ground. Unless a different threshold is specified in the published manufacturer's published instructions for the installed equipment, the maximum allowable stray voltage shall not exceed 1 volt AC/DC. All installation conductors other than those intentionally and permanently grounded shall be tested for isolation from ground per the installed equipment manufacturer's published instructions. All installation conductors other than those intentionally connected together shall be tested for conductor-to-conductor isolation per the published manufacturer's published instructions for the installed equipment. These same circuits also shall be tested conductor to ground, with each initiating and indicating circuit installation conductor pair short-circuited at the far end. The resistance of each circuit shall be measured and recorded. It shall be verified that the loop resistance does not exceed the limits specified in the published manufacturer's published instructions for the installed equipment. Introduction of a fault in any circuit monitored for integrity shall result in a trouble indication at the fire alarm control unit. One connection shall be opened at not less than 10% of the initiating devices, notification appliance and control devices on every initiating device circuit, notification appliance circuit, and signaling line circuit. Each initiating device, notification appliance, and signaling line circuit shall be tested to confirm that the conductors are monitored for integrity in accordance with the requirements of Chapter 4 and Chapter 6 of NFPA 72, 2007. The fiber optic transmission line shall be tested in accordance with the manufacturer's published instructions by the use of an optical power meter, or by an optical time domain reflectometer used to measure the relative power loss of the line. This relative figure for each fiber optic line shall be recorded in the fire alarm control unit. If the power level drops 2% or more from the value recorded during the initial acceptance test, the transmission line, section thereof, or connectors shall be repaired or replaced by a qualified technician to bring the line back into compliance with the accepted transmission level per the manufacturer's published instructions. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 82C. Supervision device method. Introduction of a fault in any supervised circuit shall result in a trouble indication at the control unit. One connection shall be opened at not less than 10% of the initiating device, notification appliance, and signaling line circuits. Each initiating device, notification appliance, and signaling line circuit shall be tested for correct indication at the control unit. All circuits shall perform as indicated in Table 6.5, Table 6.6.1, or Table 6.7. Correct operation shall be verified by removal of the fusible link and operation of the associated device. Any moving parts shall be lubricated as necessary. Correct operation shall be verified by removal of the fusible link and operation of the associated device. Any moving parts shall be lubricated as necessary. The switch shall be mechanically or electrically operated, and receipt of signal by the fire alarm control unit shall be verified. Fire gas detectors and other fire detectors shall be tested as prescribed by the manufacturer and as necessary for the application. Heat test shall be performed with a heat source per the manufacturer's published instructions for response within 1 minute. A test method shall be used that is specified in the manufacturer's published instructions for the installed equipment, or other method shall be used that will not damage the non-restorable fixed temperature element of a combination, rate-of-rise/fixed temperature element detector. Heat test shall not be performed. Functionality shall be tested mechanically and electrically. Loop resistance shall be measured and recorded. Changes from acceptance test shall be investigated. After 15 years from initial installation, all devices shall be replaced, or 2 detectors per 100 shall be laboratory tested. The 2 detectors shall be replaced with new devices. If a failure occurs on any of the detectors removed, additional detectors shall be removed and tested to determine either a general problem involving faulty detectors or a localized problem involving 1 or 2 defective detectors. If detectors are tested instead of replaced, tests shall be repeated at intervals of 5 years. Heat test shall not be performed. Functionality shall be tested mechanically and electrically. Heat test shall be performed where test chambers are in circuit, or a test with pressure pump shall be conducted. Functional tests shall be conducted according to manufacturer's published instructions. Non-restorable heat detectors shall not be tested with heat. 14. Initiating devices. A. Electromechanical releasing device. 1. Non-restorable type link. 2. Restorable type link. CB. Fire extinguishing system S or suppression system S. Alarm switch. C. Fire gas and other detectors. D. Heat detectors. 1. Fixed temperature, rate of rise, rate of compensation, restorable line, spot type, excluding pneumatic tube type. 2. Fixed temperature, non-restorable line type. 3. Fixed temperature, non-restorable spot type. 4. Non-restorable general. 5. Restorable line type, pneumatic tube only. 6. Single and multiple station heat alarms. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010, page 83. Device E. Fire alarm boxes. F. Radiant energy fire detectors. Method G. Smoke detectors. 1. In other than 1 and 2 family dwellings, system detectors in single-station smoke alarms. Manual fire alarm boxes shall be operated per the manufacturer's published instructions. Key-operated pre-signal and general alarm manual fire alarm boxes shall both be tested. Flame detectors and spark ember detectors shall be tested in accordance with the manufacturer's published instructions to determine that each detector is operative. Flame detector and spark ember detector sensitivity shall be determined using any of the following. 1. Calibrated test method. 2. Manufacturer's calibrated sensitivity test instrument. 3. Listed control unit arranged for the purpose. 4. Other approved calibrated sensitivity test method that is directly proportional to the input signal from a fire, consistent with the detector listing or approval. If designed to be field adjustable, detectors found to be outside of the approved range of sensitivity shall be replaced or adjusted to bring them into the approved range. Flame detector and spark ember detector sensitivity shall not be determined using the light source that administers an unmeasured quantity of radiation at an undefined distance from the detector. The detectors shall be tested in place to ensure smoke entry into the sensing chamber and an alarm response. Testing with smoke or listed aerosol approved by the manufacturer shall be permitted as acceptable test methods. Other methods listed in the manufacturer's published instructions that ensure smoke entry into the sensing chamber shall be permitted. Any of the following tests shall be performed to ensure that each smoke detector is within its listed and marked sensitivity range. 1. Calibrated test method. 2. Manufacturer's calibrated sensitivity test instrument. 3. Listed control equipment arranged for the purpose. 4. Smoke detector control unit arrangement whereby the detector causes a signal at the control unit when its sensitivity is outside its listed sensitivity range. 5. Other calibrated sensitivity test method approved by the authority having jurisdiction. Functional tests shall be conducted according to manufacturer's published instructions. Per test methods documented in the manufacturer's published instructions, detector alarm response shall be verified through the end sampling port on each pipe run. Airflow through all other ports shall be. 2. Single and multiple station smoke alarms used in 1 and 2 family dwellings. 3. Air sampling. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010, page 84. 4. Duct type. 5. Projected beam type. 6. Smoke detector with built-in thermal element. 7. Smoke detectors with control output functions. H. Initiating devices. Supervisory. 1. Control valve switch. 2. High or low air pressure switch. 3. Room temperature switch. 4. Water level switch. 5. Water temperature switch I. Mechanical, electrosonic, or pressure-type water flow device J. Multi-sensor detector or multi-criteria detector or combination detector device method verified as well. Air duct detectors shall be tested or inspected to ensure that the device will sample the airstream. The test shall be made in accordance with the manufacturer's published instructions. The detector shall be tested by introducing smoke, other aerosol, or an optical filter into the beam path. Both portions of the detector shall be operated independently as described for the respective devices. It shall be verified that the control capability shall remain operable even if all of the initiating devices connected to the same initiating device circuit or signaling line circuit are in an alarm state. Valve shall be operated and signal receipt shall be verified to be within the first 2 revolutions of the hand wheel or within 1/5 of the travel distance, or per the manufacturer's published instructions. Switch shall be operated. Receipt of signal obtained where the required pressure is increased or decreased to maximum 70 kilopascals, 10 pounds per square inch from the required pressure level shall be verified. Switch shall be operated. Receipt of signal to indicate the decrease in room temperature to 4.4 degrees Celsius, 40 degrees Fahrenheit, and its restoration to above 4.4 degrees Celsius, 40 degrees Fahrenheit shall be verified. Switch shall be operated. Receipt of signal indicating the water level raised or lowered 76.2 millimeters, 3 inches from the required level within a pressure tank, or 305 millimeters, 12 inches from the required level of a non-pressure tank, shall be verified, as shall its restoral to required level. Switch shall be operated. Receipt of signal to indicate the decrease in water temperature to 4.4 degrees Celsius, 40 degrees Fahrenheit, and its restoration to above 4.4 degrees Celsius, 40 degrees Fahrenheit shall be verified. Water shall be flowed through an inspector's test connection indicating the flow of water equal to that from a single sprinkler of the smallest orifice size installed in the system for wet pipe systems, or an alarm test bypass connection for dry pipe, pre-action, or deluge systems in accordance with NFPA 25, standard for the inspection, testing, and maintenance of water-based fire protection systems. 1. Each of the detection principles present within the detector, e.g., smoke, heat, CO, etc., shall be tested independently for the specific detection principle regardless of the configuration status at the time of testing. Each detector shall also be tested in accordance with the published manufacturer's published instructions. 2. Individual sensors shall be tested together if the technology allows individual sensor responses to be verified. 3. Tests shall be performed as described for the respective devices by introduction of the physical phenomena to the sensing chamber of copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 85 device. 15. Alarm notification appliances A. Audible B. Audible textural notification appliances, speakers and other appliances to convey voice messages. Method C. Visible. 16. Exit marking audible element, and an electronic check magnets, analog values, etc. is not sufficient to comply with this requirement. 4. The result of each sensor test shall be confirmed. This shall be through indication at the detector or control unit. 5. Where individual sensors cannot be tested individually, the primary sensor shall be tested. D6. All tests and results shall be recorded. Sound pressure level shall be measured with sound level meter meeting ANSI S1.4A. Specifications for sound level meters. Type 2 requirements. Levels throughout protected area shall be measured and recorded. The sound level meter shall be set in accordance with ANSI S3.41, American National Standard Audible Evacuation Signal, using the time-weighted characteristic F fast. Record the maximum output when the audible emergency evacuation signal is on. Sound pressure level shall be measured with sound level meter meeting ANSI S1.4A. Specifications for sound level meters. Type 2 requirements. Levels throughout protected area shall be measured and recorded. The sound level meter shall be set in accordance with ANSI S3.41, American National Standard Audible Evacuation Signal, using the time-weighted characteristic F fast. The maximum output shall be recorded when the audible emergency evacuation signal is on. Audible information shall be verified to be distinguishable and understandable. In locations where voice intelligibility is required, it shall be verified by one of the following methods. 1. Use of subject-based test methods as described in ANSI S3.2, method for measuring the intelligibility of speech over communication systems. 2. Use of methods and instruments that measure certain physical parameters and provide a common intelligibility scale score as described in IC 60849, sound systems for emergency purposes. 3. Use of other methods acceptable to the authority having jurisdiction. The use of test methods that provide a common intelligibility scale score shall be permitted for use in existing systems but shall not require revisions to systems that were designed prior to the 2002 edition of this code. Tests shall be performed in accordance with the manufacturer's published instructions. Appliance locations shall be verified to be per approved layout, and it shall be confirmed that no floor plan changes affect the approved layout. It shall be verified that the candela rating marking agrees with the approved drawings. It shall be confirmed that each appliance flashes. Tests shall be performed in accordance with the manufacturer's copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 86 Notification Appliance. 17. Special Hazard Equipment A. Abort switch, deadman type B. Abort switch, recycle type C. Abort switch, special type D. Cross-zone detection circuit E. Matrix type circuit F. Release solenoid circuit G. Squib release circuit H. Verified, sequential, or counting zone circuit I. All above devices or circuits or combinations thereof. 18. Supervising station fire alarm systems transmission equipment A. All equipment device method published instructions. Abort switch shall be operated. Correct sequence and operation shall be verified. Abort switch shall be operated. Development of correct matrix with each sensor operated shall be verified. Abort switch shall be operated. Correct sequence and operation in accordance with authority having jurisdiction shall be verified. Sequencing on as-built drawings or in owner's manual shall be observed. One sensor or detector on each zone shall be operated. Occurrence of correct sequence with operation of first zone and then with operation of second zone shall be verified. All sensors and systems shall be operated. Development of correct matrix with each sensor operated shall be verified. Solenoid shall be used with equal current requirements. Operation of solenoid shall be verified. AGI flashbulb or other test light approved by the manufacturer shall be used. Operation of flashbulb or light shall be verified. Required sensors at a minimum of 4 locations and circuit shall be operated. Correct sequence with both the first and second detector and alarm shall be verified. Supervision of circuits shall be verified by creating an open circuit. Tests shall be performed on all system functions and features in accordance with the equipment manufacturer's published instructions for correct operation in conformance with the applicable sections of Chapter 8. Initiating device shall be actuated. Receipt of the correct initiating device signal at the supervising station within 90 seconds shall be verified. Upon completion of the test, the system shall be restored to its functional operating condition. If test jacks are used, the first and last test shall be made without the use of the test jack. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 87 Device B. Digital Alarm Communicator Transmitter, DACT Method C. Digital Alarm Radio Transmitter, DART D. McCullough transmitter connection of the DACT to 2 separate means of transmission shall be ensured. Exception. DACTs that are connected to a telephone line number that is also supervised for adverse conditions by a derived local channel. DACT shall be tested for line seizure capability by initiating a signal while using the primary line for a telephone call. Receipt of the correct signal at the supervising station shall be verified. Completion of the transmission attempt within 90 seconds from going off hook to on hook shall be verified. The primary line from the DACT shall be disconnected. Indication of the DACT trouble signal at the premises shall be verified, as well as transmission to the supervising station within 4 minutes of detection of the fault. The secondary means of transmission from the DACT shall be disconnected. Indication of the DACT trouble signal at the premises shall be verified, as well as transmission to the supervising station within 4 minutes of detection of the fault. The DACT shall be caused to transmit a signal to the DACR while the fault in the primary telephone number is simulated. Utilization of the secondary telephone number by the DACT to complete the transmission to the DACR shall be verified. The primary telephone line shall be disconnected. Transmission of a trouble signal to the supervising station by the DART within 4 minutes shall be verified. Initiating device shall be actuated. Production of not less than 3 complete rounds of not less than 3 signal impulses each by the McCullough transmitter shall be verified. If end-to-end metallic continuity is present and with a balanced circuit, each of the following 4 transmission channel fault conditions shall be caused in turn, and receipt of correct signals at the supervising station shall be verified. 1. Open. 2. Ground. 3. Wire-to-wire short. 4. Open and ground. If end-to-end metallic continuity is present and with a balanced circuit, each of the following 3 transmission channel fault conditions shall be caused in turn, and receipt of correct signals at the supervising station shall be verified. 1. Open. 2. Ground. 3. Wire-to-wire short. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 88E. Radio Alarm Transmitter, RAT. 19. Supervising Station Fire Alarm Systems Receiving Equipment A. All Equipment B. Digital Alarm Communicator Receiver, DACR-C. Digital Alarm Radio Receiver, DAR-D. McCullough Systems Method A. Fault between elements of the transmitting equipment shall be caused. Indication of the fault is indicated at the protected premises shall be verified, or it shall be verified that a trouble signal is transmitted to the supervising station. Tests shall be performed on all system functions and features in accordance with the equipment manufacturer's published instructions for correct operation in conformance with the applicable sections of Chapter 8. Initiating device shall be actuated. Receipt of the correct initiating device signal at the supervising station within 90 seconds shall be verified. Upon completion of the test, the system shall be restored to its functional operating condition. If test jacks are used, the first and last test shall be made without the use of the test jack. Each telephone line number shall be disconnected in turn from the DACR, and audible and visual enunciation of a trouble signal in the supervising station shall be verified. A signal shall be caused to be transmitted on each individual incoming DACR line at least once every 24 hours. Receipt of these signals shall be verified. The following conditions of all DARs on all subsidiary and repeater station receiving equipment shall be caused. Receipt at the supervising station of correct signals for each of the following conditions shall be verified. 1. AC power failure of the radio equipment. 2. Receiver malfunction. 3. Antenna and interconnecting cable failure. 4. Indication of automatic switchover of the DAR. 5. Data transmission line failure between the DAR and the supervising or subsidiary station. The current on each circuit at each supervising and subsidiary station under the following conditions shall be tested and recorded. 1. During functional operation. 2. On each side of the circuit with the receiving equipment condition for an open circuit. A single break or ground condition shall be caused on each transmission channel. If such a fault prevents the functioning of the circuit, Receipt of a trouble signal shall be verified. Device, copyright sign, copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 89 Device E. Radio Alarm Supervising Station Receiver, RASSR, and Radio Alarm Repeater Station Receiver, RARSR-F. Private Microwave Radio Systems. 20. Emergency Communications Equipment A. Amplifier Tone Generators B. Calling Signal Silence C. Off-hook Indicator, Ring Down D. Phone Jack C. Phone Set F. System Performance. 21. Combination Systems A. Fire Extinguisher Monitoring Device System B. Carbon Monoxide Detectors Method. Each of the following conditions at each of the supervising or subsidiary stations and all repeater station radio transmitting and receiving equipment shall be caused. Receipt of correct signals at the supervising station shall be verified. 1. RF transmitter in use radiating. 2. AC power failure supplying the radio equipment. 3. RF receiver malfunction. 4. Indication of automatic switchover. Each of the following conditions at each of the supervising or subsidiary stations and all repeater station radio transmitting and receiving equipment shall be caused. Receipt of correct signals at the supervising station shall be verified. 1. AC power failure supplying the radio equipment. 2. RF receiver malfunction. 3. Indication of automatic switchover, if applicable. Each of the following conditions at each of the supervising or subsidiary stations and all repeater station radio transmitting and receiving equipment shall be caused. Receipt of correct signals at the supervising station shall be verified. 1. RF transmitter in use radiating. 2. AC power failure supplying the radio equipment. 3. RF receiver malfunction. 4. Indication of automatic switchover. Correct switching and operation of backup equipment shall be verified. Function shall be operated and receipt of correct visual and audible signals at control unit shall be verified. Phone set shall be installed or phone shall be removed from hook and receipt of signal at control unit shall be verified. Phone jack shall be visually inspected and communications path through jack shall be initiated. Each phone set shall be activated and correct operation shall be verified. System shall be operated with a minimum of any 5 handsets simultaneously. Voice quality and clarity shall be verified. Communication between the device connecting the fire extinguisher monitoring device system and the fire alarm control unit shall be tested to ensure proper signals are received at the FACU and remote annunciator S if applicable. Functional tests shall be conducted according to the published manufacturer's published instructions. Copyright sign copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 90. 22. Interface equipment. 23. Fire safety functions. 24. Guard tour equipment. 25. Special procedures A. Alarm verification B. Multiplex systems device method interface equipment connections shall be tested by operating or simulating the equipment being supervised. Signals required to be transmitted shall be verified at the control unit. Test frequency for interface equipment shall be the same as the frequency required by the applicable NFPA standard S for the equipment being supervised. Fire safety functions I. Fan control, smoke damper operation, elevator recall, elevator power shutdown, door holder release, door unlocking, etc. shall be tested by operating or simulating alarm signals. Testing frequency for fire safety functions shall be the same as the frequency required for the initiating device that activates the fire safety function. The device shall be tested in accordance with manufacturer's published specifications. Time delay and alarm response for smoke detector circuits identified as having alarm verification shall be verified. Communications between sending and receiving units under both primary and secondary power shall be verified. Communications between sending and receiving units under open circuit and short circuit trouble conditions shall be verified. Communications between sending and receiving units in all directions where multiple communications pathways are provided shall be verified. If redundant central control equipment is provided, switch over and all required functions and operations of secondary control equipment shall be verified. All system functions and features shall be verified in accordance with manufacturer's published instructions. The following procedures describe additional acceptance and reacceptance test methods to verify wireless protection system operation. 1. The manufacturer's published instructions and the as-built drawings provided by the system supplier shall be used to verify correct operation after the initial testing phase has been performed by the supplier or by the supplier's designated representative. 2. Starting from the functional operating condition, the system shall be initialized in accordance with the manufacturer's published instructions. A test shall be conducted to verify the alternative path, or paths, by turning off or disconnecting the primary wireless repeater. The alternative communications path shall exist between the wireless control unit and peripheral devices used to establish initiation, indication, control, and annunciation. The system shall be tested for both alarm and trouble conditions. 3. Batteries for all components in the system shall be checked monthly. If the control unit checks all batteries and all components daily, the system shall not require monthly testing of the batteries. 26. Low-power radio, wireless systems. An example, 4000 mAh x 125 equals 160 mAh charging current at 25 degrees Celsius, 77 degrees Fahrenheit. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 91b. The voltmeter sensitivity has been changed from 1000 ohms per volt to 100 ohms per volt so that false ground readings, caused by induced voltages, are minimized. C-fusible thermal link detectors are commonly used to close fire doors and fire dampers. They are actuated by the presence of external heat, which causes a solder element in the link to fuse, or by an electric thermal device, which, when energized, generates heat within the body of the link, causing the link to fuse and separate. For example, it may not be possible to individually test the heat sensor in a thermally enhanced smoke detector. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 92 Table 7.3 NFPA 72, Visual Inspection Frequencies Initial Component Reacceptance Monthly Quarterly Semi-annually Annually. 1. Control Equipment. Fire alarm systems monitored for alarm, supervisory, trouble signals fuses X, -sign, XB. Interface equipment C. Lamps and LEDs D. Primary, main power supply. 2. Control equipment. Fire alarm systems unmonitored for alarm, supervisory, trouble signals A. Fuses B. Interface equipment C. Lamps and LEDs D. Primary, main power supply. 3. Batteries A. Lead acid B. Nickel cadmium C. Primary, dry cell D. Sealed lead acid. 4. Transient suppressors. 5. Fire alarm control unit trouble signals. 6. Fiber optic cable connections. 7. Emergency voice alarm communications equipment. 8. Remote annunciators. 9. Initiating devices A. Air sampling B. Duct detectors C. Electromechanical releasing devices D. Fire extinguishing system S or suppression system S or switches E. Fire alarm boxes F. Heat detectors G. Radiant energy fire detectors H. Smoke detectors, excluding 1 and 2 family dwellings I. Supervisory signal devices J. Water flow devices. 10. Guard door equipment. 11. Combination systems A. Fire extinguisher monitoring device, systems B. Carbon monoxide detectors, systems. 12. interface equipment. 13. Alarm notification appliances, -sign supervised. 14. Exit marking audible notification appliances. 15. Supervising station fire alarm systems transmitters A.DACTB.DART-C. McCullough D.RATX weekly, -sign, 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 -sign X weekly, -sign, 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 -sign X weekly, -sign, 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 -sign X weekly, -sign, 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 -sign XX, -sign, -sign, -sign X, -sign, -sign X, -sign XX, -sign, -sign, -sign X, -sign, -sign X, -sign X, -sign, -sign X, -sign X weekly, -sign, -sign X, -sign X, -sign, -sign, -sign XX, -sign, -sign X, -sign X, 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 -sign X, -sign, -sign X, -sign, -sign X, -sign X, -sign X, -sign, -sign X, -sign X, -sign, -sign X, -sign, -sign X, -sign X, 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 -sign, -sign X, -sign X, -sign, -sign X, -sign X, 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 -sign, -sign X, -sign X, -sign, -sign X, -sign X, -sign, -sign X, -sign X, -sign, -sign X, -sign. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. X, -sign, -sign, -sign XX, -sign, -sign, -sign XX, -sign, -sign, -sign X. SB2 to 2010 page 93 component **E. IP communicator. 16. Special procedures initial reacceptance monthly X, -sign X, -sign semi-quarterly annually. 17. Supervising station fire alarm systems receivers 1A.DACR *XX, -sign, -sign, -sign B.DAR *X, -sign, -sign X, -sign C. McCullough Systems *X, -sign, -sign X, -sign D. 2-way RF multiplex *X, -sign, -sign X, -sign E.RASSR *X, -sign, -sign X, -sign F.RARS *X, -sign, -sign X, -sign G. Private microwave **H. IP communicator. 18. Public fire alarm reporting system transmission equipment. A. Publicly accessible fire alarm box. B. Auxiliary box. C. Master box. 1. Manual operation. 2. Auxiliary operation **. Reports of automatic signal receipt shall be verified daily. ***, not currently in NFPA 72X, X, 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 X. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. X minus sign X minus sign 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 minus sign X minus sign. SB2 to 2010 page 94 table 7 for NFPA 72 testing frequencies component 1. Control equipment building systems connected to supervising station A. Functions B. Fuses C. Interfaced equipment D. Lamps and LEDs Z. Primary, main, power supply F. Transponders. 2. Control equipment building systems not connected to a supervising station A. Functions B. Fuses C. Interfaced equipment D. Lamps and LEDs E. Primary, main, power supply F. Transponders. 3. Engine-driven generator, central station facilities and fire alarm systems. 4. Engine-driven generator, public fire alarm reporting systems initial reacceptance monthly quarterly semi-annually annually table 7 to reference 1, 7, 16, 17. 5. Batteries, central station facilities A. Lead acid type. 1. Charger test, replace needed. 2. Discharge test, 30 minutes. 3. Load voltage test. 4. Specific gravity battery as X, XX, XX, X, 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 1X, X, XX, X, 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 XX, X weekly 6BX X XX XX X X 6CX X X X X X XX 60 XX 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 6BX X X X X X X X 6CX X X X X X 6AXX 60X X X X X X B nickel cadmium type. 1. Charger test, replace battery as needed. 2. Discharge test, 30 minutes. 3. Load voltage test C sealed lead acid type. 1. Charger test, replace battery within 5 years after manufacture or more frequently as needed. 2. Discharge test, 30 minutes. 3. Load voltage test. 6. Batteries. Fire alarm systems A lead acid type. 1. Charger test, replace battery as needed. 2. Discharge test, 30 minutes. 3. Load voltage test. 4. Specific gravity B nickel cadmium type. 1. Charger test, replace battery as needed. 2. Discharge test, 30 minutes. 3. Load voltage test C primary type, dry cell 1.H test D sealed lead acid type. 1. Charger test, replace battery within 5 years after manufacture or more frequently as needed. 2. Discharge test, 30 minutes. 3. Load voltage test, copyright sign copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 95 component. 7. Power supply. Public fire alarm reporting systems A lead acid type batteries. 1. Charger test, replace battery as needed. 2. Discharge test, 2 hours. 3. Load voltage test. 4. Specific gravity B nickel-cadmium type batteries. 1. Charger test, replace battery as needed. 2. Discharge test, 2 hours. 3. Load voltage test C sealed lead-acid type batteries. 1. Charger test, replace battery within 5 years after manufacture or more frequently as needed. 2. Discharge test, 2 hours. 3. Load voltage test D wired system, voltage test. 8. Fiber optic cable power. 9. Control unit trouble signals. 10. Conductors, metallic. 11. Conductors, non-metallic. 12. Emergency voice alarm communications equipment. 13. Retransmission equipment, the requirement of 10.4.9 shall apply. 14. Remote enunciators. 15. Initiating devices A. Duct detectors B. Electromechanical releasing device D. Fire extinguishing system S. Or suppression system S. Or switches D. Fire gas and other detectors E. Heat detectors. The requirements of 10.4.4.4 shall apply. F. Fire alarm boxes G. Radiant energy fire detectors H. System smoke detectors. Functional test I. Smoke detectors. Sensitivity testing in other than 1 and 2 family dwellings, the requirements of 10.4.4.2 shall apply. J. Single and multiple station smoke alarms, the requirements for monthly testing in accordance with 10.4.5 shall also apply. K. Single and multiple station heat alarms. L. Supervisory signal devices, except valve temper switches. M. Water flow devices. N. Valve supervisory switches. 16. Guard tour equipment initial reacceptance. XXXX, XXX, XXXX daily, XXXXXX, XXXXXXXX, XXXXXX monthly quarterly. X, 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 X. X. Semi-annually annually. X. 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 X table 7 to reference 6b 6c 60 70 13b 10 12 13 21 11 14 24 Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 96 component initial semi-reacceptance monthly quarterly annually X XX X table 7 to reference 21A 21B 22 23 17 15 16 18 17 Combination systems A. Fire extinguisher monitoring device systems B. Carbon monoxide detectors systems. 18. Interface equipment and fire safety functions. 19. Special hazard equipment X, 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 X. 20. Alarm notification appliances A. Audible devices B. Audible textural notification appliances C. Visible devices. 21. Exit marking notification appliances. 22. Off-premises transmission equipment supervising station fire alarm systems. 23. Transmitters X, 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 X. 24. Supervising station fire alarm systems. 25. Receivers A.DACRXX, B.RXX, C. Mikalo systems XX, D. Two-way RF multiplex XX, E.RASSRXX, F.RARSRXX, G. Private microwave X **H, IP communicator X. 26. Public fire alarm reporting system transmission equipment A. Publicly accessible fire alarm box X, B. Auxiliary box X, C. Master box 1. Manual operation X, 2. Auxiliary operation X ***, not currently in NFPA 72X, X, X, 8A, X8B8C, X, X. Note: for testing addressable and analog described devices, which are normally affixed to either a single, molded assembly or are a twist lock type affixed to a base, testing shall be done utilizing the signaling style circuits, styles 0.5 through 7. The addressable term is determined by the Technical Committee in Formal Interpretation 79.8 on NFPA 72D and Formal Interpretation 87.1 on NFPA 72A. Analog type detectors shall be tested with the same criteria. Section 8 Proper maintenance of fire alarm systems. 8.1 Periodic maintenance. 8.1.1 General. When performing periodic maintenance on fire alarm systems, it will be helpful to have the following available. A. The manufacturer's published installation and user instructions for the system control unit and all connected peripheral devices, including smoke or flame detectors and other specialized components. B. The as-built drawings of the system that should include the location of all devices and appliances, wiring methods, and the sequence of the connections between the devices, appliances, and control unit. C. The appropriate NFPA standard or code if maintenance is being performed pursuant to a specific standard or code. Inspection, Testing and Maintenance chapter of NFPA 72 specifies the frequency of testing for devices, appliances, and systems. D. Any record S of tests previously performed as well as the record from tests at system start up to allow a comparison of the electrical measurements being taken with those previously observed. The NFPA 72 record of completion provides a document that acknowledges the features of the installation, operation, performance, service, and equipment at the time of the installation. The record of completion is also required to be updated after system alterations or additions. Such comparisons can be a valuable aid for rapid troubleshooting. Additionally, future faults may be prevented by finding the source of a difference in an initiating device circuit resistance, voltage, or current at control unit terminals, and resistance to ground. 8.1.2 System Performance and Integrity. One way to provide a thorough test of system performance and integrity is to repeat the tests outlined in the startup procedures published by the equipment manufacturer. If not available, NFPA 72's Inspection, Testing and Maintenance chapter in sections 6 and 7 of this manual can be used as a guide. Always remember that NFPA 72's Inspection, Testing and Maintenance chapter is the minimum testing requirement. 8.2 Fire Alarm Control Units. 8.2.1 Printed circuit board assemblies of modules. Most modern fire alarm control units do not require periodic adjustment or field repair other than replacement of a defective module, printed circuit board assembly, or the possible adjustment of battery charging voltage. Most control units now utilize printed circuit boards with numerous integrated circuits and miniature components that make field servicing at a board level virtually impossible. Defective printed circuit board assemblies or modules can be best serviced at the manufacturer's plant or at their authorized service facility. Where the control unit uses printed circuit boards, the boards should be maintained in a clean and dry environment to ensure proper operation. Exposure to moisture and high humidity can lead to printed circuit board failure. 8.2.2 Relay maintenance. As with printed circuit boards, fire alarm relays have also been miniaturized, and the maintenance and adjustment of any relays should be performed only at the manufacturer's plant or authorized service facility, or by an organization or person having the necessary technical experience, components, and equipment. A. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 97. SB 2/2010 page 98. Complete stock of spare relays should, therefore, be kept on hand so that an out-of-adjustment relay, or one with burned out or pitted contacts, can be readily replaced. Covered relays seal out dust and discourage adjustment. 8.2.3 Battery charger maintenance. Low battery voltage is generally an indication that the battery charger or battery needs maintenance. Float-charged and trickle-charged batteries are normally kept in a fully charged condition at all times except when the battery provides power for the fire alarm system during primary, main power supply failures. Before making any adjustments to a battery charger, consult the manufacturer's published instructions, as some battery chargers provide automatic charging features where low and high charge rates are automatically activated. Most modern control units also use sealed or non-maintenance type batteries. The most popular type of batteries used are sealed lead-acid and typically require replacement every 4 years. These types of sealed lead-acid batteries should be marked with the date of manufacture. 8.2.4 Battery maintenance. Batteries should be located in a vented, clean, dry place, preferably on shelves or racks above the floor level, or in cabinets. With many new control units, the batteries are now located within the control unit. The electrolyte level of unsealed storage batteries should be checked regularly. If the electrolyte level is low, distilled water should be added to bring the level up to normal. Most tap water has sufficient metal salts or chemicals to appreciably reduce battery life. Therefore, distilled water, not tap water, should be used in the regular maintenance of the electrolyte level. NFPA 72's Inspection, Testing and Maintenance chapter lists the various types of batteries in common use on fire alarm systems and includes the frequency and methods of testing. 8.2.5 Fuses. Fuse maintenance consists of checking the fuse holders to make sure that good contact is made with the connectors on each end of the fuse and that they are not corroded. Hot fuses usually indicate either poor contact or overloaded fuses, or both. A supply of fuses of each ampere size and type should be on hand so that the equipment will not remain out of service because of a blown fuse. Fuses that exceed the ratings of those for the circuit should not be used even temporarily. 8.2.6 Circuit breakers. Magnetic and thermal type circuit breakers require very little maintenance. However, they should be kept free of dust. 8.2.7 Condition of control unit cabinets. Dust and dirt removal. The top, bottom, and face of the control unit cabinet in which the equipment is mounted should be kept free of dust, dirt, and grime. These can cause trouble on printed circuit board connectors, relays, or other open contact mechanisms, or be a source of corrosion of metal parts. Neat arrangement of connecting wires from conduits, raceways, or cables at terminating points will reduce maintenance time when it is necessary to trace and disconnect a wire in the control unit from its terminal for isolation and test. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. 8.3 Non-coded manual fire alarm boxes. Maintenance on non-coded manual fire alarm boxes, with or without the pre-signal feature, should include periodic operation tests, replacement of broken, break glass windows or breakable elements, and checking terminal connections for loose or corroded connections. In monitored fire alarm systems, a broken connection should sound a trouble signal. Fire alarm boxes should be tested by activating the mechanism as someone would do in a fire emergency. Opening the fire alarm box with a key or tool does not ensure proper operation. Dust and dirt as well as mechanical degradation may cause the fire alarm box not to alarm when activated in its prescribed manner. A supply of glass rods, plates, and so forth should be kept on hand for break glass boxes. 8.4 Coded manual fire alarm boxes. 8.4.1 General primarily installed on older control units. All coded manual fire alarm boxes should be operated at regular intervals and a log kept showing the location of the station and the date when it was last checked. Both pre-signal and general alarm features should be checked. The general alarm feature is usually initiated by the operation of a key-actuated switch mounted on the box. Since code wheels can come loose on their shafts, they should be checked every 5 years. Where coded boxes are equipped with contacts for annunciation, it may be necessary to manually restore the contacts to their normal position after each alarm by means of a reset key or tool or by replacing the break glass element. Some selective coded manual boxes are equipped with test switches that can be used during regular maintenance. Inserting the key, plug, or special tool in the test keyhole or slot and turning it in one direction will sound one tap on single-stroke bells or one blast on vibrating bells or horns. Turning in the opposite direction and holding it in that position will permit operation of the station mechanism without sounding an alarm. 8.4.2 Spring-driven fire alarm boxes. Maintenance of spring-driven coded manual boxes closely follows that for non-coded boxes. When this type of selective coded box is operated, a pull handle usually winds a clock spring. When the handle is released, the spring unwinds and drives a gear train and a code wheel. The rotary motion of the code wheel makes or breaks a pair of contacts that transmit coded pulses to the control unit. The spring-actuated code mechanism is usually completely enclosed in a semi-dust-proof enclosure made of a transparent material. Caution! In some boxes, pulling the station lever breaks a glass element and or immediately closes or opens one or two sets of contacts, in addition to winding the clock spring. The contacts either operate an annunciator or prevent alarm transmission from fire alarm boxes electrically further away from the control unit by opening or shorting the line beyond. Care should be taken to ensure that these contacts function as intended. Some fire alarm boxes are wound with a key similar to a clock key. In these boxes, the pull lever mechanism only starts the code sending mechanism or auxiliary shunt or annunciator contacts, or both. As with the types in which pulling an operating lever winds a clock spring, these pre-wound fire alarm boxes cause the code wheel to make at least 3 complete revolutions and sound the associated alarm signals for a minimum of 3 rounds of code. Full rewinding of key rewound spring-driven boxes after each operation should be a regular part of the maintenance programs. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 99. SB 2/2010 page 100. 8.4.3 Motor-driven coded fire alarm boxes. The maintenance of motor-driven coded boxes is similar to that for the spring-driven type. 8.5 Automatic transmitters. The maintenance problems encountered with automatically tripped mechanical transmitters are similar to those for manual coded boxes because their construction and methods of operation are similar. The automatic transmitter, however, has a remotely controlled initiating circuit. Transmitters that can be tripped either manually or electrically should be tested manually and electrically at least once every year, or more frequently if environmental factors are severe. See the published manufacturer's maintenance instructions for non-coded and coded fire alarm boxes. Like some spring-driven manual fire alarm boxes, pre-wound transmitters require rewinding after operation. This should be a regular part of the maintenance program. Some transmitters are equipped with a local trouble buzzer, a light, and silencing switch. Some have trouble contacts for connection to the main control unit. Some have a combination of both. When these transmitters are checked periodically, The trouble signal features should be tested to make sure they are functioning properly. 8.6 Automatic heat detectors. 8.6.1 Fixed temperature heat detectors. Fixed temperature type automatic heat detectors that use fusible elements require little maintenance. This is true for most types of spot heat detectors. Loose or corroded terminal connections are, however, possible. Automatic heat detectors should not be painted. Since testing of a non-restorable fusible element heat detector destroys the fusible element, follow NFPA 72 test methods. The most common practice for this category of heat detectors is to replace these units every 15 years. NFPA 72's inspection, testing and maintenance chapter details a test and replacement procedure for non-restorable fixed temperature heat detectors. Fixed temperature detectors of the restorable type can be tested while installed on the ceiling and connected to the control unit. A heat source held several inches from the detector should cause it to operate. When the heat source is moved away from the detector, the heat sensor will reset and again be ready for use in detecting the heat of a fire. To avoid distorting or melting detectors constructed using a thermoplastic housing, apply the heat slowly by starting at a distance of about a foot and slowly bring it closer to the heat sensor until the detector alarms. 8.6.2 Rate of rise heat detectors. The tubing of line-type rate of rise detectors should be tested for pinhole leaks about once a year. The manufacturer can provide an air test device to check for such leaks. The tubing system should be tested for operation in accordance with the manufacturer's recommendations. Spot type, combination rate of rise, and fixed temperature detectors are in common use. Rate of rise detectors can be tested with a heat source. If a heat source is used to test a combination fixed temperature and rate of rise detector with a fusible element, fixed temperature feature, the heat source should be removed quickly after operation of the rate of rise feature of the detector to prevent melting of the fusible element. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2-2010 page 101. Several heat-generating testing tools are available for performing heat detector testing. The advantage of these specifically designed test tools is they have extension pole attachments and output heat at a level that reduces the chance of damaging the detector. Some of these detector test tools perform both smoke and heat detector testing as well, and some tools do not require a 120-volt power source. 8.6.3 Rate compensation heat detectors. Rate compensation detectors are self-restoring units that can be tested with a heat source. 8.6.4 Explosion-proof heat detectors. Explosion-proof detectors can be fixed temperature, rate of rise, or rate compensation type. They are provided within a housing that will contain within the housing any explosion causing a flame or spark that would otherwise escape to the surrounding atmosphere. If these detectors are tested in an explosive atmosphere, an explosion-proof heat source unit should be used to generate the heat required to actuate the detector. 8.7 Smoke detectors. Smoke detectors do require periodic maintenance. All smoke detectors should be physically tested functionally at least annually. The normal practice is to test the smoke detector in place by introducing smoke or listed smoke aerosol into the detector sensing chamber. The smoke detectors should also be visually inspected for external dust and dirt as well as for any building obstructions that would interfere with the entry of smoke into the detector. Smoke detectors, like heat detectors, should not be painted. Newer type analog addressable smoke detectors also provide additional maintenance features such as the detection of excessive dirt buildup in the detector. This allows the control unit to signal when a smoke detector's sensitivity has changed, thereby increasing its susceptibility to false alarm. Many of these analog addressable detectors also provide an automatic sensitivity test. For older type smoke detectors that do not provide an automatic sensitivity test, sensitivity tests should be conducted within 1 year from installation and then on alternate years thereafter if sensitivity is not changing. After the second required calibration test, if sensitivity tests indicate that the device has remained within its listed and marked sensitivity range, the length of time between calibration tests is permitted to be extended to a maximum of 5 years. A more detailed description of calibration testing requirements can be found in NFPA 72's Inspection, Testing and Maintenance chapter. Warning: smoke detectors are sensitive electronic devices. The specific detector manufacturer's literature should be followed in performing any test or maintenance procedure. Failure to follow the manufacturer's published instructions could damage the detector permanently. 8.8 Sprinkler water flow detectors. Two types of sprinkler water flow detectors are used. 8.8.1 Pressure-operated pressure switches are usually connected into the intermediate chamber of the main sprinkler pipe of a sprinkler system. Generally, they have either enclosed mercury-to-metal or micro-switch contacts, and they can be tested by opening the inspector's test valve. This allows water to flow through the intermediate chamber of the main sprinkler valve into the pressure-type water flow switch and to hydraulically operated water motor gong, thereby closing or opening the pressure switch contacts and actuating the control unit to. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 100 and to which the detector is connected. Because the contacts are enclosed in a dust-proof housing, cleaning is not required. Electrical connections to the switch should be checked every year. Some water flow pressure switches are actuated by a reduction in pressure and are connected to the upper chamber of the main sprinkler pipe. Such switches can be tested by first closing the main gate valve and then opening the inspector's test valve, thereby releasing the trapped pressure in the sprinkler piping. This causes an alarm to sound upon the opening of a sprinkler head even though the main gate valve is closed and only trapped pressure is released through the sprinkler head. Make certain that the main gate valve is reopened immediately after the test. 8.8.2 Vane-operated vane-type water flow switches are installed in insertion holes in the sprinkler risers. The whole assembly is gasketed and bolted with U-clamps to the piping. The switches generally have either enclosed mercury or micro-switch contacts that are actuated by the forward movement of the paddle lever in the riser when water flows through the pipes. Usually, there is a pneumatically or electrically operated retard with these switches to prevent water hammer or pressure surges from operating the contacts. The retard is generally adjustable and can be set to delay the alarm up to 90 seconds. Where water flow switch signals are used to shut down elevator power upon or prior to the discharge of water from sprinklers, the use of devices with time delays is not permitted. Vane-type switches used as water flow detectors can be tested by opening the inspector's test valve at the highest point in the sprinkler system piping. In this way, the retard timing can be checked. 8.9 Gate valve supervisory contacts. Gate valve supervisory contacts are switches that are actuated by the movement of the threaded valve stem in response to approximately 2 turns of the gate valve wheel in the closing direction. The load on the contacts is usually only a fraction of the contact rating, thus, pitching and undue arcing are not likely to occur. 8.10 Open stem and yoke, OS and Y valve supervisory contacts. Maintenance of OS and Y valve supervisory contacts is similar to that required for gate valve supervisory switches. 8.11 Pressure switches. Pressure switches on dry pipe sprinkler systems respond to high or low air pressure and require the same maintenance as those used for wet pipe systems. 8.12 Tank switches. For high and low alarm service on gravity tanks. Tank switches are actuated by a ball float, which rises and falls with the level of the water in the tank. The switch mechanism may be a mercury to metal type, or an exposed heavy-duty, snap-action type switch. The contacts are provided in a cast, non-ferrous metal housing provided with a gasket to keep moisture out. The contacts of the switch, therefore, seldom need attention and, since the exposed contacts are generally of precious metal, corrosion is not a problem. 8.13 Differential pressure switches. Differential pressure switches are generally of the same type and construction as the high and low water or air pressure switches and, therefore, require similar maintenance. They are used to start an electric pump when the pressure in the sprinkler stem piping is not at least 15 pounds higher than the pressure in the water piping from the street supply. The pump builds up pressure in the system side by pumping a small quantity of water taken from the street side of the main sprinkler valve. A second differential pressure switch sounds an copyright sign, copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 103 alarm whenever the difference in pressure between the street and system sides falls well below 15 pounds, usually due to pump failure. Pump failure may be caused by the loss of power to the motor, a burned-out motor, or a burned-out bearing on either the pump or motor. 8.14 Inspectors test valves. Inspectors test valves are the conventional hydraulic, well-actuated valves and require maintenance similar to the valves used on regular water supply plumbing systems. 8.15 Notification appliance. Alarm horns. Older direct current alarm horns are usually of the vibrating diaphragm type. An armature associated with the diaphragm makes and breaks a pair of contacts connected in series with the horn coil and alternately energizes and de-energizes the coil. Generally, a capacitor is connected across the contacts to suppress arcing. An adjusting screw controls the armature air gap and the sound level of the horn. Periodic inspection will disclose contact wear or pitting that may require smoothing with a fine file and a contact burnishing tool. When a screw and lock nut adjustment is provided to vary the contact gap, it should be adjusted to the specification of the horn manufacturer. Newer horn-type notification appliances are manufactured with a solid-state piezo element and require virtually no maintenance other than the normal once-a-year activation. Alternating current, vibrating diaphragm alarm horns are similar to the direct current types, except they do not require the contacts to alternately energize and de-energize the armature. The zero on peak voltage created by an AC 60 Hz sine wave provides 120 beats per second. These horns do not have contacts, and have been used in series-connected alarm notification appliance circuits. Up to 10 12-volt horns or 26-volt horns were used on a 120-volt circuit. Note that in new or renovated systems, series-connected notification appliance circuits are no longer permitted by NFPA 72 because these circuits cannot be monitored for short-circuit faults. Electronic horns or sirens are either of the trumpet re-entrant type with a metal diaphragm, or the cone speaker type. If a cone is torn or warped, the speaker should be replaced. 8.16 Notification appliance. Alarm bells. Direct current vibrating bells have contacts that alternately energize and de-energize their coils, thereby causing the striker to contact a steel gong shell and produce vibrating bell sounds. Maintenance of contacts and gap spacing are similar to that for horns. The distance between the gong striker and the steel gong shell require infrequent attention. Normally, the bell movement is fastened to the base by 2 or 4 screws in elongated holes, thereby permitting the striker to be adjusted closer or further away from the gong shell. Like alternating current vibrating horns, alternating current vibrating bells usually have no contacts. They are, however, designed to operate at 60 instead of 120 beats a second by using a permanent magnet or rectifier to cut off one side of the sine wave. This reduced rate provides a cleaner bell sound. Similar to alternating current series horns, alternating current bells in a series-connected notification appliance circuits are no longer permitted. Alternating and direct current single-stroke solenoid bells or chimes usually require less maintenance than other audible signals. Terminal connections need to be checked every 5 or 10 years. When that is done, any dust or dirt that has collected between the plunger and the plunger tube should be blown free with compressed air or bellows. These bells or chimes have no contacts and can be used in series-connected circuits. AC series-connected bells or chimes typically use a balancing resistor to match the current of the bell or chime. All chimes or bells on a circuit must be of the same current rating. Copyright sign, copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 104 8.17 Strobe notification appliances. With the enactment of the Americans with Disabilities Act, ADA, Fire alarm systems must now be installed with both audible and visible notification appliances. The visible appliances for ADA are typically strobe-type units capable of providing several levels of light output. These strobe appliances can be mounted with the audible appliance or as a separate unit. The strobe units, much like the horns, require little maintenance other than the normal annual activation. 8.18 Trouble bells and buzzers. Trouble bells and buzzers may be of the alternating or direct current vibrating types, and maintenance is exactly the same as for alarm horns and alarm bells. 8.19 Remote switches on systems. Fire drill, reset, signal silence, acknowledge, abort, dump, disconnect, test, handoff auto, HOA, and other types of switches are generally of the conventional type. These switches require no maintenance except replacement when they fail to function properly. Annex A wiring diagrams and guide for testing fire alarm circuits. This annex has been reprinted from NFPA 72 by permission of the National Fire Protection Association. A.1 The wiring diagrams depicted in Figure A.2.1 through Figure A.2.17 are representative of typical circuits encountered in the field and are not intended to be all-inclusive. The noted styles are as indicated in Table 6.5, Table 6.6.1, Table 6.7, and Table 8.6.3.2.2.2. The noted systems are as indicated in NFPA 170, Standard for Fire Safety Symbols. Because ground fault detection is not required for all circuits, tests for ground fault detection should be limited to those circuits equipped with ground fault detection. An individual point identifying addressable initiating device operates on a signaling line circuit and not on a style A, B, C, D, or E, Class B and Class A initiating device circuit. All of the following initiating device circuits are illustrative of either alarm or supervisory signaling. Alarm initiating devices and supervisory initiating devices are not permitted on the same initiating device circuit. In addition to losing its ability to receive an alarm from an initiating device located beyond an open fault, a Style A, Class B initiating device circuit also loses its ability to receive an alarm when a single ground fault is present. Style C and Style E, Class B and Class A initiating device circuits can discriminate between an alarm condition and a wire-to-wire short. In these circuits, a wire-to-wire short provides a trouble indication. However, a wire-to-wire short prevents alarm operation. Shorting-type initiating devices cannot be used without an additional current or voltage limiting element. Directly connected system smoke detectors, commonly referred to as two-wire detectors, should be listed as being electrically and functionally compatible with the fire alarm control unit and the specific subunit or module to which they are connected. If the detectors and the units or modules are not compatible, it is possible that, during an alarm condition, the detector's visible indicator will illuminate, but no change of state to the alarm condition will occur at the fire alarm control unit. Incompatibility can also prevent proper system operation at extremes of operating voltage, temperature, and other environmental conditions. Where two or more two-wire detectors with integral relays are connected to a single initiating device circuit and their relay contacts are used to control essential building functions, e.g., fan shutdown, elevator recall, it should be clearly noted that the circuit might be capable of supplying only enough energy to support one detector relay combination in an alarm mode. If control of more than one building function is required, each detector relay combination used to control separate functions should be connected to separate initiating device circuits, or they should be connected to an initiating device circuit that provides adequate power to allow all the detectors connected to the circuit to be in the alarm mode simultaneously. During acceptance and reacceptance testing, this feature should always be tested and verified. A speaker is an alarm notification appliance and, if used as shown in the diagrams in A.2, The principle of operation and supervision is the same as for other audible alarm notification appliances, e.g., bells and horns. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 105 SB2 to 2010 page 106 The testing of supervised remote relays is to be conducted in the same manner as for notification appliances. A.2 Wiring diagrams. When testing circuits, the correct wiring size, insulation type, and conductor fill should be verified in accordance with the requirements of NFPA 70, National Electrical Code. A.2.1 Non-powered alarm initiating or supervisory initiating devices, e.g., manual station or valve supervisory switch connected to style A, B, or C initiating device circuits. Disconnect conductor at device or control unit, then reconnect. Temporarily connect the ground to either leg of conductors, then remove ground. Both operations should indicate audible and visual trouble with subsequent restoration at control unit. Conductor to conductor short should initiate alarm. Style A and Style B, Class B indicate trouble. Style C, Class B. Style A, Class B does not initiate alarm while in trouble condition. See Figure A.2.1. Figure A.2.1 Non-powered alarm initiating or supervisory initiating devices connected to style A, B, or C initiating device circuits. A.2.2 Non-powered alarm initiating or supervisory initiating devices connected to style D or E initiating device circuits. Disconnect a conductor at a device at midpoint in the circuit. Operate a device on either side of the device with the disconnected conductor. Reset fire alarm control unit and reconnect conductor. Repeat test with the ground applied to either conductor in place of the disconnected conductor. Both operations should indicate audible and visual trouble, then alarm or supervisory indication with subsequent restoration. See Figure A.2.2. Figure A.2.2 Non-powered alarm initiating or supervisory initiating devices connected to style D or E initiating device circuits. A.2.3 Circuit-powered, 2-wire smoke detectors for style A, B, or C initiating device circuits. Remove smoke detector where installed with plug-in base or disconnect conductor from fire alarm control unit beyond first device. Activate smoke detector per manufacturer's published instructions between fire alarm control unit and circuit break. Restore detector or circuit, or both. Fire alarm control unit should indicate trouble where fault occurs and alarm where detectors are activated between the break and the fire alarm control unit. See Figure A.2.3. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 107 Figure A.2.3 Circuit-powered, 2-wire smoke detectors for style A, B, or C initiating device circuits. A.2.4 Circuit-powered, 2-wire smoke detectors for style D or E initiating device circuits. Disconnect conductor at a smoke detector or remove where installed with a plug-in base at midpoint in the circuit. Operate a device on either side of the device with the fault. Reset control unit and reconnect conductor or detector. Repeat test with the ground applied to either conductor in place of the disconnected conductor or removed device. Both operations should indicate audible and visual trouble, then alarm indication with subsequent restoration. See Figure A.2.4. Figure A.2.4 Circuit-powered, 2-wire smoke detectors for style D or E initiating device circuits. A.2.5 Combination alarm initiating device and notification appliance circuits. Disconnect a conductor either at indicating or initiating device. Activate initiating device between the fault and the fire alarm control unit. Activate additional smoke detectors between the device first activated and the fire alarm control unit. Restore circuit, initiating devices, and fire alarm control unit. Confirm that all notification appliances on the circuit operate from the fire alarm control unit up to the fault and that all smoke detectors tested and their associated ancillary functions, if any, operate. See Figure A.2.5. Figure A.2.5 Combination Alarm Initiating Device and Notification Appliance Circuits. A.2.6 Combination Alarm Initiating Device and Notification Appliance Circuits arranged for operation with a single open or ground fault. Testing of the circuit is similar to that described in A.2.5. Confirmed that all notification appliances operate on either side of fault. See Figure A.2.6. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 108 Figure A.2.6 Combination Alarm Initiating Device and Notification Appliance Circuits arranged for operation with a single open or ground fault. A.2.7 Style A, B, or C circuits with 4-wire smoke detectors and an end-of-line power supervision relay. Testing of the circuit is similar to that described in A.2.3 and A.2.4. Disconnect a leg of the power supply circuit beyond the first device on the circuit. Activate initiating device between the fault and the fire alarm control unit. Restore circuits, initiating devices, and fire alarm control unit. Audible and visual trouble should indicate at the fire alarm control unit where either the initiating or power circuit is faulted. All initiating devices between the circuit fault and the fire alarm control unit should activate. In addition, removal of a smoke detector from a plug-in type base can also break the power supply circuit. Where circuits contain various powered and non-powered devices on the same initiating circuit, verify that the non-powered devices beyond the power circuit fault can still initiate an alarm. A return loop should be brought back to the last powered device and the power supervisory relay to incorporate into the end-of-line device. See Figure A.2.7. Figure A.2.7 Style A, B, or C circuits with 4-wire smoke detectors and an end-of-line power supervision relay. A.2.8 Style A, B, or C initiating device circuits with 4-wire smoke detectors that include integral individual supervision relays. Testing of the circuit is similar to that described in A.2.3 with the addition of a power circuit. See Figure A.2.8. Figure A.2.8 Style A, B, or C initiating device circuits with 4-wire smoke detectors that include integral individual supervision relays. A.2.9 Alarm notification appliances connected to style W and Y, 2-wire circuits. Testing of the notification appliances connected to style W and style Y, Class B, is similar to that described in A.2.3. See Figure A.2.9. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB 2/2010 page 109 Figure A.2.9 Alarm notification appliances connected to styles W and Y, 2-wire circuits. A.2.10 Alarm notification appliances connected to style X and Z, 4-wire circuits. Testing of the notification appliances connected to style X and style Z, Class B and Class A is similar to that described in A.2.4. See Figure A.2.10. Figure A.2.10 Alarm notification appliances connected to style X and Z, 4-wire circuits. A.2.11 System with a supervised audible notification appliance circuit and an unsupervised visible notification appliance circuit. Testing of the notification appliances connected to style X and style Z, Class B and Class A is similar to that described in A.2.4. See Figure A.2.11. Figure A.2.11 Supervised audible notification appliance circuit and an unsupervised visible notification appliance circuit. A.2.12 System with supervised audible and visible notification appliance circuits. Testing of the notification appliances connected to style X and style Z, Class B and Class A is similar to that described in A.2.4. See Figure A.2.12. Figure A.2.12 Supervised audible and visible notification appliance circuits. A.2.13 Series Notification Appliance Circuit, which no longer meets the requirements of NFPA 72. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 110. An open fault in the circuit wiring should cause a trouble condition. See Figure A.2.13. Figure A.2.13 Series Notification Appliance Circuit. A.2.14 Supervised Series Supervisory Initiating Circuit with Sprinkler Supervisory Valve Switches connected, which no longer meets the requirements of NFPA 72. An open fault in the circuit wiring of operation of the valve switch, or any supervisory signal device, should cause a trouble condition. See Figure A.2.14. Figure A.2.14 Supervised Series Supervisory Initiating Circuit with Sprinkler Supervisory Valve Switches connected. A.2.15 Initiating Device Circuit with Parallel Water Flow Alarm Switches and a Series Supervisory Valve Switch, which no longer meets the requirements of NFPA 72. An open fault in the circuit wiring or operation of the valve switch should cause a trouble signal. See Figure A.2.15. Figure A.2.15 Initiating Device Circuit with Parallel Water Flow Alarm Switches and a Series Supervisory Valve Switch. A.2.16 System connected to a Municipal Fire Alarm Master Box Circuit. Disconnect a leg of Municipal Circuit at Master Box. Verify alarm sent to Public Communications Center. Disconnect leg of Auxiliary Circuit. Verify trouble condition on Control Unit. Restore circuits. Activate Control Unit and send alarm signal to Communications Center. Verify Control Unit in trouble condition until Master Box reset. See Figure A.2.16. Figure A.2.16 System connected to a Municipal Fire Alarm Master Box Circuit. A.2.17 Auxiliary Circuit connected to a Municipal Fire Alarm Master Box. For operation with a Master Box, an open or ground fault, where ground detection is provided on the circuit, should result in a trouble condition at the fire alarm control unit. A trouble signal at the fire alarm. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 111 Control unit should persist until the master box is reset. For operation with a shunt trip master box, an open fault in the auxiliary circuit should cause an alarm on the municipal system. See Figure A.2.17. Figure A.2.17 Auxiliary circuit connected to a municipal fire alarm master box. A.3 Circuit styles. Some testing laboratories and authorities having jurisdiction permit systems to be classified as a Style 7, Class A by the application of two circuits of the same style operating in parallel. An example of this is to take two series circuits, either Style 0.5 or Style 1.0, Class B, and operate them in parallel. The logic is that if a condition occurs on one of the circuits, the other parallel circuit remains operative. To understand the principles of the circuit, alarm receipt capability should be performed on a single circuit, and the style type, based on the performance, should be indicated on the record of completion. A.3.1 Style 0.5. This signaling circuit operates as a series circuit in performance. This is identical to the historical series audible signaling circuits. Any type of break or ground in one of the conductors, or the internal of the multiple interface device, and the total circuit is rendered inoperative. To test and verify this type of circuit, either a conductor should be lifted or an earth ground should be placed on a conductor or a terminal point where the signaling circuit attaches to the multiplex interface device. A.3.2 Style 0.5 A, Class B series. Style 0.5 A functions so that, when a box is operated, the supervisory contacts open, making the succeeding devices non-operative while the operating box sends a coded signal. Any alarms occurring in any successive devices will not be received at the receiving station during this period. See Figure A.3.2. Figure A.3.2 Style point 5 A, Class B Series. A.3.3 Style point 5 B, Class B Shunt. The contact closes when the device is operated and remains closed to shunt out the remainder of the system until the code is complete. See Figure A.3.3. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 112 Figure A.3.3 Style point 5 B, Class B Shunt. A.3.4 Style point 5 C, Class B Positive Supervised Successive. An open or ground fault on the circuit should cause a trouble condition at the control unit. See Figure A.3.4. Figure A.3.4 Style point 5 C, Class B Positive Supervised Successive. A.3.5 Style 1.0 Class B. This is a series circuit identical to the diagram for Style point 5, except that the fire alarm system hardware has enhanced performance. See Figure A.3.5 A and Figure A.3.5 B. A single earth ground can be placed on a conductor or multiplex interface device, and the circuit and hardware will still have alarm operability. If a conductor break or an internal fault occurs in the pathway of the circuit conductors, the entire circuit becomes inoperative. To verify alarm receipt capability and the resulting trouble signal, place an earth ground on one of the conductors or at the point where the signaling circuit attaches to the multiplex interface device. One of the transmitters or an initiating device should then be placed into alarm. Figure A.3.5 A Style 1.0 Class B. Figure A.3.5 B Typical transmitter layout. A.3.6 Typical McCullough loop. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 113. This is the central station McCullough redundant type circuit and has alarm receipt capability on either side of a single break. See Figure A.3.6. Figure A.3.6 Typical McCullough loop. A.3.6.1 To test, lift one of the conductors and operate a transmitter or initiating device on each side of the break. This activity should be repeated for each conductor. A.3.6.2 Place an earth ground on a conductor and operate a single transmitter or initiating device to verify alarm receipt capability and trouble condition for each conductor. A.3.6.3 Repeat the instructions of A.3.6.1 and A.3.6.2 at the same time, verify alarm receipt capability, and verify that a trouble condition results. A.3.7 Style 3.0 Class B. This is a parallel circuit in which multiplex interface devices transmit signal and operating power over the same conductors. See Figure A.3.7. The multiplex interface devices might be operable up to the point of a single break. Verify by lifting the conductor and causing an alarm condition on one of the units between the central alarm unit and the break. Either lift a conductor to verify the trouble condition or place an earth ground on the conductors. Test for all the valuations shown on the signaling table. On ground fault testing, verify alarm receipt capability by actuating a multiplex interface initiating device or a transmitter. Figure A.3.7 Style 3.0 Class B. A.3.8 Style 3.5 Class B. Repeat the instructions for Style 3.0 Class B and verify the trouble conditions by either lifting a conductor or placing a ground on the conductor. See Figure A.3.8. Figure A.3.8 Style 3.5 Class B. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB 2 to 2010 page 114 A.3.9 Style 4.0 Class B. Repeat the instructions for Style 3.0 Class B and include a loss of carrier where the signal is being used. See Figure A.3.9. Figure A.3.9 Style 4.0, Class B. A.3.10 Style 4.5, Class B. Repeat the instructions for Style 3.5, Class B. Verify alarm receipt capability while lifting the conductor by actuating a multiple interface device or transmitter on each side of the brake. See Figure A.3.10. Figure A.3.10 Style 4.5, Class B. A.3.11 Style 5.0, Class A. Verify the alarm receipt capability and trouble enunciation by lifting the conductor and actuating a multiplex interfacing device or a transmitter on each side of the brake. For the earth-ground verification, place an earth-ground and certify alarm receipt capability and trouble enunciation by actuating a single multiplex interfacing device or a transmitter. See Figure A.3.11. Figure A.3.11 Style 5.0, Class A. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. A.3.12 Style 6.0, Class A. Repeat the instructions for Style 2.0, Class A through C. Verify the remaining steps for trouble enunciation for the various combinations. See Figure A.3.12. Figure A.3.12 Style 6.0, Class A. A.3.13 Style 6.0 with circuit isolators, Class A. For the portions of the circuits electrically located between the monitoring points of circuit isolators, follow the instructions for a Style 7.0, Class A circuit. It should be clearly noted that the alarm receipt capability for remaining portions of the circuit protection isolators is not the capability of the circuit but is permitted with enhanced system capabilities. See Figure A.3.13. Figure A.3.13 Style 6.0 with circuit isolators, Class A. A.3.14 Style 7.0, Class A. Repeat the instructions for testing of Style 6.0, Class A for alarm receipt capability and trouble enunciation. See Figure A.3.14A through Figure A.3.14K. Note: a portion of the circuit between the alarm processor or central supervising station and the first circuit isolator does not have alarm receipt capability in the presence of a wire-to-wire short. The same is true for the portion of the circuit from the last isolator to the alarm processor or the central supervising station. Note: some manufacturers of this type of equipment have isolators as part of the base assembly. Therefore, in the field, this component might not be readily observable without the assistance of the manufacturer's representative. Figure A.3.14A Style 7.0, Class A. SB2 to 2010 page 115, copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 116 Figure A.3.14B Low Power Radio Wireless Fire Alarm System. Figure A.3.14C 2ARF Multiplex Systems. Figure A.3.14D One-Way Radio Alarm System. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 117 Figure A.3.14E One-Way Radio Alarm System, Type 6 and Type 7. Figure A.3.14F Style 4 Fiber Network. Figure A.3.14G Style 4 Fiber Network, Single Break. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010 page 118 Figure A.3.14H Style 4 Fiber Network, Double Break. Figure A.3.14I Style 7 Fiber Network, 2 Lens. Copyright sign Copyright 2010 by the National Electrical Manufacturers Association. Figure A.3.14J Style 7 Fiber Network, 1 LAN. Figure A.3.14K Style 7 Fiber Network. To maximize battery life, nickel-cadmium batteries should be charged as in Table A.4a. Table A.4a Voltage for nickel-cadmium batteries. Float voltage 1.42 volt, cell plus 0.01 volt. High rate voltage 1.58 volt, cell plus 0.07 volt. 0.00 volt. Note: high and low gravity voltages are plus 0.07 volt and 0.03 volt, respectively. SB2 to 2010, page 119. A.4 Batteries. To maximize battery life, the battery voltage for lead-acid cells should be maintained within the limits shown in Table A.4b. Copyright sign. Copyright 2010 by the National Electrical Manufacturers Association. SB2 to 2010, page 120. Float voltage maximum minimum high rate voltage. Table A.4b Voltage for lead-acid batteries. High gravity battery, lead calcium 2.25 volt, cell 2.20 volt, cell. Low gravity battery, lead antimony 2.17 volt, cell 2.13 volt, cell 2.33 volt, cell. The following procedure is recommended for checking the state of charge for nickel-cadmium batteries. 1. The battery charger should be switched from float to high rate mode. 2. The current, as indicated on the charger ammeter, will immediately rise to the maximum output of the charger, and the battery voltage, as shown on the charger voltmeter, will start to rise at the same time. 3. The actual value of the voltage rise is unimportant, because it depends on many variables. The length of time it takes for the voltage to rise is the important factor. 4. If, for example, the voltage rises rapidly in a few minutes, then holds steady at the new value, the battery is fully charged. At the same time, the current will drop to slightly above its original value. 5. In contrast, if the voltage rises slowly and the output current remains high, the high rate charge should be continued until the voltage remains constant. Such a condition is an indication that the battery is not fully charged, and the float voltage should be increased slightly.